202. In living beings must not be confused with the general harmony of nature. Although we admire an order and a plan in the arrangement of cosmic phenomena which leads us to recognize in it the work of an ordering intelligence, science as such, which has no means of probing the mystery of first causes, is by no means obliged to attribute any interdependent connections among the forces of nature which act as secondary causes in the production of general phenomena, any more than it has to accept them among the natural forces that man utilizes in a machine or a factory. Even though his intelligence has enabled him to adjust the parts and to combine the forces in such a way as to make them concur in accomplishing a given end. In such a case, the force inherent in each part of the system follows its own law no less than it would even though the other parts of the system did not exist. For example, we understand that the planets would continue to gravitate toward the Sun and to turn regularly around this star even if it were to cease to be a source of light and heat for them, just exactly as they do in the present arrangement of things in which the regularity of their movements appears to be so fully adapted to the manner in which they are influenced by the Sun's rays. Likewise, although a manifest harmony may be found between the organic structure of herbivorous animals and that of plants which are destined to serve them as food, it cannot be thought that the forces which actively concur in the germination and development of the plants have an influence, in a similarly active way and as plastic or efficient causes, on the organic structure of the animal or vice versa. But when we consider the animal itself, as an individual and distinct being, it is, on the contrary, impossible for us not to recognize an interrelation between the plastic forces which bring about the formation of the heart in one place and that of the lungs and brain in another, between the vital actions which fashion the tissues and bodily fluids, and those which must ultimately excite the tissues and employ the secreted fluids in the animal as a whole, between the acts which provide for the accomplishment of a function and those by which the function is carried out. It is, then, no longer a question of a harmony which may be attributed to a providential coordination or to a fortuitous combination, but to an immediate, active, and determinative influence, which rests on secondary causes, and which is exercised by forces to whose energy we immediately relate the production of the phenomena which we witness. This definite connection, or this marvelous consensus between vital forces and actions, is what makes it legitimate to call them plastic or selective forces in matters having to do with the phenomena of organic life, and instinctive actions when we are considering more particularly the relational functions, or in general all those which pertain to animal life. But consciousness brings to light only our voluntary and reflective resolutions, while the senses and the imagination show us only mechanical effects. Therefore, we find we are absolutely unable to have even an imperfect notion or image of the operations of an active principle of which we know nothing except that it acts with inevitable necessity, without knowledge and without freedom, revealing itself by means of products which are much superior to anything that a mechanism could bring about, and superior even to those that the intellect of man is able to attain through reflective arrangements. 8. 133 As a result of improperly comparing the principle of the harmonic unity of living things, that is to say, the very principle of life, to the principle, whatever it may be, of the general harmony of nature, philosophers have from the most ancient times compared the world in all its immensity to a living being, while physicians and physiologists have taken pleasure in referring to man as a microcosm, a term which could be applied equally well to any other animal as to man. But such a comparison does nothing more than indicate a complete misconception of the profound distinction between mechanisms and organisms, between inanimate nature and animate nature. The world is not a gigantic animal, but a great machine, each part of which obeys its own law and the force with which it is individually endowed. So the reason for the harmonious concourse of the parts must be sought for elsewhere than in the essence of these forces themselves and in their productive capacity. Likewise, the animal is not simply a little world, that is to say, a little machine included in the larger one, but a being which contains its own principle of unity and harmonic activity, awaiting only suitable external stimuli and a favorable disposition of the surrounding environment before it unfolds. Nevertheless, it must be fully recognized that the bonds of organic unity and interdependence show themselves to be more or less limited or extended, depending on the particular case. In this respect a plant is not comparable to an animal, nor a lower animal to a higher one which nature has endowed with a more complex and more perfect organization. Among the most perfect animals themselves, there are some organs or systems of organs whose sensitivity is more lively, and others which carry out their role in the total organism with more individual independence. In compound animals and double monsters, the organisms interpenetrate in such a way as to confuse the ideas that normal and ordinary cases suggest to us as to the independence of organic beings, and the interconnection of their constituent parts. 134 Finally, the contrast between purely physical phenomena and those that living beings reveal to us follows from the manner in which we conceive physical forces. They are assumed to be inherent in material particles as their permanent and indestructible substratum. The property of vital and plastic forces to which reason tells us the harmonic unity of organic beings must be related, in conformity with the type of each species and with the natural disposition for hereditarily transmissible variations, cannot be conceived of as adhering in a fixed and immutable manner to any material substratum, whether simple or compound. Thus, all the difficulties and all the mysteries with which philosophers have been preoccupied, especially with regard to those which have human consciousness for their setting and which give rise to voluntary and reflective acts, become visible on the threshold of physiology. It is not only for phenomena of this order, which are the highest of all, but for all functions of life, that the harmonic unity and formative energy which are always closely connected with organic dispositions and physical stimuli may not, after the manner of physical forces, be considered attached to a material substratum, whether simple or complex, to a molecule or to a system of molecules. This necessarily results in a lack of coherence in the systematic ordering of our conceptions and an interruption in their theoretical concatenation when we pass from the description or explanation of physical phenomena to the description or explanation of phenomena which are produced in the womb of living nature. That is why, in natural history, it is so impossible to conceive the first appearance of living beings, and the formation of the first organism which has not come from some pre-existing organism, as, for example, we conceive without any difficulty the formation of crystals and the first manifestation of chemical phenomena arising from the gradual concentration of nebulous matter scattered in celestial space. In fact, just as soon as the forces to which we attribute the power of producing physical phenomena are considered inherent in the ultimate particles of matter, as though this were their substratum, we have no difficulty in admitting that they reside in it in a permanent manner whether or not circumstances permit them to produce sensible effects. In this situation it is unnecessary to have recourse to an intervention of creative 206 power to endow the material particles with forces or properties of this kind, even at the moment these forces first come into play. In other words, the origin or beginning of chemical phenomena is in no way mysterious to us, although the essence of chemical forces, like the essences of all things, is necessarily hidden from all our investigations. On the contrary, a veil of mystery cloaks and must necessarily cloak not only the origin of living forms in general, but the origin of each living species and the causes of the differences between species according to time and place. On the one hand, observation leaves no doubt that these species have not always existed, on the other hand, the data of observation are no less incompatible with our admitting a spontaneous development, a creation out of nothing, and the producing of animals and plants by means other than those of ordinary generation. Thus we see that the scientists who are the least inclined to have recourse to supernatural explanations would not think of using the word creation to designate the formation of minerals and rocks, of strata and veins of ore, of deposits of coal and columns of basalt. They know that in the production of all these objects, even when actual circumstances preclude the production of them at the present time, we have no difficulty recognizing the action of physical forces which are still actually inherent in matter. However, these scientists do use the terms animal or vegetable creation to denote the aggregate of species characteristic of a region or of a geological period. They do not mean by this to make an appeal to a supernatural intervention, but simply to note that we find it equally impossible to admit, on the one hand, the endless duration of the order of phenomena that the whole gamut of living things presents to us, and to conceive, on the other hand, of the natural beginning of these phenomena. The matter at issue here is not a problem of metaphysics, such as that of knowing whether or not the world is eternal, whether matter is created or uncreated, whether order is the result of providence or chance. The issue is that of a purely physical or biological question which bears upon facts falling within the compass of the world we perceive and of periods of time of which we may, and in fact do, have extant monuments. Here is a real gap in the system of our knowledge, a gap that reason feels the need of closing, but which it is unable to close precisely because it is not possible for us to reconcile our ideas about matter and those concerning the manner in which vital forces act by giving them a material substratum, and by relating them to the forces which produce the most general phenomena of the sensible world. 135. Now, what value must be attributed to the idea of a substratum or substance which introduced the incoherence we have indicated? Whatever one may say of it, this abstract and general idea, which is the first of the categories of Aristotle, the cornerstone of many systems and the basis of all that we call ontology, has no prerogative which puts it beyond critical examination. It also asks to be judged by its works, that is to say, by the order and connection it introduces into the system of our knowledge, or through the difficulties it produces therein and the conflicts to which it gives rise. This idea of substance comes originally from the knowledge we have of our identity as persons in spite of the continual changes that age, experience of life, and accidents of all sorts contribute to our ideas, our feelings, and our judgments, and to the judgments that others pass on to us. Therefore, the idea comes naturally from the nature of the human mind, as the structure of language proves. But when we use this idea, which is entirely devoid of sensible elements, to connect phenomena which can be perceived, reason could doubt the legitimacy of its application beyond ourselves if experience did not indicate that there is in fact something in bodies that persists in spite of all changes of form, of molecular condition, of chemical composition, and of organization. These evidences from experience are sufficient to establish that the idea of substance, in the application that we make of it to bodies and to ponderable matter, is not simply a logical abstraction, a fiction of our minds. On the contrary, the reason and the basis for it are found in the essence of bodies. This is true even though we may be condemned to remain in perpetual ignorance as to what this essence is, and even though those formed and extended bits of matter which we have found it agreeable to imagine, or rather that we find it necessary to imagine as a substratum for material phenomena and for the forces which produce them, are only purely hypothetical and may even be contradicted by all the evidence of reason. When we extend this idea of material substance or substratum by analogy to agents that we call imponderable, our experience is deficient, at least up to the present time. We observe phenomena, we discern laws, but nothing assures us that a systematization of 208. These phenomena and their laws which would be found to imply the idea of substance is anything but an artificial systematization. Experience might always have left us just as ignorant in regard to ponderable bodies as it leaves us in regard to imponderable agents. To tell the truth, we were as ignorant in the one case as in the other of the true basis of the idea of substance as long as physics remained in swaddling clothes, and as long as we had no means of establishing, notwithstanding certain crude and deceptive appearances, that there is no real loss of substance, that is to say, of mass and of weight, in the innumerable transformations which we can watch matter undergo. This does not stand in the way of observing the sequential order and the interconnection of phenomena in regard to ponderable bodies, 9 as we still do for phenomena attributed to imponderable agents, and it would be a great mistake to say that without the idea of substance the spectacle of nature becomes nothing but a phantasmagoria. On this basis, those parts of physics which have to do with light, electricity, and heat would still exhibit to the mind no definite limits and no actual reality, and would have to be regarded as erudite phantasmagoria, while the phantasmagoria is found, on the contrary, only in that artificial portion of our theories in which the imagination, transcending the limits of experience, creates fictions that reason accepts provisionally, but only in the guise of scaffolding and of auxiliary symbols. If the rigorous procedures of experimentation, which are a product of the genius of modern thinkers, had contradicted the application of the notion of substance, even as related to ponderable bodies, if it had been fully established that there are certain circumstances in which mass and weight are destroyed, as there are in which vital force is destroyed, the circumstances under which this destruction takes place would have to be defined. But ponderable bodies would not, for that reason, have ceased to present us with the spectacle of well-ordered phenomena bene ordinata, as Leibniz puts it. Only we should have a better asterisk and more decisive argument for condemning the hypothesis of those formed and extended atoms that our reason already has so many reasons for rejecting, but that our imagination is still unable to give up. 136. The difficulty that we should experience in making this supposition, in conceiving physical forces which do not adhere to a material substratum, that is to say, by definition, which do not adhere to a physical atom or to a system of such atoms which have form and extension, is exactly what we experience in conceiving vital or plastic forces. This is so because matter and form seem to change roles in the passage from the phenomena of the inorganic world to those of animate nature. The persistence to a certain extent of the form or type takes the place of the persistence of mass and of weight, and the variability or even within certain limits again the neutrality of the material follows the variability or neutrality of the forms. It is to escape this difficulty that hypotheses have been formulated in the different epochs of science which today have been judiciously examined and are definitely condemned, such as those of spontaneous generation, of special creation, and others like them. We have not entered into detailed explanations of such hypotheses, which lie within the field of the anatomist and the physiologist rather than that of the logician and metaphysician. It is necessary to confess this difficulty, and even to recognize that it is insurmountable, since it arises from a contradiction between certain laws of nature and certain tendencies of the human mind. But it must not be further exaggerated. As we have already shown, ordinary physics is itself not free from analogous difficulties and contradictions. And if in certain cases the metaphysical notion of substance becomes a source of insoluble contradictions, would reason not have the right to condemn the far-fetched applications of it to some type of phenomena that one might wish to make, simply because reason is completely aware that this notion has its root in the human mind and that it directs the organization of human language? We saw above other examples of contradictions that spring from the same cause, and with respect to which we felt that it was necessary to draw the same consequence, however harsh this may appear to certain minds, however abstruse or however trifling it may seem to others. Chapter X. On Ideas of Space and Time. 137. We believe that in chapters 7 and 8 we have demonstrated that the senses contribute directly to a knowledge of the external world only in so far as they give us the representation of extension. We have further seen that this representative power is linked with the form of sensation because it is through the form alone that there is homogeneity between sensations and the external causes of the impression produced. But we do not conceive the extended only as a property of material aggregates or of bodies which fall under the senses. We also conceive of extension as the place occupied by bodies, as the space in which bodies move and in which all the phenomena of the external world occur. This idea is such, or seems to us to be such, that it would still have an object even though bodies should cease to exist, even though the phenomena for which space is the stage should cease to be produced. Likewise, our sensations have the essential quality of duration, the memory of them persists or lasts even after the organs of sense have ceased to be affected by impressions from external objects. The phenomena of the external world, of which sensations give us knowledge, themselves have a duration, and from the notion of the duration of phenomena we go on to the idea of the time in which these phenomena are arranged and brought about. This idea is such, or seems to us to be such, that it would still have an object even though the phenomena of the external world should be hidden from our knowledge or cease to be produced. It also seems that this object would not be destroyed by our own destruction, by the suppression of that sequential order of the affections and of the internal phenomena which endure and which follow one another in us. The two fundamental ideas of space and time are, therefore, not merely elements of the knowledge of the external world. They surpass this knowledge, and it is from this point of view that we consider them here. They manifest themselves to intelligence through objects which have a character of necessity that other ideas by means of which we conceive the external world do not have. On the basis of these ideas of space and time, thought of as having this character of necessity which imposes itself upon the human mind, rest the sciences which are capable of a priori construction and which borrow nothing from experience, which are independent of the consideration of the phenomena of the external world, and in the study of which images derived from the external world would serve only to aid the work of the mind without having any effect upon the body of the doctrine. Is this characteristic of necessity apparent or real? Does it pertain to the nature of things or to the nature of the human mind? Are the ideas of space and time nothing but ways in which the mind sees things, nothing but laws of its constitution? Or, on the contrary, do these ideas have a representative and objective value, and, if this is the case, what do they represent? There is no philosophical system to which the answers to these questions would not serve as a sort of a key. There is no philosophical question of any great interest which does not terminate at some point in questions to which these fundamental ideas give rise. We do not as yet wish to examine whether these questions can be resolved or whether they transcend the power of reason, whether the discussions of philosophers have clarified or confused them. What, as we see it, should be a clear result and the fruit of these discussions is the perfect analogy, the exact symmetry that all these questions present in regard to space and time, and present in such a way that the solution given or accepted for one of these fundamental ideas may, for that very reason, be given or accepted for the other, in all schools and in all systems. 138. Thus when Newton and Clarke admit the representative value of the idea of time in all its fullness, they are led to admit it for the idea of space. According to them, neither space nor time can be conceived as substances, they are the attributes of a substance. And, because the ideas of space and time are invested with characteristics of necessity and infinity, they are attributes of necessary and infinite being. Time is the eternity of God, space is his immensity. The rigorous spiritualism, the religious faith of these great men may have vainly protested against the intention of giving extension and parts to the divine substance, the force of analogy carried them away. 212. Also, when Leibniz submits the two ideas of space and time to critical examination, based upon his principle of sufficient reason, the result of the test is the same for one as for the other. Neither space nor time can have an absolute existence. This is no more possible when they are dealt with as attributes of divine substance than when they are regarded as created substances. For, all parts of space being perfectly similar, there would be no reason why the world, thought of as finite, should have occupied a certain portion of infinite space rather than any other. And if the world is infinite, the whole universe could always be conceived as changing its position in absolute space while the parts of the system continued to maintain their relative positions, so that there would never be any reason why each element of it should have occupied a certain absolute place rather than another. Similarly, all the parts of time being perfectly similar, there would be no reason why the duration of the universe, if this duration is finite, should have corresponded to any given portion of absolute time rather than to another. And, if the world has neither beginning nor end, it would always be possible to conceive a displacement of the whole series of phenomena in absolute time which would not disturb their relative dates. Thus there would be no reason why each phenomenon should have been produced at a certain instant rather than at some other. Therefore, neither space nor time can have an absolute existence, space is nothing but the order of coexistent phenomena, time is only the order of successive phenomena. Do away with phenomena, and the idea of space, like that of time, no longer has an object. Therefore, as a third and last example, when Kant, taking the converse of Newton's theory, refuses to allow any objective value to the idea of space, he does the same for the idea of time. Space and time are, for him, only forms of human sensibility, subjective conditions for the intuition of phenomena. Neither the idea of space nor the idea of time corresponds to the order of things as coexistent or sequential. They correspond to the order according to which the representations of things must be arranged in order to become objects of our intuition. One should read the celebrated correspondence between Leibniz and Clarke. This may be taken as a model of dialectic. In it one follows in detail the analogy of which we are only delineating the principal traits. Let us affirm once more that the question is 213. Not one of championing a side in these metaphysical systems, it is not even one of knowing whether the pretension of having a system or a side to take in such matters is chimerical or not. Our problem is simply that of establishing an analogy, a correlation which should follow from the nature of things and not from our systems, since it shows itself in the most contrary systems. 139. The analogy in question is even more remarkable since it is not drawn from matters dealing with the psychological origin of the ideas of space and time and the nature of the sensory images which help us to conceive them. This contrast clearly proves that we have the capacity to raise ourselves above laws which follow from our own nature and from the organic conditions of thought, in order to apprehend relations which subsist among objects themselves and which follow from their intrinsic nature. Psychologically, and because of a peculiar quality inherent in the formation of our senses, as has been explained for us, extension is the object of an immediate intuition, of a direct representation. The device of illusions and symbols is necessary so that duration may become the object of our intuition. We imagine extension by means of the concurrence of sensible images which are naturally associated with it, but we are able to imagine duration only by attributing to extension a property representing duration. We align, so to speak, the successive phenomena, until we finally get an image and through that an idea of their positional order in time. This work of the mind manifests itself in the form of language. Antia and postia, which refer to order in time, are derived from ante and post, which are more immediately related to spatial order. And, it is also generally true, for the perception of ideas of which sensibility does not furnish us immediate images, that we are obliged to combine images which have representative efficacy only indirectly and at second hand, so to speak, through the aid of analogies that reason grasps between things that are otherwise heterogeneous. This is the basis for the establishing of symbols and the principle of human perfectibility. Animals seem to us to have only a very obscure perception of relations of time, of duration, and of all that goes along with them. 1. This seems to be true even of animals which most closely resemble man. In fact, it may be said that the senses have been given to man and to animals simply for the purpose of directing them in space. On the contrary, the practical use of reason is, for the most part, to guide man in time, to coordinate his acts in view of accomplished facts and of future circumstances. Since this superior destiny and these higher faculties have been denied to animals, the clear perception of time becomes superfluous for them. And since, even among the animals that are most like man, the faculty for perceiving time has remained and has had to remain in a rudimentary state, it has not been able, even in man himself, to attain the representative clarity which is characteristic of the idea of space. For in everything connected with the development of vital powers we observe that nature propagates variety without losing sight of a common plan in the whole series of living things, developing in one species what is only rudimentary in another or in all others, rather than creating out of whole cloth that of which not even the germ exists elsewhere. As for the perception of space, the innumerable species of animals evidently have it in very different degrees, depending upon their position in the scale of animal life. We always notice, in so far as induction enables us to deal with this problem, that the degree of this perception is perfectly suited to the sort of movements the animal in question ought to make as a result of its perceptions. Or rather, as has been explained, it is the act of movement itself which originally gives the animal a perception of space consistent with the functions it must satisfy. Animals have a more or less obscure and imperfect perception of space, but not a false one. Their perceptions are, to an appropriate degree, correct and conformable to external reality, and in addition are suited to the nature of acts which they must effectively carry out in space as a result of their perception. 140. The measurement of extension or of geometrical magnitudes is carried out by means of superposition, that is, by the most direct, the most sensible, and in some ways the most imperfect method of measuring. The measurement of duration is indirect and rests essentially upon a rational idea. We judge that the same phenomenon must be produced in the same interval of time, when all the circumstances remain the same in each recur 215. Rents of the phenomenon. Thus if nature reproduces, or if we are able to reproduce artificially, the same phenomenon in conditions which are perfectly alike, we believe with reason that we possess a temporal standard, or a chronometric unit, and we use it to measure the duration of all other phenomena. It is in this way that time or duration can be measured with a water clock too, by taking as the unit of duration the time required for the liquid or the fine sand with which the instrument is filled to flow from one section of it to another, and by setting up the principle, which is certain a priori, that the duration of the flow must be identical, if neither the mass of the substance with which it is filled, nor the vessel, nor the opening, nor any other purely physical conditions of the phenomenon have undergone any change. Yet we do not understand in a completely satisfying manner, either theoretically or experientially, the laws which govern the duration and the phases of the flow. The phenomenon whose duration is taken as the standard for time is, ordinarily, a periodic movement which is as uniform as possible, in order that the aliquot parts of the period may correspond to equal portions of the duration. But it is a mistake to regard the phenomenon of motion as the essential condition of the measurement of time. Yet this has often been done. The unit of time might be the time that a body of clearly defined substance, form, and dimensions requires to pass from one temperature to another in a medium the temperature and other physical conditions of which may be exactly defined. The duration of a physiological, or even of a psychological phenomenon, could furnish a standard of time, if it were capable of being reproduced indefinitely under perfectly identical circumstances, and in such a way that the repetition would not modify the conditions of the phenomenon. Perhaps it will be objected that, if reason posits a priori the general maxim that the duration of the same phenomenon must be the same in absolutely identical circumstances, we have no means of establishing this perfect identity with certainty in individual cases. But here again a judgment of reason intervenes, based upon probabilities which go so far as to exclude doubt. When the first astronomers compared the diurnal movement of the sun with that of the stars, they were in a position to raise the 216 question strictly speaking as to whether it was the duration of the solar day which remained constant and that of the sidereal day which varies, or the other way around. But before long many inferences led them to take the duration of the sidereal day as the fixed term, and when subsequently the whole theory of astronomical movements was seen to be interrelated according to regular laws by the hypothesis of this constant duration, while the hypothesis of the constancy of the solar day would have been the source of trouble and disorder with respect to these movements, there could no longer remain any doubt concerning the fundamental hypothesis of the invariability of the sidereal day. And even long before the laws of mechanics had given the immediate reason for the invariability of the rotational movement of the Earth, the period of which coincides with that of the sidereal day, all chronometers had to be regulated according to the movements of the stars, as all thermometers are regulated according to air temperature, and for an analogous reason. Thus, from every point of view, the measurement of time requires the intervention of rational principles. It follows from the notion of the reason and the order of things. On the other hand, the direct measurement of extension falls immediately under the senses. This is a circumstance worthy of attention and one which squares with the remark already made, that the understanding of time can only be confused and rudimentary so long as the faculty of perceiving the order and reason of things does not exist or exists only in rudimentary form. 141. In so far as they furnish the materials of a science, and of a science which can be constructed independently of experience, the ideas of space and time are still very dissimilar. Space has 3 dimensions, time has only one. 3 dimensions or 3 coordinates, as the mathematicians call them, are necessary to fix the position of a point which can be moved in space in any way. 2 are necessary if the point is restricted to remaining on a surface, for example on a plane or a sphere. Only 1 is necessary if the point can move only along a determined line. Thus the points of a path are fixed when the distances from some point along the path are fixed, such as the point of departure or the 0 point of the path. A point is fixed on the surface of the ocean when the latitude and the longitude are given. But, if the VM*217 object is above or below the surface, a third coordinate must be set up if we are to know its height above sea level or its depth below this level. On the contrary, in order to set the date of a phenomenon or its position in time, it is sufficient, as it is in order to fix the position of a point on a line, to assign a single dimension, namely, the elapsed time or the time which should elapse, between a given moment of time or an era taken as a reference point, and the instant when the phenomenon occurs. The infinite variety of relations of dimension, configuration, position, and order which are the subject matter of geometry are derived from the idea of space. The idea of time, on the other hand, taken in its extreme simplicity, cannot furnish the material for a theory which merits the name of a science, since it is not connected with the abstract conceptions of geometry or with other notions suggested by the experimental study of the physical world. 142. Having indicated the dissimilarities between them, let us turn to the analogies between these two ideas, and let us see whether our methods of critical philosophy have absolutely no hold on those abstruse questions which metaphysicians have raised concerning the great and fundamental ideas of space and time. Are not these ideas in fact, as Kant saw, only laws of the human mind, forms which must somehow shape the more particular ideas the material of which the sensibility furnishes to the understanding, rules by means of which the experience becomes possible which imparts knowledge to us of the existence of external objects? Is the fact of giving an objective value for the ideas of space and time, over and above that which follows from the nature of the human mind, an illusion of the same sort as that which makes us shift to trees on the shore, the movement of the ship upon which we are traveling, and to the system of the stars, the movement of the earth from which we observe them? But, if this were so, by what extraordinary chance could the phenomena which lie within the province of our understanding be connected in accordance with simple laws which imply the objective existence of time and space? For example, Newton's law, which makes astronomical phenomena so reasonable, implies the existence of time, space, and geometrical relations outside of the human mind. How can we admit that astronomical phenomena, which are so manifestly independent of the laws or the forms of 218 human intelligence, would be so simply and regularly coordinated in a system, which would, however, point to nothing outside of the mind, because the keystone of the system would be an intellectual, human fact, inappropriately carried over into the world in which astronomical phenomena occur? What is said of astronomical phenomena may be said of all those which science has reduced to regular and simple laws, and which appear, as a result of that simplicity itself, to follow very closely from the primordial laws that are hidden from us. Moreover, we are not, for that reason, limited to insisting on such inferences, however cogent they may be. We are able to penetrate, and we have actually penetrated more deeply into the nature of the act which enables us to understand space. The analysis of our intellectual faculties has enabled us, so to speak, to put our finger upon the correlation on which nature is founded and the processes it uses to give, not only to man, but also to the other animal species, the representation and perception of space, in proportion to their needs. The daring negation of Kant is found to be refuted in advance by that very analysis which makes evident to us the reason for the representative value of sensible impressions, as these pertain to the configuration and the geometrical relations of the objects from which these impressions emanate. There is no question of the fact that this does not result from categorical demonstrations, and we know that the system of the great German metaphysician regards as valueless everything that is not established by means of a logical demonstration. But reason refuses to follow this path, which necessarily terminates either in pure idealism or in the most absolute kind of skepticism, as everyone is aware. 143. Were we to go farther and follow the ontologists in their controversies as to the nature of space and time, we should undoubtedly run up against insoluble contradictions. Equally insurmountable difficulties are involved in regarding space and time either as substances or as attributes of substance. Nevertheless, it is clearly necessary in the ontological hierarchy that objects of our knowledge be grouped either among substances or among attributes of substance. But analogous contradictions do not necessarily testify against the objective value of the ideas of space and time. They are explained just as well and even better if it is. V. N *219. Admitted that ontological philosophy proceeds from an abstract principle when it undertakes to classify all the objects of knowledge as substances and attributes. This applies as much to the remarks that have already been made as it does to those which follow. Nothing in the human mind is clearer than the ideas of space and time and all that is connected with them, nothing in it is more obscure than the notion of substance and everything that we might wish to deduce from it. Accurate criticism requires that we do not judge what is clear by what is obscure. On the contrary, it is necessary that ideas which are inherently clear throw their light on the obscure regions of the field of knowledge, and help us to drive out the chimeras. The ideas of space and time are so inherently clear that they necessarily escape all definition. When Leibniz defines space as the order of coexistent things and time as the order of successive existences, it is perfectly clear that his definitions presupposed the idea of definite objects, and that we should apprehend nothing as to their nature if we did not have the idea of them prior to our definition. But, nevertheless, these definitions have philosophic meaning, since they indicate that the idea of order, in proportion to its generality, dominates the ideas of time and space, not only in the scale of logical abstractions but even more in that of rational conceptions. As a result, we find in the theory of order in general the reason for a great number of properties and relations that mathematicians had at first studied individually under the comparatively less abstract and the more sensible forms of space and time. 144. In having recourse to these definitions, Leibniz intended to express a still more important thought, namely, that if the ideas of space and time are not fantastic illusions or forms of our understanding, if, on the contrary, they have an objective and external reality, then this external reality must not be taken in an absolute sense but in a phenomenal and relative sense, if we may make use of a terminology which is not precisely that of Leibniz, but which W.R.E. believed to be preferable and the meaning and value of which we have undertaken to fix from the very beginning of this book. It is to these terms that we bring back the basis of the dispute between Leibniz and Clarke, although they themselves did not put it in dry logical form, because, in their discussions, they were especially interested in the questions of natural theology which were involved. Leibniz supported his theory by a priori arguments based upon the principle of sufficient reason, the probative force of which we, for our part, admit. But may there not be, in addition to these arguments, legitimate inferences which could corroborate these a priori arguments? There are in fact such instances, and of different sorts. In the first place, the two fundamental principles of dynamics, the principle of the inertia of matter and that of the proportionality of force to velocity, are both results of experience and could only be derived from experience in so far as we profess to affirm something as to the absolute or relative value of the ideas of space and time. But both principles of dynamics are also necessary consequences of the Leibnizian theory, which attributes only a phenomenal and relative value to the ideas of space and time. 3. Now if a law of nature has need of empirical proof, without prejudicing anything so far as the value of a philosophic principle is concerned, and if, on the other hand, the law is a necessary consequence of that principle itself, then, inversely, the experience which verifies the law will be reputed to give, a posteriori, the confirmation of the principle, or at least will serve as a powerful inference in favor of it. We could again bring up the remark already made as to the hypothesis of formed and extended atoms, namely, that if the ideas of space and time had real objects and absolute reality, our understanding would have been able to reach primitive and absolute reality through its own skill by these principles alone. However, we have very good reasons for believing that this would prove to be very improbable, although it is not impossible nor can it be proved that it is impossible. but we prefer to insist upon considerations of another kind, to which we more usually have recourse in inquiries of this sort. Let us admit that the mind has a tendency, as no doubt it has, to attribute absolute reality to what we conceive under the ideas of space and time. Let us also admit that this tendency may be deceptive. Very likely there will be incoherencies in the system of our ideas resulting from a lack of harmony between the nature of the objects of thought and the manner in which we think of them. Reciprocally, if incoherencies and obstacles are manifest in the system of our ideas because of the attribution of an absolute reality to ideas of space and time, it will be necessary to conclude from this, and with a probability of the same order, that these ideas do not have the objective value the human mind would like to accord them, because of a condition in its organization as a thinking subject. 145. Now, such oppositions and such conflicts exist with respect to the ideas of space and time, and give rise to what Kant has described as the antinomies of pure reason in the section which, to us, is the most remarkable part of his critical philosophy. For it is equally repugnant to think of the world as limited in space and as having a beginning and an end in time, as it is to think of it as having neither limits, nor beginning, nor end. This is the first antinomy. It is also equally repugnant to think either of a limit to the divisibility of matter, or to think of it as infinitely divisible. This is the second antinomy. Both the thesis and the antithesis may be proved equally well, and yet they contradict each other. Kant develops along the same lines two other antinomies of which we have no need to speak here. These antinomies, or, to use less technical language, these contradictions, are real. It is not necessary to appeal to arguments based on the scholastic doctrine of universals to be struck by their force. We need only to survey the works of philosophers to be caught up in the interminable debate concerning them. But, as we see it, they are not contradictions of reason, but of the human mind, which is something quite different. For, if reason cannot contradict itself without losing its unity and its regulative authority, it is perfectly comprehensible that in the complex organization of the human mind taken as a whole, there may be elements capable of contradicting each other, that the understanding, as a result of the way in which it elaborates and relates materials furnished to it by the senses, may have its own illusions, like those found in sensations and in certain spontaneous judgments which are continually associated with sensations and which reason disavows. This is the only plausible motive that could have made Kant wish to refuse any objective value to the ideas of space and time and to consider them only as forms of the sensibility. But in this he goes too far, for it is sufficient to admit with Leibniz that space and time are phenomena which have objectively only a relative and not an absolute reality, in order to eliminate the contradictions, in which the point of departure of the two contrary theses is the attribution of absolute objective value to the idea of space and to that of time. The human mind is organized to perceive relations in space and in duration which actually go beyond it and are independent of it. Thus it penetrates into reality, but into a reality which is relative and phenomenal, the knowledge of which is sufficient for man's needs and for his role in the world. When the mind makes an attempt to go beyond this and to build relative reality into absolute reality, it no doubt yields to a tendency which is native to it. But it is deceived by this tendency, and reason warns of this by exhibiting its bottomless abysses and insoluble contradictions. 146. The two Kantian antinomies are not the only ones which the mind runs into when it has pretensions of attaining the essence of things or absolute reality in the twofold conception of space and time. The plenum of the Cartesians is untenable in the present stage of physics, and action at a distance across the void, in the way the Newtonians conceived it, is absolutely incomprehensible. The latter hypothesis is one which the force of scientific habits has made familiar to us, but which ought to offend our reason no less than it did that of Leibniz, Bernoulli, and Huygens, if it involves thinking of the void or of space as something primitive and absolute which subsists independently of the phenomena of the material world, and not, rather, as a relation between phenomena, the basis and essential principle of which absolutely escapes our means of perception and understanding. But what is such a contradiction in the conception that man can have of the physical world, compared to the contradictions in 224 the conception he has of himself, of the action of his organs on the mind and of his mind on the organs, and, generally speaking, of all the phenomena of organic, animal, and intellectual life, of which some are characteristic of him, while others are shared with such a prodigious variety of inferior beings by characteristics common to all living things. It is repugnant to think of intelligence and thought, of vital or plastic forces being diffused throughout an extended substance, whether this be large or limited in extent, in a system of particles which are separated from each other as much as in a continuous whole. It is repugnant to conceive of these forces as being inherent either in a single particle or in an aggregate of determined particles, or to imagine them as being carried from one particle to another, from one material group to another, in proportion to the renewal of the material of the organism. It is even repugnant to assign a place in space to the principle of life and of thought, to fix as the mathematicians would say the coordinates of a point in space in which the mind would have its seat, and from which it would act on the organs, after having experienced and perceived modifications of the organism. Reason runs into contradiction on all sides, if the extended is conceived as something absolute, and if space is something necessary, primitive, and immutable. But, instead of contradictions in our body of knowledge, there are rather facts which surpass our possible attainments. If bodies and space are merely phenomena, the external reality of which we are clearly able to perceive, but not the absolute ground and basic essence. There are needs in man's nature which would not be satisfied, faculties which would seem fruitless and deceptive, if the end of everything for him were animal life. On the other hand, it is repugnant to put the accomplishments of the superior destiny of man in space and time beyond the sphere of organic phenomena and sensible facts. We do not pretend that reason, if left to itself, may be capable of fathoming these mysteries. We only say that in the presence of such mysteries and for the conciliation of instinctive or acquired beliefs which seem to predict one another, reason finds new motives for admitting that the forms of space and time, always thought of as inherent in phenomena and not in the structure of the human mind, still have only phenomenal value themselves. v. 225. Let us be on guard against suggesting that the philosophic probability of this solution may be a probability of the same order as those which make legitimate, in the eyes of reason, the belief of common sense in the objective existence of bodies and in that of the external world, in so far as it is found in space and time. Let those for whom such inferences are without value abandon the field of philosophic speculation, they clearly have the right to do so. For those to whom such a desertion would be distasteful, it is necessary to accept the inferences as they present themselves, as far as possible without deceiving oneself, and especially without wishing to cause others to be deceived. Chapter 11. On different kinds of abstractions and entities. On mathematical ideas. On ideas of genus and species. 147. We have already indicated in a general way how knowledge or ideas break away from sense impression. In this action of the mind on the materials furnished to it by the senses, there is a series of analyses and syntheses, of decompositions and recompositions. This action is comparable to that which occurs in the elaboration of materials that animals borrow from the external world in order to extract the essential material from them and to build up out of this material others which are used immediately in the development and repair of their organs. The comparison is all the more admissible because, in the one case as in the other, the question is not simply one of isolating juxtaposed parts or of bringing isolated parts together. On the contrary, it is necessary to believe that in both cases the products of the combination acquire properties which are found neither wholly nor partially in the isolated elements. These properties are acquired through the elaboration of primitive material which is carried out under the influence of a vital principle. Inversely, the dissociation of the elements permits the free manifestation of properties which are neutralized or rendered latent in compound substances. The decomposition or analysis to which the intellect submits the materials of the sensibility is called abstraction, and although all our ideas of things, even of those falling immediately under the senses, may be abstracted or separated from the sensible impressions which accompany them, the term abstract ideas is applied particularly to those which we reach through a final abstraction or separation to which we submit the ideas of sensible objects. On the other hand, the act of composition or synthesis by which thought coordinates the materials furnished through the sensibility, by introducing into them the principle of unity and of systematic connection, leads to the conception of 226 entities. These are often called abstract ideas to distinguish them from the images of sensible objects, but it is still necessary to distinguish the ideas obtained through this latter process from those obtained by abstraction properly so called. The formation of abstract ideas and entities is not reserved to philosophers and scientists. The activity which produces them begins as soon as the human mind begins to act and is made manifest in the organization of languages, whatever the cultural level of those who speak them. In this chapter, our purpose should be to use the rules of criticism, whose applications we are trying to point out throughout this study, in order to distinguish between that part which arises from the constitution of the object of thought and the part which springs from the regulative laws of the mind, both in the formation of abstract ideas properly so called and in the conception of those purely intelligible types that we do not believe should be called entities. We make this statement well aware of the fact that during a certain period philosophers may have abused both the word and the thing, and that at another time both the thing and the word may have been subjected to an unwarranted disrepute. 148. First, let it be noted that a false, or at least a very imperfect notion of abstraction, is obtained, if we see in it only a mental process which isolates the essential qualities of an object so as to study these by themselves and thus to attain knowledge of the object more easily. This is what abstraction means in ordinary logic, and in this sense, abstract ideas and abstract sciences would be purely artificial products of the understanding. But this is true only of certain abstract ideas and sciences. In addition to this there is another abstraction, the same one which gives us the ideas of extension and duration, and of space and time free from any sensible image, an abstraction which enables us to distinguish by means of thought elements which are independent of one another, although sensation confuses them. These are abstract ideas which correspond to general facts, to superior laws to which are subordinated all the particular properties through the mediation of which external objects can be perceived by us. And the sciences which have such ideas as their object, which include the system of such laws and relations, must not be passed over as artificial, conventional, and arbitrary sciences. 228. As an example that brings out the distinction we wish to establish, let us consider a solid body moving in space. We shall select at random a point on the object and consider the movement of the body as the resultant of the combination of two other motions, the one, a motion as a result of which all the points of the mass move in a direction common to the point in question, the other, a motion as a result of which the body would turn in a certain manner around this point, to which we shall have attributed an ideal fixity. The breaking up of the real motion into these two fictitious motions, the one a translational motion common to all the points of the mass and the other a rotational motion peculiar to a single point in the mass, may be done in an infinite number of different ways, depending upon our arbitrary selection of a given point in the mass as the center of the relative movement. This ideal resolution of the real movement of the body into two others will in turn give rise to further resolutions which, like the original resolution, will be, or may be adapted to the manner in which we conceive phenomena, which will furnish images adapted to facilitate the description and the study of them, but which, in general, will be arbitrary and not based on the nature of the phenomenon itself. Now suppose we consider the case of the movement of a solid body which is affected by the force of gravity alone and which meets with no resistance from the surrounding medium through which it moves. There is a point in this body, known as a center of gravity, which has this particular quality, namely, that if it is taken as the center of the rotational motion imagined in the above illustration, each of the two motions of translation and of rotation, being independent of each other, acts separately as though the other did not exist. Consequently, the abstraction which distinguishes or which isolates these two motions at that moment ceases to be an artificial and purely logical abstraction. The basis and reason for it lie in the nature of the phenomenon and give us a conception or a faithful representation of it. 149. When, with a view to studying the conditions of equilibrium and of the movements of solid and liquid bodies more easily, we imagine perfectly rigid solids and fluids deprived of all viscosity, that is to say, of any tendency for their parts to adhere to each other, we disregard some of the natural properties that these bodies possess. In order to simplify the problems we wish to solve and in order to adapt them to per methods of calculation, we form an ideational construct of bodies, the prototype of which is not found in nature and is perhaps not capable of realization. In reality, and by a happy circumstance, solid and fluid bodies of the sort nature offers us do not differ so greatly from the fictitious conditions of absolute rigidity and fluidity that we may not regard the theoretical results obtained through the use of these conditions as already representing within allowable limits of approximation the laws of certain natural phenomena. This is the basis for the utility of hypotheses or of abstract conceptions which are artificially substituted for the natural types of solid and liquid bodies. When a study is made of the laws according to which wealth is produced, distributed, and consumed, it is discovered that they may be theoretically established in a simple enough manner, if we abstract them from certain accessory circumstances which complicate them and whose effects, as a result of that complication, can be only vaguely estimated. Consequently, it will be admitted that wealth or commercial paper can circulate without the slightest restraint, can pass immediately from one hand to another, can be realized, negotiated, or exchanged for other papers or for coins, and can be exchanged for values of other kinds at the pleasure of the person who holds them and at the current exchange rate and market price. Similarly, the perfect equalization of price under the influence of free competition will be admitted. None of these assumptions is completely true, yet they come close to being true when they are applied to goods preferred by commercial speculators, and in countries and at times in which commercial organization is more advanced. Such abstractions, by means of which the mind separates facts which are naturally associated and dependent on one another, are what we propose to call artificial abstractions, or, if it is preferred, logical abstractions. These are abstractions with which we might dispense, if the human mind were capable of embracing at one and the same time all the causes which have an influence on the production of a phenomenon, and of taking account of all the effects which result from their association and their mutual reactions. 150. There are other abstractions brought about by the nature. 230. Of things, by the mode of existence of objects of knowledge, and in no wise by the constitution of the mind or because of the point of view from which the mind envisages them. Surely the abstractions upon which the system of pure mathematics rests, for example, the ideas of number, distance, angle, line, surface, and volume, are of this sort. It is in the very nature of things that certain phenomena result from the configuration of bodies, and are not dependent on the physical qualities of the stuff of which the bodies are formed. Thus, when our mind abstracts the physical qualities of matter, for the purpose of studying separately the geometrical properties or those of configuration, we must simply conform to the order according to which, in nature, certain relations are established, certain phenomena develop along with but independent of other phenomena. With still better reason, if the progress we make in the philosophical interpretation of nature tended more and more to give us means of explaining all physical phenomena by means of geometrical relations, the laws of which we have been able to study carefully, if physics tended to be resolved into mathematics, it would conform to the nature of things and not simply to the nature of the human mind, to isolate by means of thought a system not only of general, but also of fundamental facts. This is a system of relations which dominates the others and contains the objective reason for them to such an extent that we might be able to see in mathematics the thoughts of God, to speak of God as the eternal mathematician. Such abstractions, which are independent of human thought and superior to its phenomena, must not be confused with artificial abstractions which the mind devises for its own convenience, and we shall call them rational abstractions. 151. The same sort of motives which lead us to attribute an objective value to mathematical abstractions make us believe in the existence of an external world or tend to make us attribute an objective value to the fundamental ideas of space and time. If the notion of a straight line or of distance were nothing but a fiction of the mind, an idea created artificially, by what chance could the forces of nature, the force of gravity, for example, vary with distance in accordance with simple laws, or as the mathematicians say be junctions of distance, so that variation in distance is necessarily conceived as the cause or the reason for variation in force? What would give rise to this harmonious agreement between the general laws of nature, with respect to which we are simply intelligent witnesses, and an idea which is what it is because of the constitution of our understanding, and which would have value only as a human invention and as a product of our personal activity? 152. But, if the belief in the existence of the external world is and must be a natural belief for carrying out the destiny of man, if nature is charged with combating the skeptics on this ground, it is by no means concerned, nor should it be concerned, with combating a purely speculative skepticism, which consists in regarding all abstract ideas as nothing but the work of the mind or as arbitrary creations of the understanding. The latter interests philosophy, but does not interest either practical life or science proper. Our knowledge of physics or of mathematics would be neither more nor less adequate, whether we considered mathematical conceptions as mental fictions having no objective reality, but finding a useful application in the analysis of physical phenomena, or whether, on the contrary, we think of mathematical truths as having an objective value independent of the mind that conceives them, and as containing the reason for the physical appearances which are adapted to the modes of our sensibility. Science is indifferent to this transposition of order, and there is nothing which can serve to demonstrate logically that the order A, B must be admitted to the exclusion of the order B, A. But that which has no direct influence on technical applications and on the progress of positive science is precisely that which is of the greatest importance for philosophic order to introduce among the objects of knowledge, and to illuminate by the light of reason the connections and the relations among scientific facts which have been definitely established. Neither the true character of the mathematical sciences nor the role they play in the system of human knowledge will be accounted for until we appreciate the importance of these questions of order and until we have resolved them on the basis of philosophic inferences, analogies, and probabilities. The farther we go in our examination, the more we shall discover motives for attaching great importance to the doctrinal distinction between logical abstraction and rational abstraction. 232. For, if all abstractions are artificial creations of the mind, it would be very simple for the mind to arrange these products of its characteristic faculties to suit its own fancy and the convenience of its nature. But if, on the contrary, there are abstract ideas the prototype of which may exist independently of the human mind, since the mind is able to work with abstract ideas, whatever their origin, only by applying certain perceptible symbols to them, certain disagreements will be found between the nature of the symbols which are used for this purpose and the nature of the ideas which are recalled to the mind by these symbols. These disagreements are capable of interfering either with the accurate perception of thought, or with the correct expression by means of language of the bonds and the relations which must be discerned between the prototypes of such ideas. 153. Because the fundamental ideas of mathematics are not artificial products of the understanding, it does not follow that all parts of mathematical doctrine are free from artificial conceptions which pertain less to the nature of things than to the organization of our methods. Thus, the application that we make of numbers in measuring or in expressing continuous magnitudes is without any doubt an artifice of our own minds, and does not belong essentially to the nature of these qualities. In this sense, it may be said that numbers do not exist in nature. Yet, when our thought moves to the abstract idea of number, we are fully aware that this idea is not an arbitrary fiction or an artificial creation of the mind, set up to facilitate our researches, as the idea of perfectly rigid and fluid bodies would be. When we study the properties of numbers, we have reason to believe that we are studying certain general relations among things, certain laws or general conditions of phenomena. This does not necessarily imply either that all properties of numbers play a part in the explanation of phenomena, or, a fortiori, that the supreme reason of all circumstances which give rise to phenomena is to be found in the properties of numbers, in accordance with that enigmatical teaching which was handed down from Pythagoras to Kepler, and which had its birth in remote antiquity only to disappear with the introduction of modern science. It ordinarily happens that after the nature of things has furnished the prototype for an abstraction, the abstract idea thus formed suggests, in its turn, further abstractions and systematic generalizations which are no more than fictions of the mind. From this it follows that ideas that we call new, because they throw new light on the objects of our knowledge, have their periods of fruitfulness and their periods of sterility and exhaustion. If these ideas are fruitful, it is so because, far from being created out of whole cloth by the genius who first lays hold of them, they are ordinarily only a felicitous expression of a relation found to exist among things. If their fruitfulness is not unlimited, like the number of artificial combinations into which the mind is able to introduce them, it is so because nature does not subject itself to the logical rules which preside over the systematic coordination of our ideas. From this in turn it follows that the general fault of systems is, as we say, that they are too exclusive or include only a portion of the true relations of things and turn away from them entirely in their ultimate conclusions or in their excessive prolongation. 154. The application of the fundamental laws of mathematics to the scientific interpretation of nature does something more than show us that they are not artificial creations of the mind. It is to be noted that many of these ideas, in spite of their high degree of generality and abstraction, are only particular forms and, as it were, concrete species of ideas still more abstract and general, to which we should be able to raise ourselves by other means than those of mathematical abstraction, and by the contemplation of other phenomena than those to which calculation and mathematics are applicable. The ideas of combination, order, symmetry, equality, inclusion, exclusion, and so on, do not invest only geometric or algebraic forms, and certain properties of figures or numbers which belong to a type of order of that kind, and to such a form of combination or symmetry, have their cause or their ration d'etre in a realm of abstraction superior to geometry and arithmetic. For example, the notion of inclusion, or the relation of the containing to the contained, is recognized in logic, in which it serves as the basis of the theory of the syllogism, although the manner according to which the general idea contains the particular idea may be very different from the way in which one quantity or one space includes another quantity or space. The idea of force or of active powder is clearly more general than that. 234. Of a moving or a mechanical force, and perhaps a day will come when, still in conformity with Leibniz's suggestions, we shall be tempted to make a sketch of that higher dynamics the rules of which we have glimpsed only confusedly up to the present time, but which includes those of mathematical and mechanical dynamics, or at least those parts of the latter, which relate to conditions not exclusively characteristic of mechanical phenomena, such, for example, as those which are connected with the special properties and exclusive characteristics of the ideas of space, time, and motion. The two proverbs, every action involves a reaction and one can rest only upon that which resists, which are accepted alike by physics, medicine, morals, and politics, are simply so many ways of expressing certain rules of that dynamics which has come to be called higher because it governs the moral as well as the physical world, and serves to make reasonable the most delicate phenomena of organisms as well as the motions of inert bodies. 155. In order to prove that the ideas which are the foundation of the structure of pure mathematics have their prototypes in the nature of things and not in fictions of our minds, we have drawn our inferences from observed correlations between the abstract truths of mathematics and the laws of natural phenomena. The former contain the explanation or the reason for the latter. But we should put aside these inferences to consider the system of mathematics by itself, independent of any application to the scientific interpretation of nature, in order to get at the organization of that system, and to find once more sufficient reasons for rejecting the very presumptuous or very timid opinion according to which the human mind may operate only upon the products of its own imagination and, as Vico has said, may demonstrate mathematical truths because it made them. Had this opinion been established, nothing would be easier than to divide the field of pure mathematics into regular and clearly defined compartments, or, in other words, to submit the system of mathematical sciences to a classification of the same sort as those which please us because of their regularity and their symmetry, when we are dealing with those ideas that the mind creates out of whole cloth, and may arrange to suit its convenience, without being embarrassed by the obligation to reproduce an external prototype. But on the contrary, and this circumstance is well worth noting, mathematics, the exact science par excellence, is one of those in which there is most vagueness and indecision in the classification of the various parts, in which most terms which express the principal divisions are taken now in a larger sense and again in a less inclusive sense. Whether they are taken one way or the other depends on the context of the discourse in which they are used, and on the characteristic views of each author, and without our being able to fix their meaning clearly and rigorously in a common language in whichever sense they are taken. This indicates a complication and an intricacy of relations ill-suited to the logical procedures of definition, division, and classification. Nothing shows more clearly that the object of mathematics exists outside the human mind, and independent of the laws which govern our intellect. 156. It is the function of general philosophy to fix the relative position of mathematics in the general system of our knowledge and to estimate the value of the elemental notions which serve as the basis for that vast scientific structure. But if we enter into the details of the arrangement of its parts to each other and of its internal organization, we see analogous questions springing up to which the same means of criticism are applicable, which have a 236. Special interest to mathematicians because their studies provide the clearest understanding of them, and which, to a large extent, make up what may be called the philosophy of mathematics. It goes without saying that these questions of detail do not lie within the scope of the present volume. We have developed them in other works too, to which we refer any readers who are curious about speculations of this kind. Here we must limit ourselves to the most succinct remarks. In the forefront of philosophical questions, in mathematics as elsewhere, are those which bear upon the representative value of ideas, and in which it is a question of distinguishing, as Bertrand of Geneva expressed it, what pertains to things themselves rational abstractions from that which pertains only to the manner in which we may choose to envision them artificial or purely logical abstraction. Is algebra only a conventional language, or is it really a science, the developments of which, while no doubt connected with the use of an arbitrary and conventional primitive notation, nevertheless bring together a body of general facts and of abstract or purely intellectual relations that the mind discovers and disentangles with more or less skill and success, but which it is so far from having created that it must engage in many tentative efforts and make many verifications of these relations before we can have, so to speak, any confidence in its discoveries. Is every calculation of negative, imaginary, or infinitesimal values nothing but the result of rules set up by arbitrary convention? Or are all these pretended conventions only the necessary expression of relations which, because of their ideal and purely intellectual nature, the mind is, of course, obliged to represent by symbols whose form is arbitrary, but which the mind does not invent according to the whims of its fancy or because of the bare necessity of its own nature, and which it is restricted in getting hold of, in so far as these relations are presented to it by the nature of things, as a consequence of the faculty of generalizing and abstracting with which it has been endowed? This is the issue that divides mathematicians into schools. This is the basis of the philosophy of mathematics, as of all philosophy. It must be noted that all this does not affect the positive and purely scientific part of the doctrine. All mathematicians will apply the same rules of calculation to symbols referring to negative, imaginary, and infinitesimal values, and Wi-Fi, derive the same formulas, no matter what their philosophic opinion as to the origin and the interpretation of these symbols may be. But that which is of no interest to the doctrine from the point of view of positive rules and practical applications is precisely what comprises the underlying reason for the concatenation and for the relations among the various parts of the doctrine. It is no more possible to demonstrate logically that certain ideas are not pure fictions of the mind than it is to demonstrate logically the existence of bodies. Yet this double impossibility no more arrests the progress of positive mathematics than it does that of positive physics. But there is this difference between these two cases: the faith in the existence of bodies is a part of our natural make-up, while we must become familiar, through the cultivation of the sciences, with the meaning and the value of the high abstractions used in them. This is the meaning of the common saying attributed to D'Alembert: "Go forward and faith will follow you," not a blind, mechanical faith, an unreflective product of habit, but an acquiescence of the mind based upon the simultaneous perception of an ensemble of relations which can only successively make an impression on the attention of the disciple, and from which follows a group of inferences to which reason must yield, in the absence of a logical demonstration that the nature of things renders impossible. 157. We now move on to consider that other category of abstract ideas to which the mind is raised by the method of synthesis, in order to bring together in a systematic unity the variable appearances of things which are immediate objects of its intuition. These are the ideas or concepts to which we give the name entities, and in order not to offend any readers too greatly by using a term which recalls so much scholastic want of learning, it will be well to select first the most obvious examples and to show how entities intervene with regard to the conception of phenomena which fall most immediately under our senses. If we disturb a point on the surface of a liquid mass, a wave is created, the propagation of which the eyes can follow as it spreads out in all directions from the center of the disturbance. This wave has a characteristic velocity of propagation which must not be confused with the velocity of each of the fluid particles which successively rise and fall slightly, above or below the level which they maintain in a condition of rest. The movements of these material particles to and fro are very small and can be measured only with difficulty, while the wave always travels in the same direction, through great distances, with a velocity of which we are perfectly aware without instruments and which we can measure in the most exact manner with the aid of suitable instruments. If many points at some distance from one another on the surface simultaneously become centers of undulatory motions, we shall see many systems of waves which meet and cross each other without losing their identity. All this clearly gives us authority to conceive of the idea of the wave as an object of observation and study, which has its own particular form and its own characteristics and particular attributes, such as a measurable velocity of propagation. Yet actually, the wave is nothing but an entity. The material or substantial reality belongs to the molecules which become successively the loci of oscillatory motions. The idea of the wave is the systematic conception of the way in which these motions follow one another and are connected. But this idea does not have an arbitrary origin. It is immediately suggested to us by sensible perception. It enters as an element into the rational explanation of all the phenomena which result from the propagation of undulatory motions. It is an entity of the sort we call natural or rational, as opposed to entities which are artificial or logical. 158. Suppose a naturalist or an engineer takes the Rhone River as the object of his study. Suppose he gives us the history of this river, of its meanderings, of its floods, of slow or sudden changes which occur in the behavior of its waters, of the properties which distinguish them, and of species of animals which live in them. Would anyone believe that a person would go to so much trouble in connection with something that is, after all, nothing but an entity, a symbol, a flatus vocis? The history of each drop of water would have to be given, each drop would have to be followed through the atmosphere, in the sea and in all the different ocean currents in which chance had destined it to be caught by turns. The drop of water is the object endowed with substantial reality. If, on the one hand, the Rhone is considered as a collection of drops of water, it is an object which changes ceaselessly. On the other hand, the Rhone is an object having no reality. If, in order to preserve its real unity, we regard it as an object which persists, after all the drops of water which compose it at one moment of its existence have been replaced by others. 3. In the example we have cited, the objections raised would be ridiculous and would probably occur to no one. Such a monograph as that suggested concerning the Rhone would be read with the same curiosity and scientific interest as would one written about that strange wind that blows across the same country and which is known as the Mistral. We do not take poets seriously when they personify rivers and winds. But, notwithstanding the subtleties of dialectic, we no longer consider rivers and winds as abstractions having no more basis than that given them by a symbol, or a fleeting sound. Winds and rivers are objects of common knowledge as well as of scientific theories. Such objects can be neither poetic images nor simple logical symbols. Actually, a river like the Rhone, an ocean current like the Gulf Stream, or a wind which behaves in a characteristic way like the Mistral belong to that category of entities the notion of which results either from the perception of a form which remains the same in spite of changes of material, or from a form the variations of which are independent of changes in the matter found in them. Or it may be the perception either of a systematic bond which persists whatever the individual objects accidentally involved in part of the system, or of a bond which is modified by causes which are independent of those which impose modifications on the individual objects. These are entities, but they are rational entities, which do not arise because of the way in which we conceive and imagine things, and which, on the contrary, have their basis in the nature of things, on the same grounds as the idea of substance, which is itself only an entity. 159. In addition to these entities there are some which are manifestly artificial. Thus, for example, in physical geography we are interested not only in rivers but in what we call river basins. Some modern authors have set forth in all their minutiae the systematic distribution of the earth into basins of various sorts, on the basis of the water courses which drain them. Now, among these basins, some are clearly determined by the formation of the terrain and by all their physical characteristics, others, and these are much more numerous, are only artificial conceptions of geographers and arbitrary lines of demarcation between territories that nothing divides naturally. It may be, as has been maintained by certain medical schools, that those who describe diseases have abused the idea of entities, that in grouping certain morbid conditions under the name fever or under any other name, they have created an artificial systematization. This systematization has dangerous consequences if it leads medical men to lose sight of the alteration of the organs which are the seat of the illness, for the purpose of attacking the fever as though it were an enemy which must be bound fast and struck down. But suppose that there is, on the contrary, a morbid condition, such as cholera or smallpox, the symptoms, the behavior, the periods of attack, and of waxing and waning, are fully identified, whether we consider their action among individuals or in large numbers of cases. We should no more misuse abstraction in setting up such morbid conditions as entities by writing a monograph on cholera or yellow fever, than we should if we were to write a monograph about a river or a wind. For, by hypothesis, there is a general progression and behavior that marks cholera which will not be modified or which will only undergo changes of a secondary nature, depending upon the susceptibility of populations or of individuals accidentally exposed to its attack, just as the course and the behavior of the Mistral does not appreciably depend upon accidental circumstances which have brought a certain bit of air into the region in which this wind prevails. In general, philosophic criticism of the sciences, in which entities are constantly making their appearance under common or technical names, like the criticism of ordinary or elementary knowledge, as this is expressed by the forms of common language, will consist, so far as this is possible, in making the distinction between artificial entities, which are nothing but logical symbols, and entities based on the nature and reason of things. They are veritable brain children, to use an expression which is common, but which has a true and profound meaning, when rightly understood. To the degree that progress in observation and in the development of scientific theories suggests to the mind the conception of entities of higher and higher orders, the comparison of observed facts and inferences which are suggested by them should furnish reason with criteria of judgment on the basis of which it will decide to what extent these entities are pure logical fictions, to what extent they have their basis in nature, and to what extent they clearly indicate the purely intelligible causes of the phenomena we experience through sensation. 160. there is one category of entities or abstract ideas which deserves particular attention, and with which the logicians of antiquity and of the Middle Ages particularly concerned themselves. This is the category of universals, as the scholastics said, or that which includes the ideas of classes, genera, and species hierarchically arranged according to their degree of generality, species being subordinated to genera as individuals are to species, and so on. Now, the distinction between artificial or logical abstraction and natural or rational abstraction is nowhere more evident than in this category of abstract ideas. What is properly called classification is an operation of the mind which artificially groups objects in which any common characteristic is found, and gives to the general group thus formed a tag or generic name. This operation is carried out for the convenience of research or of nomenclature, to assist the memory, with respect to the needs of teaching, or for any other purpose which is related to human ends. Using the same procedure, these artificial groups may be further divided into subordinate groups, or group 2. 242. Together to form collections and, to some extent, unities of a higher order. This is the nature of classification as seen from the point of view of pure logic. Bibliographies, which every person modifies to suit his own convenience in making a catalogue of his own library, may be cited as examples of artificial classifications. But, on the other hand, nature offers us specific types in the innumerable species of living things arid even of inanimate objects, which surely are neither artificial nor arbitrary, and which the human mind has not invented for its own convenience, and the ideal existence of which it understands very well, even when it finds it difficult to define it. This is analogous to the situation when we take the evidence of our senses as a basis for believing in the existence of a physical object before we have seen it sufficiently close at hand to distinguish its outline, and especially before we have been able to give an account of its structure. These specific prototypes are the principal objects of the scientific knowledge of nature, for the reason that in these species or natural groups, the stable characteristics which are the basis of the specific or generic association dominate and greatly surpass in importance the accidental or particular characteristics which distinguish the subordinate individuals or species from one another. In short, just as there are degrees in this domination and superiority of characteristics in relation to one another, it must and does happen that some genera appear to us to be more natural than others, and that the classifications to which in all cases we are obliged to have recourse, as a result of the needs of our study, most often offer a mixture of natural and artificial abstractions without which it would be difficult or even impossible to demarcate clearly the transition from one to another. A physical example, in which the term group is taken in its material acceptance, will perhaps better prepare us for understanding those abstract relations between the groups that we think of under the names of genus and species. 161. We are aware that astronomers have grouped the stars into constellations, either on the basis of ancient mythological traditions, or by imitation, or for the purpose, whether well or poorly conceived, of practical convenience, in dealing with the portion of the starry sphere unknown to the ancients. These are manifestly artificial groups in which individual objects are associated not according to their true relations of size, distance, or physical qualities, but because, from our point of view, they happen to fall along the prolongation of visible rays which are slightly inclined toward one another. Now suppose that certain very small areas of the celestial sphere, areas which are completely isolated and distinct and in which myriads of stars of the same magnitude appear to be accumulated, are observed by means of a telescope, as Herschel has done. We shall not hesitate to admit that these stars form so many natural groups or particular systems, although we have little or no information as to the nature and origin of their systematic relations. No one will be tempted to attribute this apparent accumulation to an optical illusion or to an unusual chance which would have brought together in this way the visible rays which extend from our eyes to all these bodies. This is the case even though actually the stars in such a group may be distributed in celestial space at distances comparable to those which separate stars which belong to different groups. This is mathematically possible, but not physically admissible. Once we are convinced that we are dealing with a real grouping of stars in celestial space, and not simply an apparent grouping on the celestial sphere, we shall again resist the idea that this proximity may be due to a chance of another sort. We shall rather believe that mutual bonds of interrelatedness exist among the stars of a given group. For example, we shall believe that the stars in Group A would not be so close together if the causes which have determined the position of each were not dependent upon one another, rather than being dependent upon causes which have brought about the distribution of stars in Group B, or in the other groups. After a telescopic study of the skies has given this notion of a cluster of stars, and of a non-fortuitous accumulation or of natural constellations, we shall be able to recognize again, as Herschel has done, that the most brilliant heavenly bodies, which give the appearance of being irregularly scattered across the celestial sphere, very probably form, together with our Sun, one of these groups or one of the natural constellations. Here we have something whose richness and immensity satisfies and exceeds the imagination of poets, but which, in turn, is swallowed up by another immensity that is revealed by the scientific study of the universe. Now notice, and this is a very essential point, that the mind 244 has no difficulty conceiving of an indefinite number of nuances between completely irregular and fortuitous dissemination, which would allow nothing but purely artificial groups to be set up, and accumulation in clearly marked, completely isolated groups which are very distant from one another. The latter, which cannot be considered as fortuitous, but imply, on the contrary, the existence of a connecting link between the causes under the influence of which each individual has taken its place, give us the idea of perfectly natural systems. There are innumerable nuances between these extreme states, because in them the connecting links gradually become restrained or relaxed, and because the part played by accidental and fortuitous causes may be combined in variable proportions with the part influenced by constant and jointly responsible causes. If, therefore, we are forced by the nature of our methods to establish boundaries and groups everywhere, we shall be able to direct this activity in such a way as to bring us as close as possible to the conditions of a natural distribution. But some of the groups will be less natural than others, and the expression of natural relations will be found to be inevitably complicated by the presence of artificial links, factors introduced to meet methodological exigencies. 162. It is not necessary to have a large number of individual objects in order to make natural groups stand out. For the discovery of some new planets, it was sufficient to suggest the idea of the distribution of the planets into 3 groups or classes. One perfectly marked out median group or class comprises the telescopic planets that are comparable with respect to their physical qualities, their small masses, and the approximate equality of the long axes of their orbits, a so-called inner group composed of the Earth and the 3 other planets, whose dimensions and the period of whose diurnal rotation are comparable to those of the Earth, and, finally, an outer group which now numbers 4, one of which, the farthest from us, is still almost unknown, but the other 3 of which resemble each other very much with respect to their mass, their speed of rotation, and their attendant satellites. Similarly, as the number of chemical radicals has been increased, we have come to see very natural groups standing out among them, although including few individuals, such as the group which includes the radicals of potassium and sodium, or, again, those which include chlorine and its analogues. Still other radicals remain isolated or can be related to one another only by means of characteristics arbitrarily selected according to some artificial system of classification. 163. Completely analogous remarks may be made about the naturalists' generic types and classifications. A genus is natural when the species included in it resemble one another in many ways, and by comparison differ so much from species belonging to genera most closely related to them that this relation to the one and separation from the other cannot reasonably be accounted for on the basis of the fortuitous play of causes which would make the types of organization vary irregularly from one species to another. There must have been connecting links between the causes, whatever they may be, which have formed the species of a given genus, or we believe rather that these causes may be broken down into 2 groups, a group of dominant causes which is the same for all species in the genus, and which determines the generic type, and a group of causes which is subordinate to the former, but which varies from one species to another, and which causes the specific differences. If, in its turn, the genus is considered as a species of a higher genus to which we give the name class, so as to avoid confusion, everything that we have said of genera and species may be said of classes and genera. For in that case the class and the genus will be similarly derived from nature, if, as a result of the comparison of species, we must conceive the aggregate of causes which have determined the nature of each species as breaking up into three hierarchically arranged groups. First is a group of causes to which all others are subordinate, and which, being constant for each genus, and consequently for all the species of each genus, has determined the whole group of fundamental characteristics which make up the class. Second are groups of causes which are subordinated to the preceding and constant for all species of the same genus, but which vary from one genus to another, and which, in connection with the preceding, give rise to the generic types. Finally, there are causes of a still more inferior sort, which, being subordinate to the preceding, as we have said, form the specific types. In the regular system of classification to which we submit things for the symmetry and convenience of our methods, the genus may be natural and the class artificial, or the other way around. There is no more natural class in the animal kingdom than that of birds. Yet in spite of this fact, or perhaps because of it, there is in the class of birds more than one genus about which naturalists do not agree and which we may strongly suspect of being artificial. A genus is artificial when the distribution of the varieties of forms among the species comprising it includes nothing that may not reasonably be attributed to the action of fortuitous causes which vary irregularly from one species to another. In that case, a term is omitted in the series of steps that we have indicated, and the fundamental causes which determine the prototype of the class, that of birds, for example, come to be subordinated without intermediary to causes which vary without restraint from one species to another, and which produce the specific differences. 164. There may be, and ordinarily are, a greater number of steps than we have indicated. Moreover, the conception of these steps is itself only an imperfect image, and we observe in the subordination and the intricacy of natural causes innumerable nuances which our nomenclatures and classifications are unable to express. From this, there arises an inevitable mixture of rational abstractions, which have their prototypes or their bases in the nature of things, and artificial or purely logical abstractions, which we use as instruments, but which, like so many direct objects of knowledge and study, lack that theoretical excellence which excites and sustains distinguished minds. The work of most eminent naturalists attempts to untangle these artificial abstractions, which are introduced into the natural sciences so that they may be studied more conveniently, from rational abstractions through which our mind grasps and expresses the dominant traits in the plan of nature. The philosophy of the natural sciences consists principally of a critique of this sort. The difficulty which stands in the way of complete success in this undertaking stems from the continuity of nature as much as from the infinite variety of modifying causes of which only an imperfect expression can be found in the symbols DF language, as will be explained later. One of the most remarkable characteristics of the scientific work accomplished in nearly a century has been this tendency to extend artificial classifications further and further, so that we can accommodate classifications more and more to the expression of the natural relations among the objects classified, even at the expense of practical convenience. This movement, which marks the work on classification, should certainly be made evident first in botany and zoology, in which the objects to be classified are so numerous and involve such complex organizations, and, consequently, are capable of being compared in so many ways. But it has gradually pervaded all the branches of human knowledge. We have cited above examples taken from astronomy and chemistry. Other instances might have been taken from linguistics, that very recent science which is very deserving of interest and which seeks to bring out the natural affinities and the common roots of dialects. These are invaluable evidences of genealogy and of the connections of the human races for the periods concerning which history or monuments are silent. 165. In the philosophic schools of the Middle Ages, in a period when skepticism could be confined by religious faith and could no more have been exhibited with respect to the basis of the ultimate data of knowledge and sensible experience than to the basis of morality, dialectical skill was expended on problems relating to the objective consistency of abstract ideas, rational conceptions, and logical fictions. From this situation developed famous controversies and innumerable sects that have been grouped under three principal headings: realism, nominalism, and conceptualism. This tripartite division lacked clearly marked lines of distinction, and on the whole it indicates nothing more than the existence of two extreme parties and a middle party, susceptible of further fractionization, as is always the case in these long disputes which separate men and which cease only when the parties to them become exhausted. Certainly we have no wish to do what 248 has been done by so many others and reopen this sterile and knotty subject. Nor do we wish to go through this labyrinth of subtleties and ambiguities again at the risk of misleading our readers with respect to it. Yet it is well to point out the origin and the point of departure of these schools and to evaluate the principle involved, evaluating it on the basis of its consequences, the trouble it gave rise to, and the interminable contradictions it raised. The origin of all these disputes lies in the very foundation of the peripatetic doctrine and in the role that Aristotle allotted to the idea of substance when he placed it at the head of his list of categories and subordinated all others to it. Substance, according to this doctrine, is reality or being par excellence, and all other categories share in reality only in so far as they represent the affections or the modes of being of a substance. On the one hand, substance is the apex in the scale of classifications, or of metaphysical degrees. Birds are animal, animal is body, body is substance. Now, if the two extreme terms of the hierarchical series of genera and species, and of classes or metaphysical degrees, that is to say, the individual and substances, are things to which reality and the fullness of being cannot be refused, we may reasonably conclude from this that reality subsists in the intermediary degrees, and that the difference between the one and the other, or that which must be added to the one in order to bring about the other, is a reality. 5. Thus, corporeality is added to substance to create bodies, animality is added to corporeality and substance to form the animal, and so on until the individual is reached, which brings together in itself the constitutive essences of the species and of the higher genera, together with the accidents which characterize it as an individual. Such is the basis of peripatetic realism, and it is principally on this ideational foundation that the controversies among men of letters during the Middle Ages revolved. Listen to what M. Cousin said about this matter. The principle of the realist school is the distinction in each thing of a general element and of a particular element. Now, the two equally false extremes are really these two hypotheses: either the distinction of the general element and of the particular element leads to their separation, or their non-separation leads to the abolition of their difference, and the truth is that these two elements are at once distinct and inseparably united. All reality is dual. The self is essentially distinct from each of its acts, even from each of its faculties, although it cannot be separated from them. The human genus sustains the same relationship with the individuals which compose it, but they do not make it what it is. It, on the contrary, makes them what they are. Humanity is essentially one and complete in itself and yet at the same time in each of us. Humanity exists only in individuals and through individuals, but in return individuals exist, resemble one another, and form a genus, only as a result of the unity of humanity which is in each of them. Here, then, is the answer we propose to give to the problem presented by Porphyry: does the genus exist apart or as a perceptible thing? Distinct, yes; separated, no; separable, perhaps, but with that we leave the limits of this world and of actual reality. 166. If the human genus maintains the same relation to the individuals who compose it that the self maintains to each of its faculties or to each of its acts, in other words, if we attribute to humanity or to the human genus the substantial reality that we attribute to the self or to a human person, and if this substantial reality which constitutes the genus is found again at one and the same time in all the individuals of the genus which are distinct, although inseparably related to a particular element, then there is in truth a mystery in all this that is as impenetrable to human reason as are the most profound mysteries of theology. The obscurity becomes still more profound if we notice that, apparently, substantial reality does not belong to this special element, since we have compared it to the faculties or acts of the self, while it must have substantial reality on the same basis as the general element, if it is to reappear on that basis in the subgenera or hierarchically inferior species. But the contradictions disappear and the veil of mystery is torn, without having to go beyond the limits of this world and of human science, if, instead of a hierarchy of substances and essences, we see in our generic terms only the expression of a subordination of causes and of phenomena. In proportion as this subordination is more or less marked, the genus is more or less natural. It ceases to be natural when the resemblances on which we establish it, although real enough, may be explained by means of chance, that is to say, by means of the concurrence of causes not connected with and subordinated to one another. Thus, for every organic species, and for the human species in particular, there is an evident subordination of the causes which result in the individual varieties to the causes which determine the general and specific and hereditarily transmissible traits. There is a no less manifest subordination of the conditions of existence for the individual to the conditions of the existence and the perpetuity of the species. Therefore, the human species, as naturalists say, or the human genus, to use a term more familiar to philosophers and moralists, constitutes a natural genus. In other words, a human nature exists, and these words are not empty sounds, nor do they represent a pure conception of the mind. Similarly, the class of birds and the still more general class of vertebrates are natural, for, as a result of the knowledge we have gained in zoology, we are led to consider as dominant the characteristics of these classes which, taken together, make a sort of prototype or form in conformity with which nature has subsequently and secondarily proceeded by means which up to the present time remain unknown to us in the operation of varying genera and species within limits fixed by the dominant conditions. Consequently, the causes, whatever they may be, to which it is necessary to impute the determination of the dominant and constitutive characteristics of a class must be regarded as essential and dominant with respect to the equally unknown or very imperfectly known causes which have introduced the diversity of the species. 167. It is not necessary to believe that the scholastics absolutely ignored the distinction between natural and artificial genera. On the contrary, they more than once indicated that they intended to apply their theories of metaphysical degrees only to those things which, having a natural substance, proceed from divine action, for example, to animals, metals, and trees, but not to armies, tribunals, nobles, and so on. 7. But preoccupation with substances and with substantive distinctions always entered their minds to obscure a glimpse quite removed from that degree of clarity through which, in modern times, it has led to a profound study of the organization of existing things. The conclusion to 7 Remusat, Abelard, B.K. I. 432. On kinds of abstractions and entities 251. Be drawn from this chapter in the history of the human mind is that everything becomes clear when we take as our guiding thread, in the philosophic interpretation of nature, the idea of the reason of things, of the connection of causes, and of the rational sub-ordination of phenomena, that sovereign and regulative idea of human reason. Everything is obscured and made difficult when we take as the regulative and dominant idea that of substance, which has only a subjective basis, or the objective value of which is confined within limits which the genius of Aristotle ignored, and of which the doctors of the Middle Ages had not the slightest notion. Nevertheless, it must be recognized that the instrument of language is established in conformity with the idea of substance and is suggested by the consciousness we have of our personality and of our ego, to use the language of modern metaphysicians. The order of the categories proposed by Aristotle conforms to the genius of language and to that which we may call the order of grammatical categories. From this a veritable contradiction arises, a real opposition between the conditions of the structure of the organ of thought and of the nature of the objects of thought. This contradiction has tormented philosophers during the centuries in which men should have been all the more preoccupied with logical forms, when the science of things was less advanced, and for the solution of which it would be necessary to know how to disengage oneself from the influence of logical forms and the mechanism of language, without thereby going beyond either the limits of this world and of actual reality or the truly essential conditions of human knowledge. Chapter 12. On Moral and Aesthetic Ideas. 168. In the general harmony of the world, nothing is more striking than the agreement we observe in all the degrees of animal nature between the arrangement of the organs and of the faculties through which animals receive impressions from outside, and the whole arrangement of the faculties and organs by means of which animals react on the external world so that each may fulfill its proper destiny. The two systems move along parallel to one another, develop, become perfected, and break down together. Alongside the nervous system which carries sensations is the nervous system which transmits the directions of the will. With the more perfect sense organs are associated more powerful and delicate organs of locomotion or of grasping. Following more obscure or more distinct perceptions, actions become more indecisive or better determined. Thus, analogy should be sufficient to allow the presumption that since, in matters pertaining to knowledge, man has faculties which are much superior to those of animals, he is for that reason called to a higher destiny and should perform acts of a higher sort. If this superiority in the order of knowledge were to go so far as to enable man to conceive absolute and necessary truths, that ability in itself should be enough to suggest the intervention of a principle which may have this character of necessity and absolute rigor, so far as the regulation of his acts is concerned. This suggestion is undoubtedly only a supposition based on a rational inference of the sort which would impress an intelligent being who, although not a man and without having direct knowledge of the law which governs the action of men, would observe man as we observe animal species, completely enough to foretell all the relations between humanity and the rest of creation. Therefore, it is very plain that the philosophical study of man consists of two essential parts which are distinct although connected, and that a philosophical theory of our acts and their control corresponds to every philosophical theory of knowledge. It is also clearly evident that this dual nature of man, this complex of intellectual and rational faculties and of instinctive and animal faculties, this life of telations and this ability to rise through the relative to the concept of the absolute, plays analogous roles in logic and in morals, the one being, so to speak, the counterpart or symmetrical reproduction of the other. A development of knowledge to which no parallel development of the active faculties of man corresponded would, as far as we are able to judge this matter naturally, be an anomaly, an irregularity, and a disturbance of the general plan of creation. Thus, when organs designed by nature for the propagation of a plant have been transformed into beautiful ornaments, into resplendent but sterile petals through careful work and the artifices of cultivation, no matter how much charm they may have for the senses, reason sees in them only a monstrosity rather than a perfection. When we consider man as a product of social forces, we must no longer expect to find among individuals that natural and correct balance between knowledge and acts, that parallel development of intellectual and active faculties of which we have been speaking. The division of labor, the distribution of roles among various members of the human family does not permit it. And, independently of social necessities, the abuse man makes of his liberty would be sufficient to disturb this balance. It is in the social body that we must look for and that we may find, at least approximately, the correlation and parallelism that nature has achieved with a surer hand among individuals, necessarily confused by progress and abuse, instead of in the species that it has not destined for a social life. 169. In this book, we have proposed to present a sketch of a critique of knowledge. We have not proposed to seek in the human heart, in the analysis of the tendencies and of the needs of human nature for the rules of private morals, of justice, and of politics. No doubt man may find in his conscience reasons for admitting or rejecting certain theories, depending upon whether or not they appear to him to lead to practical consequences that the heart honestly approves or disavows. This is a criterion like any other, and perhaps the best of all, but it is not what we wish to concern. 254. Ourselves within the present study. On the contrary, we think of moral ideas, from whatever source they come, as objects of knowledge for the understanding. The philosophic question we raise is that of discovering whether or not there is any reason to regard moral ideas simply as human facts springing from the unique nature of the species, or whether, on the contrary, they must be related to an order of facts, laws, and conditions which dominate the laws and conditions of humanity. This is another instance of the problem which has occupied us previously, and the principle by which it may be solved must still be the same. 170. Suppose, for example, we are dealing with the problem of evaluating with perfect philosophical detachment a moral system in which the search for pleasure and the avoidance of pain are considered to be the end and rule of human actions. It would not be difficult to see that such a system is out of harmony not only with certain elements of human nature, but also with what we have discovered of the general plan of creation. We see all around us that nature has introduced pleasure and pain as means and not as purpose, as devices for obtaining certain results and not as final ends. Pleasure and pain are connected with certain impressions from external agents and with certain functions of animal life, precisely in the amount required to conserve individuals and species. Every analogy would be made worthless if man, having acquired faculties superior to those of the animals, had not acquired them for other ends than for that which is not even an end in the order of animal functions and faculties. And the dissonance would not be reduced, if we were to replace the desire for present pleasure or the repugnance for imminent pain with a sort of arithmetical balance of pleasures and pains which must follow one another in the course of the life of the individual, as a result of such a basis of determination. This would be the case even though, in order to establish this balance, as many individual lives or as many successive generations as might be wished were gathered into a single group. 171. Especially in morality, skeptics have had good sport by comparing the opinions, maxims, and practices of one people, sect, caste, or period with those in vogue among other sects, nations, or other generations of men. A midday nap decides the truth. Right has its eras. A pretty sort of justice, that bounded by a river or a mountain. Truth oil this side of the Pyrenees, error on the other. And to this formidable objection, epitomized in this way by Pascal in his energetic sentences, the dogmatists have been able to reply only by citing the interests and passions of men, which obscure their judgments in regard to things that touch on practical affairs, leaving them with their habitual clarity only when they deal with speculative truths. But we fail to see why it would be more difficult to agree that in matters which pertain to the moral faculties of man, as in what we properly call spirit, genius, and character, the varieties of races or even the varieties of individuals have a freer field of action than in those which pertain to the organization of the faculties by means of which we acquire knowledge of physical objects and their relations. Every species has certain more constant, more specific characteristics, just as it has others which exhibit by preference individual differences or racial variations. And, in the same way, when we compare many species of the same genus, we recognize that the genus is established naturally only by the persistence of certain characteristics which are more fundamental than those variations which differentiate the species. It is consistent with every analogy to say that the faculties which exist fundamentally among animals most closely related to man, as in man himself, although developed very unequally, have more specific persistence in human beings. On the contrary, faculties which are exclusively characteristic of one species and consequently less fundamental for envisioning the concatenation of species and the general plan of nature lend themselves more easily to individual differences and to racial variations, or to varieties which result from the prolonged action of the same external influences, according to circumstances in a given country or period. The task of the moral philosopher is to distinguish within the subject matter of moral ideas, in so far as this is possible, that which is specifically fundamental, which pertains essentially to human nature, and which is restricted only in morbid cases and monstrosities, from that which is left to individual differences or to variations of the sort that we have noted above. But his task is not limited to this. In accordance with rational inferences, he may, and indeed he must, distinguish among ideas. 256. And beliefs of different origins, those which have their basis, their reason, their prototype in laws of a higher order as compared with those which have given man his specific nature, and on the same basis distinguish what is morally good or bad in individual differences. 172. This pertains particularly to what is called honor, the rules of which, even though they are often tyrannical, have as their sanction not remorse, but disgrace, and are not to be confused with those revelations of conscience the authority of which we respect even when we happen to break them. We shall nowhere find this subject better analyzed than in the book in which a very sensitive author has envisioned from every point of view the consequences of the great social transformations of which we have been the witnesses. It would seem that men employ two very distinct methods in the judgment which they pass upon the actions of their fellow men. At one time they judge them by those simple notions of right and wrong which are diffused all over the world, at another they appraise them by a few very special rules which belong exclusively to some particular age and country. It often happens that these two standards differ, they sometimes conflict, but they are never either entirely identified or entirely annulled by each other. Honor at the periods of its greatest power sways the will more than the belief of men, and even while they yield without hesitation and without a murmur to its dictates, they feel notwithstanding, by a dim but mighty instinct, the existence of a more general, more ancient, and more holy law, which they sometimes disobey, although they do not cease to acknowledge it. Some actions have been held to be at the same time virtuous and dishonorable. A refusal to fight a duel is an instance. The author goes on to show, with a great deal of sagacity, how the ideas of honor which are characteristic of certain countries, professions, or classes are determined by the needs or exigencies which rest in the very nature of the country, profession, or class. As a result, these ideas become more singular and have more influence in proportion as they correspond to more particular needs and are experienced by a smaller number of men, and, on the contrary, they tend to disappear as social classes break down and populations intermingle. From this the author finally concludes, if it were allowable to suppose that all the races of mankind should be commingled and that all the nations of earth should have the same interests, the same WANTS, undistinguished from each other by any characteristic peculiarities, no conventional value whatever would then be attached to men's actions, they would all be regarded in the same light, the general necessities of mankind, revealed by conscience to every man, would become the common standard. The simple and general notions of right and wrong only would then be recognized in the world, to which, by a natural and necessary tie, the idea of censure or approbation would be attached. But in this extreme supposition, and on the basis of the author's principles themselves, it would still not be permissible to consider rules of universal morality, appropriate to the general needs of humanity, as a sort of resultant or mean between particular standards of honor or morality which are suited to certain groups of men and are adapted to their special needs. For the simple coalescing of needs cannot change abruptly the character of the moral law, make it more sacred, impose it by belief as well as will, give it as a sanction remorse, on the one hand, and the satisfaction of conscience, on the other. This very remarkable characteristic of universal morality, by which it stands in contrast with the rules of honor which pertain to a class or profession, could not be due only to the fact that the general needs of humanity outweigh the needs of a class or profession and are not the product of conventional institutions. It must be due above all to the fact that as a result of their generality the notions of the just and of the unjust overshadow the idea of humanity itself, and they must also be due to the fact that we understand that these notions would still govern societies of rational and intelligent beings other than men, beings having neither the same organs nor needs that we have. We believe in such principles just as we believe that there are principles in our human logic which would direct minds served by other senses than ours, using different symbols, or in which truth might be attained without the mediation of sense impressions, and which would not need the assistance of symbols in order to transmit it. If, in the very core of humanity, there is one indelible distinction which does not have its roots in conventional institutions, and which exercises an influence of prime importance on everything connected with customs and on what we call honor, it is surely the distinction between the sexes. Now, although Christianity has worked to raise the moral dignity of women to that of men, and to impose on man, through his conscience, duties no less severe than those imposed on woman as a consequence of the natural conditions of her sex, the world, to use the language of the Christian pulpit, has persisted in a morality at once more relaxed and tyrannical, full of rigor for one sex and of indulgence for the other. Such are characteristics which we assigned a moment ago to that honor which finds its reason in the needs of society, in the conditions of existence of a class or of a particular group. But while public morals always yield to the necessity of these natural conditions, the innermost voice of reason, or the moral sense, even when devoid of religious faith, would protest against the injustices of the mores. This protest indicates that, above the laws of the physical organism and the consequences which follow from them, we conceive of a reciprocity of rights and obligations among moral persons who are bound by mutual obligation and who are capable of raising themselves in the same degree to the ideas of right and duty, notwithstanding all the native physical dissimilarities that nature has put between them. 173. No one would contest the fact of the successive appearance and development of a certain number of moral ideas, as a result of the culture of societies and of individuals, under the influence of religious and civil institutions and of individual education. But it seems that this fact, which is so natural and so constant, has been correctly interpreted neither by minds having skeptical tendencies, nor by those who may have or who may assume the mission of refuting them. The former have thought they were justified in concluding that moral principles have no basis outside of or above social institutions. The latter have wished, by means of subtle distinctions, to maintain intact the proof drawn from a pretended unanimous consent of people during every epoch of the life of humanity. Yet, why should the idea of a moral progress in individuals and societies offend reason and universal order any more than the idea of progress in the sciences, in philos, ophy, and in the arts? If, for any reason, the objective value of moral ideas were denied, it would be necessary to call in question the objective value of all scientific truths, which are not the heritage of all minds, and which manifest themselves only to certain finer intellects with the assistance of a large number of instruments and helps of every kind, and are met only in the midst of very cultivated societies. On the contrary, must we not deduce an argument in favor of the objective value of moral ideas from this, if it happens that, in spite of very different initial conditions and under the influence of races, climates, and institutions which differ considerably, moral ideas which have been refined by culture tend more and more to approach the same type, far removed from their original distinctions, and, under the same physical influences, come to be more and more strengthened and pronounced? The mere fact that the system of moral ideas tends toward uniformity, among peoples whose social culture improves under the influence of different circumstances, would be good reason to admit that the system progressively casts off everything that is based on accessory and variable causes, in order to retain longer only that which may be attributed to the very basis of humanity itself and to the moral constitution of our species, to its natural bents and to its permanent needs. But if, in addition, new needs are introduced in the course of this progressive improvement, it must be presumed that such ideas, of which humanity has not always been in possession although its needs may have been the same, are not true only in a human and relative sense. They must be presumed to depend on the general order of things that we are not always capable of discovering, but that always impresses us as soon as it is shown to us. In a word, they must be part of a body of higher truths. Although it can be argued against them that they have remained unknown to less refined men and to barbaric peoples, because they have been perceived only in the course of the improvement of civilization and manners, their newness itself, that is to say the newness of their revelation, would be the best evidence of the eminent rank that they occupy among the principles man discovers but does not create. Otherwise, how would it happen that a genius, whatever power he may have had, would have been able to impose imperishable beliefs on future generations? In endowing some privileged individuals with the 260 most brilliant faculties of genius, nature has, after all, produced only an accidental and passing phenomenon. If, instead of discovering one of the great laws of nature, Newton had envisioned only an ingenious but imaginative system, it could be said that a day would come when his name would be forgotten. But it will never perish from man's memory, because it is connected with the discovery of an eternal truth. It is a law of the moral order as it is of the physical order that the traces of initial and accidental circumstances are effaced in the long run under the influence of causes which always act in the same way and in the same manner. And even though the traces of these initial circumstances were never to disappear entirely, or require for their disappearance periods which, up to the present time, the span of recorded history has been too brief to encompass, we should realize that in their gradual and temporal weakening they cannot be part of the conditions of a normal and definite state. Thus, moral ideas would have even greater value for statesmen and for political historians, but they would become, so to speak, matters of indifference for philosophers whose thought aspires to set aside accidental and variable facts in order to penetrate better the inner disposition of the permanent laws of nature. On the contrary, if an idea or a moral belief is not weakened by being handed down by tradition, or if it persists or recurs, whether complicated by variable accessories or freed from them, in all periods of human history and among peoples who are most unlike one another with respect to the forms of civilization, then such an idea or belief will have to be regarded as having its root in the nature of the species. This is the case even when, as a result of the absence of traditional transmission, the idea or belief happens not to develop in the individual or to develop in him only under very exceptional circumstances which, in one sense, come back to the general plan of nature and to the conditions of definite and permanent order. We may count on this since everything that happens as a fortuitous and singular case is nevertheless destined to happen sooner or later, after the play of fortuitous causes is finally introduced, in the midst of a mass of combinations which leave no trace, the particular combination which incorporates the principle of its perpetuity. Who can say that among the species which today are the most stable so far as their physical characteristics are concerned, there are not some whose origin resulted from individual peculiarities, which, far from disappearing with the individuals in which they first appeared, have found the circumstances by means of which they have been able to reproduce and to become thoroughly established through their descendants. In passing, it may be noted that the same remark must not be lost sight of when the question of the natural or supernatural origin of language is raised. It may be that most men were formed in such a way that, living by themselves and under ordinary conditions of primitive life, they would not have invented the art of speech. But it is sufficient that some individual persons who had a more fortunate structure, and who were placed in more favorable circumstances, were capable of beginning the rough skeleton of a language in such a form that this rudimentary tongue could then be perfected and propagated by all the members of the species. And in this sense, it would still be true to say that the gift of language belongs naturally to the species, or is naturally a part of the structure of the species. 174. All we have been saying about moral ideas applies, with some slight changes, to that other category of abstract ideas which is concerned with beauty and taste in the arts, the theory of such ideas being a preferred study in modern times, and at the present time is usually given the name aesthetics. It is still less our purpose to develop here a system of aesthetics than to present a theory of morals. Nevertheless, it is within the scope of our plan to make it understood that, in aesthetics as in morality, the purpose of critical philosophy is essentially to bring about the separation between modifications left to individual or racial varieties, to accidental and transient influences, and the basic characteristics pertaining to the normal and specific constitution. After this separation has been effected, the further goal of critical philosophy is to seek to discover whether the ideas which pertain to the normal state and to the specific constitution do not have their objective prototype or their raison d'etre in the very nature of the external objects which suggest them to us, or in more general laws than those which have impressed on mankind its particular organization and structure. Finally, for all this work, critical philosophy can only set forth rational inferences, analogies, and probabilities of the same sort as those to which we have been ceaselessly calling attention up to this point. Does an object delight us because it is beautiful in itself, and 262. Because we receive from nature the gift of perceiving this quality of external things and of delighting in it, or do we rather call a thing beautiful because it delights us, because we have no other basis for the idea of beauty than the very pleasure which the object causes in us as a result of fixed laws of our particular nature, or because of accidental modifications which it has undergone? This is how the problem which we have run into everywhere presents itself to us in aesthetics. This problem consists in distinguishing the role of the feeling or perceiving subject and that of the object seen or felt in the act which brings them into relation with one another and from which a feeling or perception results. In aesthetics as elsewhere, there must be extreme cases in which the solution of the problem, in one way or the other, leaves no trace of doubt in a perceptive mind, in spite of the fact that this result may be reached only by a process of inference which necessarily excludes a rigorous demonstration and which is inevitably exposed to sophistical negation, just as there must also be doubtful and uncertain cases with respect to which different persons incline to one side or another, depending upon their particular habits and the point of view in which they are placed. On the occasion of the perception of an object which pleases us and which awakens in us the idea of the beautiful, critical philosophy may be led to a different solution of the same fundamental problem, depending upon whether it approaches it from the point of view of aesthetics, or from the point of view of knowledge unadorned, and independent of the feeling of pleasure which accompanies it. For example, an architect who understands the effects of perspective will purposely alter the proportions of a building so that from the position from which the spectator views it the perspective rectifies these alterations, and the object appears as it must if it is to please us and is to present to us the characteristics of beauty. In the same way the tragedian or pantomimist may exaggerate certain effects in his performance in order to make allowance for the distance of the stage from the audience. Now, in such cases, if we consider the idea that the sensible impression gives us of the external object, insofar as it is representative of the object itself, that idea is certainly falsified by subjective conditions. Consequently, the characteristic of beauty that we impute to the object in reality belongs only to the image as our senses present it to us. But it by no means follows from this that the conditions of the beauty of this image are purely relative to our sensibility and that the image, as we conceive it, or the object which would bring it into being externally, has no intrinsic beauty which subsists by itself, whether or not we may have been so formed organically that we may be affected by it, as light would subsist even though we had no eyes with which to learn that it exists. 175. Before entering into more detailed explanations, let us make some general remarks. Not only do a multitude of natural objects please us and seem beautiful to us, but the world itself, considered as a whole, presents us with the characteristics of beauty in an eminent degree, and the very name the ancients gave it, if we may believe their own testimony, expresses that eminent beauty. External reality is not only an inexhaustible source of methodical observations for scientists, of calculations for mathematicians, and of meditations for philosophers. It is also a marvelously fruitful source of poetic beauties and of ravishing ecstasies. Now, what would be likely if man were to get his ideas of beauty only from the comeliness of his own nature and from the particular circumstances of his organic structure, if, for example, as many men have claimed, we were to judge the beauty of forms and proportions only in so far as they are related to the proportions and the forms of the human body? Would it not be an entirely unprecedented and improbable chance that starting from this arbitrary model, we should continuously find in external nature, to the degree that we probe its depths and scrutinize its details, not only some objects which fortuitously bring together the conditions of this relative and entirely human beauty, but also innumerable beauties of detail and comprehensive beauties which infinitely surpass the most beautiful productions of human art in the way each part falls into place? Do we not see that with respect to other ideas, for example, with those of the good and the useful which are actually related to our nature and needs, we do not observe a similar agreement? As a result, in speaking of the three as far as I am concerned, I am in agreement with the peoples of the world. The Greeks have designated the world by the word cosmos, which means ornament, and we have given it the name mundus because of its perfect finish and grace. Pliny Natural History, 2. 3. 264. Many marvelous works that nature seems to produce simply for the joy of producing them according to our human ideas. It is almost impossible for us to say what they are of service to, in what way they are good and in what way useful. Therefore, that human idea of the good and the useful must not be carried over, or, at least, we have no authority to carry it over into the realm of natural facts, and we run a great risk of going astray if we seek in them the reason for the order and harmony of phenomena. But inversely, since the beauty of the works of man appears to us to be only a weak reflection and an image of cosmic beauties, there is reason to infer from this that the idea of beauty does not originate in purely human convenience. And just as when we see that the universe is subject to mathematical laws, we infer that mathematical ideas and relations subsist independently of the mind that conceives them and must not be put in the same category with artificial abstractions but with the rational principles of things, so the beauties which are so profusely scattered throughout the world as a whole and in its details must lead us to believe that the principles and the reason of beauty do not arise in the particularities of man's organic structure, but are of a sort which is clearly superior to that of purely human facts. At least at first sight, it might even be supposed that the influence exercised on man by the spectacle of nature is what has fashioned his tastes for the purpose of producing an object agreeable to him and of making sure that he finds beauty in it, when this object recalls to him the proportions, forms, assortment of colors, and so forth to which the daily pageant of the world has early accustomed him. In general, all the hypotheses which were discussed in Chapter V, and to which one may have recourse for the explanation of the diverse harmonies of nature, may be called upon to explain the harmony between the order of the world and our taste with respect to beauty, except for the more thorough examination of the question as to which has the higher degree of probability, according to the force of inferences and the spread of analogies which work in its favor. But the supposition that our ideas and our tastes in matters of beauty depend upon the peculiarities of our individual or specific organizations and that nevertheless they are found to agree fortuitously with the general arrangement of the world seems improbable and inadmissible from the very first. 176. This is the place to make another general remark completely analogous to that which has been suggested to us concerning moral ideas. In the products of human art, the discovery of the rules and conditions of beauty is the fruit of patient research or of the inspiration of genius. If we reach them methodically and progressively as a result of the development of civilization and of the culture of individuals and peoples, and in such a way that ideas and tastes which differ radically among themselves in primitive periods and during the infancy of a people tend to approach the same types as a result of the intercommunication and progress which civilization introduces, then there is reason to believe that man has not forged these types but has discovered them and that he perceives them more clearly in proportion as his eyes are better prepared to be open to the impressions of a light from without. But what, on the contrary and T3 seems to be more in conformity with historical evidence is the situation where the influence of the individual genius plays the most important part in the discovery of the beauty in matters of art, where the masterpieces of genius, which are objects of continual imitation and study, exercise an ineffaceable influence upon the ideas that men form of beauty. Can this fact be reconciled with the general law which supposes that every accidental and isolated occurrence leaves only passing traces, at least to the point of admitting that the individual genius has revealed to humanity permanent forms, the knowledge of and feeling for which cannot be lost once it is acquired, without a return to a condition of barbarism which would abolish every impression of them? 177. There is in art, says La Bruyere, a point of perfection, as there is one of goodness or of maturity in nature. One who perceives and loves it has perfect taste, one who does not perceive it, or who likes only this part or that of it, has defective taste. There is, therefore, good and bad taste, and tastes can reasonably be disputed. But what is this point of goodness or maturity in nature which must be regarded as the ground and the reason, or at least as the model of perfection in art? Let us take an example, and discuss from this point of view the idea that we have given of the specific prototypes and of the conditions of ideal perfection in organic beings, fashioned according to these types. For greater simplicity, let us consider at first only that which pertains to dimensions, contours, and sensible forms. Is it necessary to believe that we measure all the dimensions, all the lines, and all the angles in a great number of individual objects which may serve to determine their individual forms, that we take the mean for all these particular quantities, and that the system of these mean values determines the form, the 8O, of the specific type? Modern statisticians seem to have understood the matter in this way, but in doing so they have failed to take account of a grave theoretical difficulty. In fact, it could well happen, indeed in most cases it must happen, that these mean values do not agree among themselves and may as a whole be incompatible with the essential conditions of the existence of individuals and of species. To take a different comparison, but one whose geometrical simplicity enables our mind to grasp it clearly, let us suppose that we are interested in the problem of a right-angled triangle whose sides vary accidentally, within certain limits, from one to another, without maintaining exactly either the same absolute dimensions or the same proportions. Let us measure a great number of these triangles, let us take the mean values for each side, and let us construct another triangle having these mean values that, in one sense, we may call an average triangle. Yet this mean triangle will not be the specific prototype of any of the individual triangles, for as geometry proves it will not be right-angled and thus it will not possess the essential characteristics of the class of right-angled triangles. Let us admit that this essential condition is taken account of by postulating that the prototype of the triangles be right-angled, and that we succeed in fixing the limits of it by using as the length of the two sides which form the right angle the average length of these two sides, as obtained from the series of individual triangles. The two acute angles of the triangle so constructed would not be the averages of the corresponding angles as these would be given by the series, and the base would not conform to the average base. In a word, no matter from what point we approach the problem, it will be mathematically impossible to construct or to define a triangle in which we find realized at one and the same time, and interconnected among themselves, the average values of all the dimensions which, for each individual triangle, have yielded perfectly determined and perfectly compatible values. If this is the case for the most simple geometrical figure, the triangle, there are good reasons why, without restriction or arbitrary conventions, we cannot define the form or the specific type in a group as complex as that of the aggregate of the organs of a plant or an animal by means of a table of averages. What would the situation be if we wished to take account of a great many other physical or physiological characteristics, such as weight, muscular force, power of the senses, and so on? Evidently, the mean values of such different elements would agree among themselves only by a very great chance, and the synoptic table of all those values, not being intended to be regarded as the definition of a possible individual, is still less the definition of the specific type. We still seek the idea and the approximate description of this sort of definition no matter how much difficulty we experience, and even though it may be impossible to give it a perceptible image and an adequate expression through the use of methodical and rigorous procedures. 178. But let us move along, and come back to the principles of aesthetics from which these preliminary remarks have diverted us. Even though the collection of individuals were to furnish a system of perfectly reconcilable mean values, it would by no means be necessary to conclude that this system exhibits the image of the specific type, or that it is suited to give us an idea of what this type is in itself, independently of the influence of external and accidental circumstances which alter and deform it. No doubt if these accidental features affect one of the elements of the species, for example, the length of a line, sometimes in one way and sometimes in another, by exaggeration or by diminution, and with the same facility and the same intensity, then the average furnished by a great number of individual cases would be precisely the value which belongs to the prototype, and all the alterations due to accidental and external causes would exactly compensate for one another. But should this exact compensation not occur, or even though the causes of deformation always acted in the same manner, 5. It would not follow that they lose their character of accidental and unusual causes, nor does it cease to be necessary to think of the effects that they produce as alterations of the original type, alterations that must be put aside if we wish to conceive this prototype in its ideal perfection and in its essential beauty. Such is the object or one of the objects of art. In default of the methodological procedures of science, it is to this object that the indefinable feeling which we call taste applies, and it is that which, when exercised by a particularly sensitive organism, turns the results of attentive study and observation as much to account as does science, although in a different way. 179. No doubt the conditions of the perfection of specific types of ideal beauty do not attract the attention of laymen and artists in the same degree and with respect to all species. There are two reasons for this. One is relative to man and causes him to take a preferential interest in species which are most closely allied with him, which best serve his needs or his pleasures, and which are his natural friends or enemies. The other is based upon the very nature of the various objects displayed for human observation and is rooted in the fact that certain specific types, in comparison with others, thoroughly combine, to a very high degree, the conditions of perfection and of ideal beauty. In fact, why may we not say of species of the same genus what is said with reason of individuals of the same species? It is true that we know even less about the causes which modify the fundamental characteristics of genera and of the way in which species become differentiated than we do of those causes which continually act to modify the fundamental characteristics of species or of races in such a way as to produce individual varieties. But this ignorance does not keep us from understanding very well, in both cases, the subordination of modifying and accessory causes to those which give rise to fundamental characteristics. Therefore, in the case of each of those genera that we call natural because the kinship of the species which compose them is so strongly marked, as in the genus Felis, for example, no naturalist fails to pick out one species, such as the lion, which is, as we say, the prototype of the genus. In other words, it is the species in which we find combined in a more excellent manner than in any other the distinctive characteristics of the whole genus. For this reason, whether it be clearly understood or confusedly perceived, this is the species that we find beautiful or excellent in comparison with the other species, and yet no arbitrary element enters into such a judgment. It is possible to go higher in this hierarchical progression. Then the prototype of the genus Felis will also be the prototype of the order of carnivorous mammals, provided the genus in question is the one in which the power, harmony, and perfection of the characteristics of carnivorous mammals are found in their maximum development. For the harmony without which no work of nature could continue to exist does not reveal itself to us in such well-defined characteristics, and does not actually exist in the same degree in all works of nature. Some imperfections may be and are incompatible with the conditions of the existence of individuals and of the perpetuity of the species. Among strongly indicated types of intermediary and indistinct forms, imperfect sketches or less perfect models may be and are recognized. In their way these give evidence of the unfailing fecundity and infinite resources of nature, but they can neither excite our admiration in the same degree nor stimulate the imagination of the artist, because, actu. 270. Ally they do not, like the others, have an ideal type and form of beauty which is characteristic of them. 180. Suppose man sets about to modify nature, that he creates new races and to some extent new species which are suited to his needs and enjoyment. No one would deny that these more recent and less stable species have certain conditions of perfection and harmonious adaptation, an ideal type and a kind of beauty which is different from those which belong to natural and uncultivated species, even though they are derived from a common source. If in addition we assume that these types which cultivated or uncultivated nature offers him are seized upon imaginatively by the artist to express symbolically a moral or an abstract idea, if the lion becomes for him the symbol of force, the horse the symbol of tractable impetuosity, we shall allow him a certain exaggeration of fundamental characteristics. Judged from the point of view of art, his work will be beautiful or not in spite of the fact that there are in nature no individuals of the sort he has portrayed, but also in spite of the fact that the existence of such individuals would be incompatible with the organic traits of their species. This is the reason why the beauty of works of art may be distinguished from the beauty of works of nature, and why the conditions of ideal perfection are not necessarily the same for both, in spite of community of origin. 181. Next to the works of art made in imitation of the works of nature are placed the works so peculiarly adapted to the needs of civilized man that nature offers no model of them. Nevertheless, here, too, we still encounter the beautiful and the ugly, that good and bad taste of which La Bruyere speaks, and the reason for which must always be given by a theory of aesthetics. For example, take what is perhaps the simplest of the products of plastic art, a vase that is required by the conveniences of manufacture as well as those of use to have a rounded form. In such a case the question is no longer that of tracing its contour or, as geometricians say, its generating curve. The sole question is to know why one contour pleases and seems more beautiful to us than another. Now, if we consult those who have dealt with the problem thoroughly, 6 we shall find that after all ordinary forms have been put aside, in the use of which the only purpose has been the construction of a utensil without any pretense of satisfying the conditions of plastic beauty, the remaining forms arrange themselves naturally under a rather small number of specific types, each determined by the combination of a very small number of elements and by simple relations among their principal dimensions. The scheme of those conditions can be represented as determining, for each type of species, a system of points through which the curve of the form is required to pass, and which can be united in a continuous line which serves to determine the contour of the vase according to the taste of the designer, and which stamps it, so to speak, with the seal of his individuality. Now we understand that in order to answer to the idea that one must know the perfect form of the object under consideration, 4 things are necessary. First, its form must indicate clearly the use to which it may be appropriate, even though in reality it serves as an ornament or as an image of something rather than the thing itself. Second, the physical conditions resulting from this usage as, for example, the conditions of stability, should obviously be satisfied. Third, the subordination of incidental parts to principal parts must clearly result from the way in which they are associated and from their relative dimensions, and fourth, among the various relations capable of satisfying the above conditions, we choose by preference the simplest ***** 7 relations which are more pleasing, and not just because our mind is better able to grasp them, but because reason is offended by unnecessary complications by virtue of the same principle which makes it take offense at an absence of symmetry when there is no intrinsic reason why the symmetry of something should be disturbed, and because this manner which the human mind has of looking at things constantly finds its confirmation in the study of the phenomena and of the laws of nature. So much for the explanation of the fundamental conditions of what is done and for the reasons which, in a species, fix the points of reference of the profile. It would not be so easy to say what guides the taste of an artist in the apparently arbitrary sketching which must connect these points, nor would it be easy to say what leads us to prefer one sketch to another as more correct, more elegant, or more pure. But observation teaches us that in this part of his task the artist has to avoid 2 extremes, on the one hand, a stiff or formal style, and on the other, an affected or distorted style. Moreover, we understand that one of these extremes is offensive to us because it seems to reveal a servile constraint, the other because it indicates a capricious complication. That is sufficient to convince us that, independently of any arbitrary system, there must be a mean and normal form between these extremes. In short, the history of art informs us through a mass of examples of all sorts that the natural progression of the human mind in the arts is to begin with inflexibility and to end with affectation in performance. This is a subject for subtle analysis and one which involves some of the most interesting problems which remain to be resolved, problems of such a sort that it would seem very strange if an algebraist were to attempt to find their solution. 182. The poverty of language need not lead us to confuse affections which are of different sorts and are thoroughly distinct, even though they are closely associated in those complex phenomena which we call sensations and feelings. The sentiment we have for the beautiful is one thing, the pleasure of agreeable emotion which the spectacle of beauty gives rise to in us is something else. Just because a tragedy or an opera, although often mediocre, may affect us more than the sight of a picture, a statue, or a great piece of architecture, we must be on guard against concluding that there are in the play or in the opera beauties of an order clearly superior to anything that the art of Phidias or Raphael is able to produce. This is principally a matter of the ability to react to agreeable or voluptuous impressions which depend upon very changeable particularities of structure, to the point that often what pleases one person displeases another, and what has given pleasure at one time does so no longer. Intellectual taste, as it has been called, which is only one way of spontaneously judging the conditions of beauty, and catching sight of that in which it exists, has much more constancy and fixity. But so that the distinction may be clearer, it will be convenient to make a new approach to this problem and to start with the more homely effects of physical sensibility. An odorous or savory object acts upon the olfactory nerves and on those of taste in such a way as to give rise to a characteristic impression that we recognize as being the same, even though we may have acquired a aversion to the taste or odor which originally was agreeable to us, or vice versa. This follows from the fact that the sensory nerves may be affected in the same way and still provoke in the rest of the organism sympathetic reactions which are entirely different, according to the general disposition of the system as a whole or to that of some of the great sympathetic centers. One man will face with courage or even with serenity a physical pain which would cause another to faint. This is not because both do not experience the same sensation of pain in the nerves affected, but because the general make-up of one is formed in such a way as to resist the disturbance caused by local pain, or else the excitation communicated by moral causes produces the same results as an increase of physical force. In all these cases we see clearly that it is necessary to distinguish local and special sensations from the attractive and repulsive feeling which is connected with them, and which, being a very much more complex phenomenon, must have much less constancy and fixity. A similar statement might be made concerning colors, about which the adage assures us it is no more necessary to dispute than it is about tastes. A color which has pleased us may come to displease us, although the special function of the optical sensation certainly remains the same so long as the eye remains normal. Likewise, after having preferred the sound of a string instrument to that of a wind instrument, we may come to have an opposite preference, although the impression sui generis that the timbre of each instrument produces upon the auditory nerve is always the same. There is no distinction to be made in this respect between the two superior senses of sight and hearing and the inferior senses of taste and smell. But if the ear perceives a succession of different tones, or if the eye is struck by an assortment of colors, then harmonies and contrasts appear which are based, as physics brings us to understand, not on the particularities of organic form which vary from one person to another, or even on anatomical or physiological 274 v. traits native to the species, but on the very nature of the phenomena, the perception of which comes to us through the sense of hearing or of sight. 8. This explains well enough why the notion of beauty is connected with the sensations that we obtain from these two superior senses, while it is never associated with sensations of taste and smell. Consequently, the preference for the brilliant colors of a Flemish painting or the more somber tints of a Spanish canvas will depend on individual taste, according as one or the other is more in harmony with the condition of the nerves and the state of the mind. There will be, so to speak, a chromatic scale which will change from one master to another, or from one school to another, but whatever the influence of the master or the school on the general tone of the coloring, it will be necessary to apply the same rules to the relations of the colors among themselves, to their harmony and to their contrasts, and the observation of these rules will establish the beauty or perfection of coloring in all systems. Likewise there is a beauty and perfection in an air in music, which belongs essentially to the melody, that is to say, to the succession of sounds and to their relative intervals of tone and duration, no matter what the absolute value of the fundamental note may be, and even though there are preferences of individual taste in regard to the timbre and quality of sounds, depending upon the instruments and the voices used in playing the piece. 183. These individual preferences, upon which depend what in art is called style or manner, and what in matters that do not aim at aesthetic beauty is called fashion, must therefore not be confused with taste, which follows from the essential conditions of beauty, in conformity to a certain ideal. And it is no more necessary to confuse the perception of beauty according to a type which is constant and independent of the organism with the sensuous excitation which is connected with it. The vivacity of the latter is deadened by habit, although it may serve to give more persistence to our judgments of intrinsic beauty, and is so variable in other respects, depending as it does upon temperaments, upon the nature of the agents or of the materials used in the arts, and upon the way in which they act upon the organism. Now, when thought has abstracted in this way all the accessory and variable feelings which are connected with intellectual taste or with the perception of beauty, what remains, if not a faculty of pure reason, a way of judging and discerning in things the relations of order, fitness, harmony, and unity? Omnes porro pulchritudinis forma unitas est, Augustin said in a phrase that everyone cites, and which in fact would be the best definition of beauty if it were possible to define it and to include in one general formula that which presents itself under such varied aspects, in our eyes at least, and at the distance we are removed from supreme principles. We still prefer it to those definitions which are more modern and more mystical than they are philosophical, and which make beauty consist in a pretended relation between the finite and the infinite, about which it is very doubtful that the great artists had ever thought, and the study of which would, in any case, characterize the quest of a particular school rather than answer to the idea that men have always had about beauty. When this degree of abstraction is reached, morality itself may be considered, and often has been considered, a branch of aesthetics. In fact, some actions are morally beautiful as well as morally good, since they conform to those ideas of fitness, order, and harmony of which human reason is capable of conceiving the model and of proceeding with the application. As Plato insisted, it is at this point in particular that ideas of the beautiful and of the good are confused or tend to become confused. For if we prefer to reserve the epithet of the good for actions which presume a rare virtue, a generous devotion, and which excite in us a sentiment of admiration that we do not experience as a result of ordinary acts of honesty and beneficence, it is plain that it would be difficult to draw a clear line of demarcation between those falling on one side and those on 276. The other. It is also plain that the feeling of duty and the satisfaction that is experienced in carrying it out, or the remorse at having failed to do so, are affections of the mind which can neither be identified nor compared with the attraction that is felt for the beauties of nature and of art, or with the disgust that ugliness inspires. But as soon as these diverse affections of the feeling subject are removed, in order to consider only those aspects of the acts by means of which we apprehend the qualities of things which have a representative value for the understanding, we see that each depends upon the same superior faculty which seeks and finds order, harmony, and unity everywhere, and which, having found what it seeks, is convinced in that way of the legitimacy of its pretensions, and of the conformity of the general laws with the laws of its own nature. Chapter 13. On Continuity and Discontinuity. 184. As soon as our intellect begins to distinguish among perceptions, it acquires the notion of distinct and similar objects, such as the stars in the sky, the pebbles on the seashore, and the trees or animals across an expanse of open countryside. In this way we derive the idea of number, the simplest and most common of all our abstract conceptions, and the one which contains in rudimentary form the most useful as well as the most perfect of the sciences. 1. Even though man, deprived of all or of some of his senses, were to have no knowledge of external objects, it is conceivable that the idea of number might be suggested to him through his consciousness of what occurs within him, as a result of his attention to the intermittent reproduction of identical or analogous internal phenomena, provided his faculties were not condemned to inactivity in other respects. Number is conceived as a collection of distinct units. That is to say, the idea of number implies three things at one and the same time: the notion of the individuality of the object, the notion of the connection or continuity of its parts if it has parts, and the notion of the separation or discontinuity of individual objects. Even though the numbered objects are physically contiguous, reason must distinguish them, and we must be able to consider them separately, in spite of the fact that this contiguity or continuity is accidental and in no way inherent in the nature of the numbered objects. Stones do not cease to be naturally distinct objects simply because they touch one another, and the cement which sometimes holds them together does not prevent the recognition of fragments of rocks of different sorts and origins which existed prior to their being mixed. When specific numbered objects and, consequently, collections of those objects can be compared with respect to quantity, the quantities established by such collections are called discrete or discontinuous. Only in one of the objects which make up such a collection is added or removed, the collection passes abruptly from one state to another without passing through intermediate nuances and without imperceptible gradations. While we understand that this property of individuality or discontinuity is characteristic of a great many objects which we perceive, others have a contrary characteristic. For example, just as in the case of a pile of pebbles, we think of the water which fills a vase as a quantity which may be increased or decreased. But whereas the pile of pebbles necessarily undergoes abrupt changes in its volume, weight, and form when pebbles are added to or removed from it, the flow of water into or out of the vase results in a continuous variation of the weight, volume, and height of the liquid in the container. This variation is such that these different quantities pass from one condition to another only after having passed through an infinite number of intermediate stages, however nearly adjacent to one another one may imagine the different quantities to be. 185. In the example we have selected, the continuity may be only apparent and relative to the imperfection of our senses, for perhaps the liquid is only a collection of particles which differ from larger pebbles and whose individuality eludes our senses only because their dimensions are so extremely small. But in other cases, the notion of continuity comes from a rational examination independent of sensible experience. It is indeed only through such an examination that the idea of continuity and, consequently, the idea of continuous mass can be understood in their absolute exactness. Thus we necessarily conceive that the distance from a moving body to a body at rest, or that between two moving bodies, can change only by passing through all the unlimited or infinite number of intermediary distances which separate them. The same thing is true of the time which elapses during the passage of bodies from one place to another. All geometrical quantities, lengths, areas, volumes, and angles are called continuous quantities because they evidently have the property of increasing and decreasing continuously. The same thing is true of the quantities dealt with in mechanics, such as velocity, force, and resistance. In general, when a physical quantity varies because of the passage of time or only because of changes in the distances between molecules or material systems or as a result of both these factors, it is contradictory to suppose that it passes from one determinate value to another without having gone through all the intermediary values in the interval. But, in the imperfect condition of our knowledge about the structure of material media, we are justified in admitting, for certain physical quantities, as we can conceive and define them, disruptions of continuity resulting from the sudden passage from one finite value to another. Thus when two dissimilar liquids, such as water and mercury, are superimposed, we regard density as a quantity which varies sharply at the point of contact between the surfaces of the two liquids. This is the case even though all inferences lead us to believe, and although it may be philosophical to admit, that the disruption of continuity would disappear if we could take complete account of the structure of the liquids and of all the modifications which occur near the surfaces where they are in contact. Physicists and mathematicians no longer admit the existence of what were called discontinuous forces, that is, of forces to which were attributed the ability to change suddenly the direction of the movement of a body and to make it acquire or lose a finite velocity instantaneously. It is generally recognized that the forces in question, which are developed on the occasion of the impact of two bodies, for example, are not unlike the other forces of nature, such as gravity, which require a finite time to produce a finite effect. Today forces which were formerly called discontinuous are no longer distinguished from others except by the property of using up their energy in a very short time, which is ordinarily imperceptible to us because of the inadequacy of our senses and of our means of observation. For example, when an elastic band strikes an obstacle, the sudden change which seems to us to occur in the direction of its movement and in its speed only appears to be sudden. In reality, the body is insensibly distorted and gradually loses the speed with which it was propelled. After that, molecular reactions restore it to its original form and impress on it another speed in a different direction. All this occurs in such a brief interval of time that it is beyond our ability to estimate it, and hence we cannot grasp it, although we cannot doubt the succession of the different phases of the phenomena. 280. In the same way, when a ray of light seems to us to be bent suddenly in passing from one medium to a second contiguous medium which has a different density, it actually changes direction without discontinuity. The new direction is connected with the old through a portion of a curve whose dimensions are too small for us to detect. 186. In the idea we form of lines, angles, forces, durations, and so forth, the attribute of continuity is found to be associated with that of magnitude, and we think of the latter as a homogeneous whole which may be divided, at least by thought, into any desired number of perfectly similar or identical portions. This number may be increased more and more, for there is nothing to limit its being increased indefinitely. The notion of magnitude is immediately connected with that of measurement. A magnitude is considered to be known and determined when we have indicated the number of times it contains a specified magnitude of the same sort which has been posited as a standard of comparison or as a unit. All magnitudes of the same sort, of which the latter is an aliquot part, are then represented by numbers. Since the unit may be divided and subdivided according to some law into as many aliquot parts as may be wished parts which in their turn may be regarded as derivative or secondary units, it is clear that, after the standard unit has been chosen arbitrarily and the law according to which its successive divisions and subdivisions are to be made has been arbitrarily fixed, any continuous magnitude whatsoever allows a numerical expression of any desired degree of approximation. This follows from the fact that it necessarily falls between two magnitudes which are capable of an exact numerical expression, and the deviation from which may be reduced as much as we may wish. Continuous magnitudes, expressed numerically in this way by means of an abstract or conventional unit, become quantities, or are what we call quantities. Thus, although the idea of quantity is altogether simple, and although it has generally been considered as a fundamental category or an original idea, it is not really one. The idea of quantity is constructed by the human mind by means of two truly irreducible and fundamental ideas, those of number and size. Not only is the idea of quantity not primary, it also implies something artificial. Numbers exist in nature, that is to say, they subsist independently of the mind which observes and conceives. Them, a flower has 4, 5, or 6 stamens, with no possible intermediary, whether it does or does not occur to us to count them. Continuous magnitudes are likewise found in nature. But quantities appear only because of Th6 arbitrary choice of a unit, and because of our need, a need which springs from the nature of our minds to have recourse to numbers for the expression of magnitudes. For when numbers apply to the measurement of continuous magnitudes, the term unit evidently takes on another meaning than the one it has when it is applied to the numbering of objects which are individual and truly single in nature. Philosophically, these two meanings are quite properly opposed to one another. This is an inconvenience which results from the nature of ordinary language, but it is a lesser inconvenience than having recourse to a term that is not sanctioned by usage. On the other hand, both the philosophic meaning and the analogies of language are simultaneously offended when the name quantity is applied to pure numbers and to numbers which designate collections of truly individual objects, by calling them discrete or discontinuous quantities. The merchant who delivers 100 feet of wood or 20 horses does not deliver quantities but numbers or quotas. If we are interested in 20 hectoliters or 1,000 kilograms of wheat, the delivery will actually concern quantities and not quotas. This is so because we compare the grains of wheat considered collectively to a continuous mass with respect to volume or weight and have no interest at all in separating or numbering individual grains. A sum of money may also be considered a quantity because it represents a value which is a continuous magnitude, and then counting the pieces of money, a process that gives a number that may change even though the total amount remains the same, is only an auxiliary operation devised for the purpose of measuring the value of the money more quickly. 187. In conformity with the common definition, we give the name quantity to anything which is capable of being increased or decreased. But a great many things which are not magnitudes, and which consequently cannot be quantities, are capable of being increased and decreased, and even of being increased and decreased in a continuous manner. A painful or a pleasurable sensation increases or decreases and goes through various degrees of intensity with no sudden transition from one to another. Yet it is impossible for us to fix the precise instant when it first begins to appear and when it becomes completely extinct. At least, this is undeniably the way things happen in a great many cases. If, at other times, a pain seems to begin or end suddenly, to increase or diminish by definite increments, there is every reason to believe in this case too, just as there was in regard to the impact which suddenly changes the direction in which a body is moving, that the discontinuity is only apparent, and that in reality the phenomenon is always continuous. This is the case even though we may confuse at any moment the duration of phases whose sequence escapes us because of the imperfection of that internal sense that we call psychological awareness. Sensations of pleasure and pain, however, have nothing in common with the mathematical notion of magnitude. It cannot be said that a more intense pain is the sum of weaker pains. Yet in going through its continuous modification, sensation often passes from pleasure to pain or inversely from pain to pleasure, after passing through a neutral condition which, in many respects, recalls the decrease of certain magnitudes in the passage from positive to negative quantities. But this neutral condition cannot be regarded as resulting from an algebraic sum or from a balance of pleasures and pains. 188. It is true that through the study of anatomy and physiology we come to see how the continuous variation of intensity in a sensation of pleasure or pain may be connected with the variation of certain measurable magnitudes and depends on the continuity inherent in extension and duration. For we recognize that the greater the size of a nerve too among members of the same species, the greater the intensity of the painful experience which results from the irritation of the nerve. A certain intensity of pain corresponds to each unit of area of the cross-section of the nerve, provided all other conditions remain the same. But this correspondence or relation is in no sense mathematical, since the attribute of measurable magnitude which belongs to the area of the transverse section does not belong to the sensation. 4*. If a person plunges his hand into a bath having a temperature of 40 degrees and leaves it there for a sufficient length of time, he experiences at first a sensation of apparently sudden cold. Following this, assuming that the bath does not become cooler, the sensation weakens gradually and without shock, in such a way that it is impossible to fix the precise moment at which the sensation ceases. All other things being equal, the intensity of the sensation depends upon the time elapsed since the moment of immersion, and the continuity in the passage of time gives sufficient reason for the continuity of the variations of the intensity of the sensations produced. But this sensation must not be thought of as a measurable magnitude that can be related to a unit and expressed numerically. Since the velocity of the vibrations of a sounding body or of the ether are measurable and continuous quantities, a sufficient reason is seen why the passage from the sensation of one tone to that of another, from the sensation of one color to that of another takes place with continuity. But that does not mean that there are numerically assignable relations among the different sensations of tone and color, as there are among the velocities of the vibrations which correspond to them. The sensation of the tone G is not equivalent to 1.5 times the sensation of the tone C simply because the velocity of the vibrations which produces the sound G is 1.5 times that which produces the sound C. The sensation of orange is not 5/7 or any other fraction of the sensation of violet, simply because the velocity of the vibration of the ether in the case of the orange ray is nearly 5/7 of what it is for the violet ray. Continuity in the variation of the intensity of the power of attention or of sensuous appetite will be fully explained by the continuity in the variation of certain physical and measurable magnitudes, such as the velocity and abundance of the blood, or the electric charge on or the temperature of certain organs, which have or may have an immediate influence on other vital forces. But this affords no basis for concluding that the attribute of being a measurable quantity belongs either to these vital forces themselves, or to the phenomena which they determine. 189. Just as the continuity of certain purely physical quantities is sufficient to enable us to submit the forces, affections, and phenomena of organic and animal life which are not measurable. 284. Quantities to the law of continuity, so we understand that these forces or phenomena, which are continuous but not capable of being measured, may introduce continuity into variations that permit forces or phenomena of a higher order which even more obviously lack the character of measurable quantities. If, among men in particular, the phenomena of the intellectual and moral life depend upon or presuppose those of animal life, as the phenomena of animal life in their turn depend upon or presuppose the general phenomena of the physical order, then the continuity of the fundamental forms of space and time would be sufficient to make us presume the continuity which is habitually observed in matters relating to the web of organic forms, of life, and of thought, with respect to matters pertaining to the intellectual and moral orders, which are liberated most mediately from the conditions of animal sensibility and those of materiality. In a word, the continuity of space and time would suffice to make reasonable the old scholastic adage, as invoked by Leibniz, natura non jacet saltus. This does not hinder us from supposing, if we wish, that the continuity in the cases of the intellectual and of the moral order has still other bases or grounds than the continuity of space and time, nor does it keep us from admitting, with Leibniz, that continuity in all things comes directly from a higher law of nature, of which the continuity in the phenomena of extension and duration is only a particular manifestation. 190. In the development of intellectual faculties, sensations which are accompanied by perceptions, that is, representative sensations which are capable of giving rise to images which persist or which the mind can reproduce after external objects have ceased to act on the senses, come after purely affective sensation. Now, for the very reason that sensation is representative or that it gives rise to images, it is perfectly clear that a continuity or discontinuity in the intellectual phenomenon of the image corresponds to the continuity or discontinuity of the object. If I think of the constellation called the Big Dipper, the image present to my mind is that of 7 twinkling points, clearly distinct from one another and arranged in a certain pattern, but if I recall the view displayed before my eyes when I had reached the summit of a mountain, my imagination is no longer presented with a collection of a determined number of points. What I remember is a continuous and harmonious whole, into the details of which I cannot go without finding other details in them, and so on to infinity. The same thing is true of sensations that come to us through other senses than those of sight, and to which, by extension, we also give the name images. Thus, after having heard a musical air, I may be able to recall perfectly the series of notes which compose it. In this case, my perception will be made up of a system of distinct and discontinuous perceptions. But, if my recollection involves all the impressions that I experienced on hearing this piece performed by a talented singer, including the timbre, accentuation, and modulations of voice that cannot be woven into a score, I should once more catch a glimpse of the infinite nuances in the harmonious and continuous whole. All this has been verified and expressed 1,000 times in all the forms of language. Discontinuity or continuity is found in the data of memory not only because of the nature of the objects upon which recollection rests, but also because of the nature of the forces and conditions upon which the acts of memory depend, whatever these are and whether they are organic or hyperorganic. It is often noticed that after making a long effort to recall a name, a date, or a historical fact, the recollection of the forgotten item occurs suddenly and by surprise. At other times we have a vague and confused remembrance, the features of which clear up little by little until they attain a perfectly definite form. 191. We say of an image that it is faithful, of an idea that it is true. By this we mean to express the conformity between the object or the type perceived and the image or the idea presented to the mind. If the conformity is rigorous, the idea is said to be exact or adequate, but modifications of the idea which alter this rigorous conformity may, depending upon the case, admit of continuity or discontinuity. In this way there may be a sudden transition from truth to error or, on the contrary, a continuous degradation of truth. Everyone knows that the portrait of a person, or the picture of a bit of landscape may be more or less faithful, and that there are infinite nuances in this resemblance. This does not make it possible, however, either to achieve a perfect or exact resemblance or 286. To draw a line of demarcation between what resembles, although imperfectly, and that in which the resemblance disappears completely. We say that a portrait is or is not a true likeness, and we point out certain portions that are better than others, but we would not think of making a tally of the truths or errors found in the portrait. A geographic map may be regarded as a sort of portrait. However, it is a part of the daily task of geographers to reveal and compute the errors in a map. This is why their attention rests so exclusively upon a certain number of prominent points which may be fixed exactly, at least within the limits of precision consistent with our instruments and our observations. These points are noted or forgotten, they are or are not in the exact locations that accurate observations assign to them. Where they are concerned, there is a place for an enumeration of truths or errors. However, when we turn our attention to the continuous lines which connect the landmarks and which serve to show the course of rivers, the indentations along a coast, or the contours of mountains, resemblance is only more or less approximated. It is no more possible to count and balance truths and errors mathematically in this sort of portrayal than it is in any other. In the memory I have retained of a musical air, I may mistake one note for another, an F natural for an F sharp, and should I play the air on an instrument like the piano having definitely determined intervals between its notes, I shall make a mistake or an error, because there are no intermediate degrees between consecutive keys on the keyboard. But when an artist wishes to imitate the playing of a rival on the violin or on the French horn, the imitation will be found to be only more or less faithful. It will be said that an auditory image of this sort is or is not true. But no one would dream of trying to calculate truth or error in such a situation. 192. The fidelity of a portrait, the resemblance of an image to its prototype admit of progressive variations, and their progression falls under the law of continuity, but that does not mean it is something measurable. There is no standard 0F measurement for that species of truth to which we properly give the name resemblance. Let us reduce this analysis to the simplest and the most mathematical terms. If, in order to make a copy of an ellipse, point 1 draw another ellipse having the same relation between the long axis and the short axis that is found in the first, the resemblance, or to employ a technical term used by mathematicians, the similarity, will be perfect. Now, if we conceive of a series of ellipses in which this relation, which is a measurable quantity, varies continuously, the individual figures will resemble the first one less and less in proportion as they become more extended and more flattened. This resemblance will depend upon the smallness of the deviation between the fixed value of the relation in the ellipse taken as the prototype and the variable value of this relation in the series of copies. We shall nevertheless be unable to determine this error quantitatively on the basis of a mathematical law, which we like to think of as the measurement of similarity or dissimilarity, except by means of a purely conventional and arbitrary rule. With still greater reason, if, in order to duplicate some sort of an oval curve other than an ellipse, and one which is not amenable to mathematical definition, a curve is traced which more or less resembles the one in question, the resemblance being such as to permit innumerable intermediate degrees, then it would be impossible to measure or to evaluate the resemblance numerically. It is the very nature of things and not simply the imperfection of our theories and our methods which puts an obstacle in the way of such an evaluation. Similarly, if we compare one triangle, which remains constant, to a series of triangles in which the angles and the relations of the sides undergo progressive and continuous alterations, it would be impossible to assign a function of the angles and the relations of the sides which would be the natural measurement of the resemblance to the invariable type without using an arbitrary stipulation. 193. We are faced with an entirely different problem when a question comes up concerning the picture of a living creature and of the expression of that indefinable characteristic that we call physiognomy. We are always struck by the singular fact that a silhouette, a photograph, or a bust cast from life may show less resemblance than an engraved or pencil portrait by an artist. This reflection takes full account of the superiority of the version obtained by art over the version to which it seems that nature has made the major contribution. For example, a picture sketched on a plane surface is a projection of the object in relief, and it is possible that in the most wisely chosen projection almost insensible. 288. Nuances of form which characterize physical individuality and more especially moral individuality are effaced and obliterated in such a way that the artist who is endeavoring to express just these nuances can do no better than feign a projection which is geometrically impossible. He will be able to strengthen or exaggerate traits in such a way as to have, however, only the exact expression of what he must portray. He will not be reproached for making these exaggerations, in the sense in which this term is used by artists, if he actually overdoes not the lines which identify the form of the drawing, but the physical, intellectual, and moral characteristics that the strokes must depict. This is a resemblance of another type than geometrical similarity or resemblance, but one of such a sort that in portraits which resemble one another in a similar way, the technique or style of painting will be very clearly recognized. Each painter attains the same degree of resemblance in his own way and by substantially different techniques. In short, this type of resemblance is even much less susceptible to measurement and evaluation than is a purely mathematical construct, although its progressive alterations may always be subject to the law of continuity. If the painter is commissioned to make not a family portrait, but one of a historical personage whose physical features reveal little of value except that they have the merit of indicating forcibly the most notable characteristics of an intellectual and moral personality, he will have to be satisfied with other circumstances of resemblance. He must make the picture less a geometrical or physical and more an ideal reproduction. This progress toward the ideal will become even more marked when, in representing an allegorical type or a sacred figure, the common forms of humanity appear only to the extent necessary to give substance to the idea that the artist must present and wishes to present. 194. The tendency of art toward the expression of an ideal conceived by the mind, without either a logical formula to define it or a mathematical method for approaching it, is so obvious a thing that no one has ever denied it and that it may perhaps have been exaggerated in the subtle refinements of modern criticism. We have reached the point of making the artist too philosophical, and, on the contrary, we have not sufficiently noticed that in the expression of a pure idea, in so far as it is only an object of knowledge independent of any intention of pleasing or impressing, the On Continuity and Discontinuity 289. Philosopher is also and cannot help being an artist after his own fashion. Deceived by the nature of the institutionalized symbols to which they are forced to have recourse, men have pictured their ideas to themselves as so many units, ciphers, or monads, and they have supposed that the whole business of thought consists in systematically combining or grouping these individual objects. It always seems possible to count the truths and the errors scattered through a book, in the same way that an astronomer makes a catalogue of the stars, or that a public official takes the census of a city, or, even more, in the same way that the propositions contained in a treatise on geometry or the errors of calculation missed by an editor of tabular data are counted. However, although falling outside the realm of sensible phenomena, if the object of the idea is one of those which permit continuous modifications, the character of truth which consists in the conformity of the idea to its prototype and of the expression of the idea with the idea itself will likewise admit of continuous gradations. In that case, it will be clearly possible to say that a given person had come closer to the truth than another, but it will not be possible to enumerate the new truths of which he is the inventor. Everyone will evaluate the worth of this approximation in his own way and will form an opinion about this sort of resemblance, without being able to refute with precision those who do not adopt his evaluation and who contradict his opinion. The inaccuracy of the picture of an animal is obvious to a naturalist if the number of toes, teeth, feathers, fins, and so on which characterize the species are not found in it. In such cases we find errors which may be taken account of and established without debate because there is no intermediary, no gradual shading among 3, 4, and 5 toes. On the contrary, a painter, whose attention is never fixed on the characteristics which serve in the methodological classification of species, finds the physiognomy or external aspects of the animal portrayed with more or less fidelity. If his judgment is contested, all he can do is to appeal to those who, like himself, have a feeling for the form of the animal and for the skill shown in the portrayal. He is no more in a position to appeal to a formal proof than I am able to prove to a man that a painting has failed to catch his likeness, if illusion or caprice leads him to find a resemblance in it. 195. A botanist has committed an error in his description of a 290. Plant. Two imperfectly developed stamens have escaped his notice because of their smallness. As a result, he has put a species which should have been grouped with those which are heptandrous into the pentandrous class of Linnaeus. A more attentive observer, or one who is not misled by an accidental monstrosity, will correct this error with the use of nothing more than his eyes and a magnifying glass. Once this has been done, the error should not appear again, for the botanical description of the species will have been definitely cleared up and, in return, it will have been enriched by a precise, positive, and incontestable fact. But let us imagine that the flower is subject to an imperfect development which is constant, normal, and specific, that the two stamens are so modified in the course of their development that their functions are further and further removed from those of the ordinary stamen. Let us further imagine that because of this fact one botanist may put the plant in one of the families in which the presence of 5 stamens is a distinctive characteristic, while another botanist evaluates the relative importance of the characteristics differently, and, distinguishing what is essential and persistent from what is accessory and variable in the structure of the organs, again places the plant in one of the families having 7 stamens. How will the difference between the two men be settled? No doubt on the basis of the judgment of the botanists whose opinions are considered most authoritative. How is that judgment formed? It cannot result from an experimental demonstration that falls within the ken of the senses, and still less from formal arguments like those which are used by logicians and mathematicians. For if, on the one hand, there are cases in which this transformation of organs shows itself only as a secondary phenomenon which should not escape the eye of a naturalist more experienced in closer resemblances, on the other hand, as we go from metamorphosis to metamorphosis, we should not know when to stop, and in the end we may confuse things which are most unlike. Here truth and falsity tend, so to speak, to be based upon one another. Truth does not show itself as a light uniformly illuminating a clearly circumscribed area, but rather as a flash of light which becomes weaker after leaving its source, and the track of which the eye is able to follow for a longer or shorter distance depending upon the tone of its sensibility. And no one can say, for the purpose of invalidating the example, that the problem of knowing whether to classify a plant or an animal in such and such a family is purely a matter of nomenclature and of method. A truly natural classification, and indeed any classification in so far as it is natural, can be nothing but an expression of affinities which connect organic beings closely among themselves and of laws to which nature is bound in varying or modifying organic types. These laws subsist independently of our methods and of our artificial procedures, just as do the laws governing the movements of inert matter, although they may neither be expressed in the same way in terms having a rigorous exactitude, nor established by measurements which are precise, or the precision of which has no limits other than those which follow from the imperfection of our instruments. In general, as we have tried to demonstrate in the next to the last chapter, alongside of artificial abstraction, which is only a fiction of the mind and one which is suited to its instruments and needs, is placed rational abstraction, which is simply the conception or the ideal representation of the bonds which nature has placed among things and of the subordination of phenomena. But, because of the continual efforts of the mind to achieve an understanding of phenomena, there is almost always a mixture of the two sorts of abstraction and a continual transition from one to the other. The bonds of solidarity, of kinship, of harmony, and of unity which we try to grasp through rational abstraction may be more or less stretched or eased, yet our mind experiences the same need for classification, regularity, and method in dealing with all objects of nature. As far as possible, a critical philosophy must begin with artificial and rational abstraction, by basing itself upon inductions and probabilities. Now, as we have already explained, it is the essence of philosophic probability to yield to continuous alterations or progressions, without implying that this probability can be evaluated numerically, and without its becoming a numerical quantity after the manner of mathematical probability. Thus, under whatever aspect the subject may be viewed, we find that the law of continuity prevails in that intelligible world in which the thought of the philosopher searches for the principles and the reasons for sensible phenomena, no less than it does in the material world which falls under the senses. 196. In the sphere of moral ideas, nothing is more evident than the continuous transition from one to another and from one quality to the contrary quality. Murder inspired by a passion of malevolence or cupidity is one of those great crimes which arouses a general public censure, and to the repression of which every member of society, according to the nature of his functions, readily lends his cooperation, except for perversions of custom of which we cannot take account here. On the other hand, if only the natural feelings of a person are consulted, moral sympathy and approbation will continue to be won by any person who avenges by murder, and at the risk of peril to himself, the offended honor of persons of whom he is the natural protector. Purely human laws will be unable to triumph over that natural feeling. Between these extreme cases there are murders that some will censure and others will excuse. A human authority will find it impossible to fix the exact point at which criminality ceases and devotedness, not to say virtue, begins. Even when the status of the act is not doubtful because of the circumstances under which it is perpetrated, we are aware that the moral responsibility of the agent and the perversity the act presupposes may permit an infinite number of nuances, depending upon the age, the sex, the temperament, and the education of the culprit. The interest which attaches itself to the defense of the accused among civilized and humane people must not be permitted to disregard that truth when dealing with cases of great outrages which call for severe repression by penal laws. But the case is the same with respect to the notions of equality, of honesty, and of decorum, as it is with that of criminality. It is legitimate to draw a profit from one's work and from one's capital, to prefer to do business to this end with those persons who offer the most advantageous conditions, and even to make one's profit larger in proportion to the risk of loss which one runs. The most honest man can do all this without in any way prejudicing his reputation. Yet we justly stigmatize with an odious name a person who makes a business of speculating in goods necessary to life during calamitous times, or who lends his money at excessive rates on coming into contact with those whom wrong conduct, lack of foresight, or misfortune force to submit to his power. Now, is it possible to say precisely at what point usurious profits begin? Whether we are dealing with wheat, money, or any other sort of merchandise? Is there a line of demarcation such that it suffices to stay on one side of the line in order to lay claim to scrupulous integrity, and which one needs but to cross to come to be likened to the most dishonest persons? This conclusion is obviously distasteful. It must be admitted, on the contrary, that with a more delicate feeling for the morality of his acts, such a trader will restrain the temptation of personal interest more rigidly and will have a right to a higher place in our esteem, without making it necessary to condemn absolutely anyone who goes beyond the former self-imposed limits. When the rate of interest on money is fixed by a positive law, we fully understand that a formal censure should, or may, overtake anyone who exceeds, by however small an amount, the legal rate. In such a case moral censure follows from the infraction of a higher law, namely, that by which citizens are morally bound to submit to the positive laws of their country in matters which follow from the discretionary power of the legislator. The intervention of this power must be considered as having precisely the purpose of introducing an artificial discontinuity where none has been placed in the nature of things, as will be shown later. In the histories of any people we read of governments which have been established through the misuse of force and through the violent upsetting of certain institutions which had long prevailed. Power gained in this way is said to be usurped, in contrast with legitimate powers that create and maintain the regular operation of the institutions of a country. But, on the other hand, institutions are continuously being modified. Changes that the course of events produces in these institutions, even when quite sudden, create new rights and exclude outdated claims, and yet it is impossible to indicate in any other way than by legal fictions or the needs of the parties involved, where illegitimacy ceases and legitimacy begins. Even here the nature of human affairs, in contrast with certain theories for the use of speculative minds, maintains continuous transitions among terms which remain perfectly distinct so long as attention is fixed only on the extreme cases. The abuse of logic and of casuistry in politics as in morality consists in not taking account of the continuity of transitions and in wishing to apply the exactness of definitions, formulas, and 294. Logical deductions to things which are incompatible with it because of this very continuity. On the contrary, the practical good sense of people and statesmen consists in accurately apprehending the relations between things at the point at which they have insensibly introduced forces the nature of which is to act progressively, slowly, and without intermission or discontinuity, and in protesting against the absolute systems of some arrogant minds whose error is not in setting up a theory, but a false theory, and who believe they are making use of logic when actually they are abusing it, by applying it to things to which it is impossible for it to be adapted. 197. We hope to demonstrate that the distinction which is best suited for clarifying the theory of human understanding is that of the continuity and discontinuity in the objects of thought. This is the case whether we are dealing with sensible phenomena or with qualities and relations which are purely intelligible but which subsist among things or in things independently of the mind which conceives them. We claim that this distinction gives the key to the most common acts of the mind, as well as to the methods the use of which is reserved to philosophers and scientists, at the same time that it takes account of a great number of the details of social organization. In short, we maintain that, as a general law of nature, continuity is the rule and discontinuity the exception in the intelligible and moral order as much as it is in the physical, and for ideas as much as for images, and that, if this important fact has been misunderstood or if one does not apply oneself sufficiently to developing its consequences, lack of application must be attributed to the nature of the symbols which are for us indispensable instruments in the work of thought. The remaining parts of our study will be especially devoted to the development of these consequences, with which logicians generally have been so little concerned. We will say that continuity is quantitative or qualitative according as it concurs or does not concur with measurability. But in thus opposing quantity and quality, it is not necessary to consider them as general attributes, as Aristotle and his successors did, that is, as predicates or categories of the sapere order. On the contrary, in justice to the idea, it is necessary to understand that the relation between these predicates or categories is that of species to genus, or of the particular, or, rather, of the singular case to the general. It follows from this that, if the singular species were to be abstracted in order to put it in opposition to all other species, by conserving the generic name in this collection, the reason is that, because of its importance, the singular species acquires for us a value comparable to that which the generic idea, in contrast, has preserved by its extension, or by the innumerable variety of specific forms that it is able to cover. 198. Thus, to use a comparison, the circle may be considered as a kind of ellipse. It is a species of ellipse in which both axes are equal and in which, consequently, the two foci coincide in the center. But it is not simply a particular species lost, so to speak, among the innumerable multitude of all those which can be obtained by varying the relations of the axes in any manner whatever. It is a singular species, and one which it is convenient to consider by itself, for two reasons. First, because the properties common to the whole genus of ellipses undergo very remarkable modifications and simplifications when we come to the case of the circle. Second, because all ellipses may be considered as projections of a circle seen in perspective, and because by thus connecting the generation of ellipses with that of the circle as the ancients did we find in the properties of the circle the reason for all the properties of the curves included in the genus of ellipses. In the same way, the continuous variations of that singular species of quality which we call quantity are amenable to the regular methods of determination which are possible in the case of no other quality. Furthermore, in the present state of our knowledge it is permissible to think that the continuity of every qualitative variation is a necessary consequence of the continuity inherent in the quantitative variations upon which the others depend. No doubt, variations characterized by qualitative continuity depend in addition on other principles whose action, on being applied to the forms of space and time, leaves its specific mark on each of these variations. And it is possible that these elements may themselves be capable of continuous variation, but of a sort which is not quantitative or measurable and which is entirely independent of the quantitative variation inherent in the forms of space and time. So the qualitative continuity in subordinate variations does not proceed solely from a quantitative continuity in certain primary data. This is indeed, if you will, probable, but not demonstrable, and, for OMA purposes, we are not required to detain ourselves for a discussion of this hypothesis. 199. Depending upon the circumstances, a variation of quantity may be thought of either as the cause or as the effect of a variation of quality. But, in either case, in so far as the question depends upon it, the human mind tends to reduce every variation in the quality of things to a variation in quantity for which we have regular methods of determination and expression. For example, in almost every case it would be impossible to measure the pleasures and enjoyments or the inconveniences and disadvantages which are connected with the consumption of any kind of goods, or with the possession of property of any sort, in comparison with advantages or inconveniences connected with the consumption of another good, or with the possession of property of another sort. At first, all such factors have a very irregular influence on the discussions between buyer and seller. Later on, when the transactions are more numerous and more frequently repeated, they quickly have a mutual influence on each other, a current price is established, and a definitely measurable quantity, namely, the purchase value of real estate, of a commodity, or of a service is found to depend upon non-measurable qualities. This dependence follows from the development of social organization and from the need that man feels, as a result of the peculiar structure of his faculties, to reduce to numbers and to processes of indirect measurement things which by their nature are least susceptible to direct measurement. Are we not led to make use of numbers even in cases in which the problem is to classify numerous candidates on the basis of their knowledge and intelligence by means of examinations and competitions? As if it were possible to evaluate the erudition, sagacity, and keenness of the mind. Indeed, we are well aware that the small number of judges is reason enough why the figures which they choose are very unreliable. On the other hand, we realize that if we were able to bring together a sufficiently large number of competent judges so that anomalies of individual judgment would offset each other, we should obtain an average result which would give, if not the exact measurement, at least the exact gradation of the excellence of the various candidates, as this is revealed through their examinations. Nothing varies more with circumstances and is less directly measurable than the criminal character of an act or the moral responsibility which attaches to the commission of a crime. But although legislators have wished to leave to the judges the power to take account of all the possible gradations of the offense and of deciding the severity of the punishment, they must indicate the kind of penalties to be imposed, such as a fine or a temporary imprisonment, and these are perfectly measurable quantities. The gradation of penalties would then accurately reflect the gradation of the offenses at least as these appear to us and to other men like us if the number of judges were sufficient to compensate for any fortuitous errors among individual decisions. Even though it is sometimes clumsy and premature, the prodigious development of what is called statistics in all branches of the natural sciences and in social economy stems from the need of measuring in a direct or indirect way everything that is measurable and of establishing by means of numbers everything that permits of such determination. This is true even though statistical numbers most often measure only very complex effects, and effects which are very far removed from those which would have to be known in order to have a rational theory of phenomena. It is because they did not recognize this law of the mind that philosophers from Pythagoras to Kepler vainly sought for the explanation of the great cosmic phenomena in ideas of harmony which they mysteriously connected with certain properties of number considered in themselves and independently of the application that could be made of them to the measurement of continuous quantities. True physics was founded on that day when Galileo rejected these long sterile speculations and thought not only of the idea of examining nature by means of experiments which Bacon also proposed in his own way, but of stating precisely the general form to be given to experiments, by setting up as their immediate object the measurement of everything in natural phenomena which is capable of being measured. A similar revolution was made in chemistry a century and a half later when Lavoisier ventured to submit to balances, that is to say, to measurement or quantitative analysis, properties to which chemists before him had applied only the type of analysis which they call qualitative. 200. What is the source of this singular prerogative which the ideas of number and quantity have? On the one hand, it comes from the fact that the symbolic expression of numbers may be systematized in such a way that with a limited number of conventional symbols, for example, our written numeration, which consists of only 10 characters, we are able to express all possible numbers, and, consequently, all quantities commensurable with those that have been taken as units. On the other hand, it arises from the fact that, although incommensurable quantities cannot be exactly expressed in numbers, we have a simple and regular technique for giving them a numerical expression approximating whatever limits our needs require. From this, it follows that the continuity of qualities presents no obstacle because we express them all by means of combinations of a limited number of distinct symbols, and because, in this way, we submit them all to the operations of calculation. The error resulting from this can always be indefinitely reduced, or have as limits only those which are produced by the imperfection of our senses in the exact determination to primary data. Metrology is the most simple and the most complete solution, but only in a particular case, of a problem on which the human mind never ceases to work. This problem is to express qualities or relations in terms of continuous variables, with the aid of syntactical rules applicable to a system of individual or discontinuous symbols and necessarily limited in number because of the convention which institutes them. The three great innovations which, in modern times, have successively extended the domain of calculation, namely, the decimal system of numbers, Descartes' theory of curves, and Leibniz's infinitesimal calculus, are fundamentally nothing but three great steps taken in the art of applying conventional symbols to the expression of mathematical relations governed by the law of continuity. 201. The matter needs no further explanation where the invention of our decimal arithmetic is concerned. Descartes' idea was to cease making the distinction in algebraic formulas between known and unknown quantities as had been done prior to his time, but to make it rather between quantities which are constant, because of the nature of the problem, and quantities which are variable without being disconnected. In this way the essential purpose of an equation or algebraic relation became that of establishing a dependence between the variations in the one and the variations in the other. This was promoted by means of abstraction, for, whereas in the older algebra, with nothing to specify with respect to the numerical values of certain quantities, mathematicians had always had in mind quantities which had become fixed and in some degree stationary, now what the mind grasped, embracing as it did a continuous series of values which includes an infinite number of values, made evident the law of the series rather than of the values themselves. Simultaneously with his discovery that algebraic symbols, which were originally designed to represent numbers or discrete quantities, were thus suited to exhibit the law of a continuous series, Descartes invented another device which made this law clear and gave it a form and a description. By means of the path of a curve, he depicted the ideal law already defined in algebraic terms. As a celebrated modern writer has said poetically, he was not content to apply algebra to geometry as the word to the thought, he reciprocally and figuratively applied these two great mathematical ideas or theories to one another, and he obtained from both symbolic expressions which are singularly appropriate, each in its own way, to sustain the human mind in its investigation of more hidden truths and of still more general and abstract relations. Above all, we are indebted to this invention by Descartes for clearing the ground for the third important discovery we have mentioned, that of the infinitesimal calculus. This was destined to replace the complicated and indirect methods based on the reductio ad absurdum, or on the consideration of limits. What is called the method of limits consists in initially positing a fictitious discontinuity among things actually subject to the law of continuity, For example, by substituting a polygon for a curve, a series of impacts for a force acting without intermission. Then the limits are sought which the results obtained continuously approach when we restrict the abrupt changes so that they follow one another by smaller and smaller intervals, and, consequently, since the total variation must remain constant, each individual change becomes smaller and smaller. The limits found are exactly the values which hold in the case of continuous variations, and these values are found to be determined in this way in conformity with an exact, though indirect, procedure, since this passage from the discontinuous to the continuous is not based on the nature of things, but is simply a logical device suited to our methods of demonstration and calculation. The complication of this artificial scaffolding was hindering the progress of the sciences until Newton and Leibniz conceived the possibility of directly fixing the view of the mind with the aid of suitable notations. The former fixes this view directly on the unequal rapidity with which continuous quantities tend to vary, while other qualities on which they depend undergo uniform variations. The latter fixes it directly on the relations among elementary and infinitely small variations of diverse quantities which depend upon one another, relations whose law contains the true reason for the progression that the variations of these same quantities conform to, so that we can observe them at the end of a finite interval. From this was developed the infinitesimal calculus, the peculiar virtue of which is that it enables us to understand directly the fact of the continuity in the variation of quantities, and which consequently is adapted to the nature of things, yet not to the way the human mind proceeds, since nothing but finite variations are perceptible and capable of being grasped directly by it. Thus, when in cooling a body continuously emits heat, the loss of temperature that occurs in any interval of time whatever, no matter how small we may assume it to be, is really a complex fact, resulting, as if from its cause, from the law according to which the body continuously emits an infinitely small quantity of heat during each infinitely small interval of time. The relation between the elementary variations of heat and of time is the reason for the relation which is found between the variations of these same quantities when they have acquired finite values. Similarly, the space through which a freely falling body passes in yielding to the action of gravitation varies proportionately with the square of the time elapsed since the start of the fall, because the infinitely small space traversed during each moment is proportional to the acquired velocity, and, through an evident result of the continuous and constant action of gravitation, this velocity is proportional to the time elapsed from the moment the body began to move. From this very simple relation between the elements of the elapsed time and the space traversed is derived, as though from its cause, the less simple law which connects both the finite variations of these two quantities. In this sense it may reasonably be said that the infinitely small exists in nature. This statement is legitimate not because infinitely small quantities can fall within the domain of imagination or of sensory perception in any way, but because the abstract and purely intelligible notion of infinitesimal elements, far from being an abstraction whose origin is artificial and adapted to the nature of the mind and to the way in which we conceive and imagine things, is rather quite the opposite of this, since it is directly applicable to the way in which natural phenomena come into being and to the expression of the law of continuity which governs them. This is the reason why Leibniz's calculus, which gives to the infinitesimal method the assistance of a regular system of symbols, has become so powerful an instrument, has changed the appearance of pure and applied mathematics, and constitutes by itself alone an invention of capital importance, the credit for which belongs entirely to this great philosopher. 202. The methodical and indefinite approximation of the continuous through the use of the discontinuous is possible not only in questions dealing with relations among quantities in the strict sense. It is equally adapted to relations of position and configuration in space, which have the additional property of being capable of being implicitly defined by means of the relations among the quantities. Thus, whether or not we have considered the length of a curve and the area of the surface it circumscribes, we shall be able to determine with an unlimited approximation their bearing, their deviations, and their sinuosity, or, in short, all the accidents which relate directly to form and not to size, provided we have exact methods for determining as many points on the curve as we wish to choose, and provided these points may be brought nearer to one another indefinitely. Indeed, When we wish to unite these independently determined points by a continuous line, the hand of the person drawing the line will be guided by a feeling for the continuity of forms which cannot be translated into fixed rules and which does not permit of a rigorous analysis. This will be a matter of art and not of method. But the closer the reference points are to one another, the more restricted will be the limit of deviation among different figures drawn by differ. 302. And persons, depending upon whether their hands are more steady and more skillful, or whether they follow the direction of a mind endowed with surer and clearer perception of the continuity of forms. Everyone knows the process used to copy a design or an image of the two dimensions so as to preserve or change its scale. We break up the surface of the model and the surface on which the copy is to be made into corresponding squares. Then we copy square by square in such a way as to restrict the possible deviations of the copy between limits that approach each other more and more as the number of squares is increased. In this way less and less is left to the skill and the taste of the artist, to the clarity of his perceptions and to the steadiness of his hand. Workers who reduce the block for sculptors have an analogous technique for reproducing somewhat methodically and mechanically in marble the figures for which they have the clay model made by the artist, by sharpening up the figure, as we say. This does not exempt the artist from later giving his work those final skillful and physically scarcely noticeable touches, in connection with which method is of no help, and of which the artist alone has the secret. Basically, and however bizarre this comparison may seem at first glance, the administration of justice and of public affairs constantly depends upon a similar device. Rules are established, as we shall explain later on. Limits are set up so that the conscientious evaluation of an expert, an arbiter, a jury, a judge, or an administrator is kept within more or less narrow bounds. Evaluation rebels at analysis and consequently breaks loose from rigorous control. But since it is no longer a question either of magnitude or of extension, or, in short, of any quantitative continuity, the nature of things is averse to whatever would systematically organize a method of progressive and indefinite restriction, and the nature of things is also averse to whatever, at each step taken by a method of systematic restriction, would make a precise accounting of the approximation obtained by such a method. 203. It is evident that every logical rule which promises or seems, in theory, to promise an unlimited exactness, leads in practice only to a limited exactness, since it requires, if it is to be applied, the intervention of faculties or the use of instruments whose perfection is limited. It is possible to carry to any desired length the whim of indefinitely extending such a series of decimals as that which results from the calculation of the relation of the diagonal of a square carried to its side, or that of the relation of the circumference of a circle to its diameter. Once the rule for such a calculation is discovered, we say its application is mechanical. This does not mean precisely that it could be carried out by an automaton. It indicates, rather, that since the rule prescribes a series of perfectly distinct and determined acts, both may be controlled by persons who apply it in such a way as to give quasi-certainty to the correctness of the resultant. Now, if on the basis of this rule we are dealing with the problem of expressing numerically the length of the diagonal of a square the side of which has been measured, the precision of the measurement is necessarily limited, since the perfection of the senses and of the instruments used are necessarily limited. Hence, in the application of calculation or of logical rules, it would be fanciful to exceed the limit of precision imposed by the operation of measuring. If it is not possible to agree closer than a decimeter in the measurement of the length of a side, it would be unreasonable to carry the calculation of the diagonal into millimeters or fractions of a millimeter. When we reach fractions of this order, the lack of precision in the data would take away any significance so far as the precision of the calculation is concerned. This may seem like a very simple thing to point out. Yet it has very frequently been lost sight of in the application of mathematical processes to the physical sciences. Without considering in detail all the circumstances which must have an influence on the limit of precision of often very complicated observations and measurements, an illusory precision has been effected in calculations or in certain details of experiments. This apparent precision is inconvenient not so much because it involves useless exertion and work, as because it gives the mind a wrong idea of the result obtained. An illusion of this type, but one much more difficult to discover and destroy, may deceive us as to the range and results of those administrative and judiciary rules by means of which it has been proposed, and not without good reasons, to limit the discretionary use of certain powers and the arbitrary latitude of certain appraisals. Because reason might be entirely satisfied with 304. A system of such rules, it would be necessary that the appraiser checked at one door if we may be allowed this trivial image might not go out through another, that in imposing one part of the rules of procedure or of minute, consistency, a latitude may not be left to the judge in the appraisal of certain facts, or to the accountant in the administration of certain affairs, which destroys the guarantees purchased as a consequence of the fulfillment of annoying or expensive formalities. In a word, it is necessary to be forewarned against the abuse of formality in public affairs, as well as and for the same reason that it is necessary to be cautioned against the abuse of calculation in physics. The reason is that there are limits to possible precision, that in matters related to practical or experimental determinations, rules would only be empty forms, dead letters, without the intervention of those forces which spring from the principle of life, the continuous development of which eludes measurement, rule, and control. No doubt, there is much that is vague in these generalities, as in a great many other logical rules. In what follows we shall try to indicate some applications that can be made of them in a more special and better established order of facts. 204. If one of the habitual devices of mathematicians is to assume initially a fictitious discontinuity where there is actually continuity, once this artifice has put them in possession of rules for measuring the continuous, they quite frequently have had recourse to a contrary device, which is to posit a fictitious continuity where there is actual discontinuity, for purposes of reducing calculation and making it more convenient. By such means, they obtain only approximations of true results, but these are so arranged that the approximation is sufficient, while exact calculation, although theoretically possible, would in fact be impracticable because of the excessively long operation it would require. This device of the mathematicians, which is especially useful in the calculation of chances and of mathematical probabilities, resembles fundamentally that which is practiced every day in the most ordinary circumstances. Thus, instead of counting grains we measure them as though the grains formed a continuous mass. This is done because it is recognized that if the grains are of the same kind, the relation of volumes does not differ appreciably from the relation between the two large numbers. On continuity and discontinuity 305. Which would express the number of grains in the measured volumes, if one had sufficient patience to count them. This is also true when, in banks, sacks of money are weighed instead of counting the coins, although the value of the coins, when they circulate as money, is legally accounted by the piece and not measured by weight, or may be independent of variations in weight from one coin to another provided these variations, which are continuous in their nature, do not exceed certain legally established limits. In general, if man's mind is bound, by the nature of its organization and by the form of the tools that it uses, to substitute habitually an artificial discontinuity for the continuity in things and, as a result, to note degrees, break up lines, and set up divisions on the basis of artificial and, to a certain extent, arbitrary rules, then there is also reason to put into practice the opposite device and to treat the discontinuous as though it were continuous, by breaking away from systematic and rigorous procedures whose application is impossible because of the time and energy they require. Thus, although we had exact methods for putting in perspective an object like a machine or an architectural decoration, all the parts of which are capable of being defined mathematically, the designer, the painter, or the theater decorator will apply these long and difficult procedures only to the principal points which will serve him as landmarks, and he will leave the rest to his dexterity as artist. Similarly, in social affairs, at each moment we come to conclusions about chances the exact evaluation of which, while not theoretically impossible, would in fact be impracticable because of the immense amount of calculation it would entail, or, rather, about chances the evaluation of which, while not requiring much time, would demand much more than the habits of society and the rules of the game would be disposed to allow it. In that case it is necessary that such an estimation of chances be made instinctively and spontaneously by a sort of sense whose acuteness springs from a natural aptitude or from exercise, and that constitutes what is called the spirit of the game, or skill, or knack. This applies not only to games but also to trading, to military tactics, and to a great many other things in which man needs to be guided by the light of a sudden inspiration, even in things which by their nature would not absolutely rebel against an exact analysis and rigorous thinking. Chapter 14. On Language T. 205. A language is a system of symbols, necessarily limited in number, which must be associated and combined according to certain rules, and which are intended to furnish man with means for making known his sensations, ideas, feelings, and passions. On the basis of this simple statement, plus what has been said in the preceding chapter, we should understand that in most cases the purposes of discourse can be attained only imperfectly. The work of the orator, and consequently that of the writer, is analogous to that of the mosaic artist who has been given nothing with which to copy a natural object or an ordinary picture but an assortment of stones whose colors and dimensions are fixed in advance. It is clear that such an artist will be able to reproduce only approximately the colors and the contours of the objects which he uses his talent to imitate. Vocal articulations and the representation of these articulations in ordinary handwriting are not the only symbols nature has put at man's disposal for the communication of his thoughts. The advantages of spoken language over written discourse come primarily from accessory signs used in speech, such as accent, intonation, gesture, movements of the eyes and face, and the speeding up and slowing down of delivery. These lend themselves to the needs of infinite shadings, similar to those of the thoughts being expressed, and to some extent they fill in the intervals and breaks in language and, to use a common expression, paint word pictures. That is to say, these accessory signs re-establish continuity of the sort that would be found in that kind of image which is the most perceptible, and to which, consequently, we like to compare all others. For these reasons we should not be surprised at the preeminence of spoken language, not only when dealing with description, narration, and exhortation, but even when, in the mouth of a skillful teacher, it is used with the intention of bringing to light abstract truths and of making known relations which 306 permit of an infinite number of nuances and continuous gradations, and doing so as effectively as the lines of a pencil sketch or the tones of a picture. When we read a discourse, a lawyer's plea, or a written lesson, we are not surprised that we find in it only part of the emotions, the images, or even the purely abstract conceptions that its oral presentation would excite. On the other hand, it is clear that all these signs which make up the accessories of spoken language, and whose ordinary, everyday use is the object of the art we call oratory, remain limited for most men to the translation of the simplest affections of the sensibility. They are left with what must have been the first rudiments of language, and which make up what grammarians call onomatopoeia. It is true, the art of gestures has been perfected and systematized for the use of deaf mutes. This systematization, however, is the work of persons whose whole education has been gained under the influence of ordinary language. That alone is sufficient to indicate that the figurative and conventional language of which they are the authors is simply a translation of oral speech, and that while it has kept the advantages of conventional language to a large extent, it has also retained its imperfections. 206. Language is so intimately connected with the products of our intelligence that the Greeks used the same word to designate both language and reason. At first, it must seem to be impossible to distinguish what depends upon the nature of our intellectual faculties from what depends upon the form of the instruments they use. How can we judge what form of development our intellectual faculties would have taken had they used instruments and symbols of another sort, of which we can form no precise idea? Would the loss of language result in the perfecting of other means of communication, other systems of representative symbols, as happens when the loss of eyesight ordinarily leads to the perfecting of the sense of hearing or of touch? The example of what would happen to deaf mutes if they were left to themselves is not conclusive, for they live in the midst of men accustomed to speech, whose efforts cannot correspond to theirs, and above all, among these persons placed in an anomalous position, we do not find that transmission of efforts from one generation to another which is the essential condition of all human progress. But in 308, instead of setting up systems upon empty fictions, we may at this point make some general remarks which are basic to the subject. 207. A language would be quite poor if it consisted only of onomatopoeia or of vocal signs having natural relations to the things signified. Any other type of perceptible signs would also offer little assistance if we used only those which naturally have the property of calling up the idea of the thing signified, and if we had no recourse to symbols which have been established or given a conventional value. But the number of such symbols cannot be unlimited, so that they correspond to every object of thought. There must be laws of combination or syntax for such symbols having prescribed forms which can be kept in the mind until they become habitual, so that attention may proceed to the matter of meanings without being distracted by syntactical form. Now, how can these syntactical laws be adapted to anything other than individually determined elements, and how could the products of such a combinational synthesis vary without discontinuity? From this it must be concluded that the radical imperfection of language comes from the discontinuity of its elements, which in turn, results primarily from the abstract nature of conventional symbols and not from the physical characteristics which they specify. In other words, the imperfection of language is connected with the property of the form and not with what may be called the matter and perceptible content of the symbol. On the one hand, nature has sought to subordinate the operation of human thought and the development of human intelligence to the use of perceptible signs. On the other hand, the only development possible for a system of discontinuous signs is one which parallels the development of thought. It follows that one of the greatest handicaps to intelligence must result from this clash between the essential nature of signs and that of most ideas. This is a handicap against which the mind has struggled ever since it began to develop, and a handicap from which it has sometimes been fortunate enough to free itself, but which in other respects holds it in eternal infancy. A meditative mind will recognize in this discordance between ideas and signs one of those details in which nature seems accidentally to deviate from its general plan of continuity and harmony. For philosophy and the human sciences, those eminent products of thought upon 309, which we rightly pride ourselves, are, after all, only incidents in the history of nature and even in that of humanity, the result of a somewhat exaggerated development of faculties which seem to have been given to and for a much less ambitious purpose. 208. This is not to say that conventional symbols other than words may not have been superior to language in other respects. In fact, man invented writing only to remedy one of the greatest inconveniences of speech, that of being a short-lived symbol. The period in which the invention of writing occurred may be regarded as the critical period in the history of the human mind. The direction impressed on the later development of thought had to depend on the form taken by this great invention. We are beginning to lift the veil which has hidden those distant times, and to recover vestiges of the elaboration by which the system of graphic symbols was definitely fixed, at least among the great families of peoples in the midst of which philosophy and the sciences were destined to emerge from their infancy. Thanks particularly to the ingenious work that has been done in Egypt since the opening of this century, we are beginning to understand how writing which consisted at first only of general signs to which analogical symbols were soon added, then of symbols which were purely conventional but were still independent of language, and finally admitted conventional symbols has tended more and more to become an indirect symbol, a simple conventional representation of spoken language, until this revolution was systematized by the invention of letters and of the alphabet. From then on writing has been nothing more than language made permanent and stripped of some of its sensible accessories. We are tempted to wonder if this complete subjection of the graphic symbol to the word, which was completed with the invention of a written alphabet, has been more favorable to the development of the human mind than the coexistence of two systems of independent symbols. Our numerical figures and algebraic symbols are inventions which give evidence of the utility of ideographic writing independent of language. Descartes' conception, to which we have already called attention, furnishes a no less remarkable example of the importance of a graphic and conventional symbol especially adapted to the nature of the thing signified. It has been said, and it is natural enough to believe. 310. That written Chinese makes possible certain niceties of expression, certain beauties of style to which nothing in the spoken language corresponds. We must, however, consider a number of factors in this connection. The ideas expressed by means of arithmetical or algebraic characters are only a small number of those which permit an exact determination. The continuity of forms of the understanding could never be adjusted according to a regular and systematic method in the conventional representation of qualitative variations. For this reason all ideographical writing would remain an art rather than a method, or would become a method only by losing its special advantages, and by permitting the existence of the inconvenience of two independent and heterogeneous languages, the habit of using which would have to be acquired, and which would continuously have to be translated into one another. If we keep these things in mind, we shall understand how the invention of a purely phonetic language, by simplifying teaching, must at least have facilitated the raising of the average level of minds, and contributed powerfully to the progress of what is properly called civilization. 209. Without pushing this discussion further, let us make some examination of how language, which is, so to speak, our sole mode of expression with respect to abstract matters, and which results essentially from the association of discontinuous elements according to certain syntactical laws, may lend itself more or less to the production of types which are modified with continuity. Let us also examine how in general the expression of the continuous is accomplished by the discontinuous, a thing which becomes so simple in the particular case of quantitative continuity. The reason of philosophers has not proposed this question. Men have solved it without being aware of doing so during the slow course of the formation of languages. Most of the constitutive elements of language have not been given a fixed, determined value, like that of each number or each musical note, considered in its tonic relation to a fundamental note. Words which are essentially distinct may assume identical forms as a result of a fortuitous coincidence, especially in very mixed languages. Furthermore, the same words may be used with a determined number of clearly distinct meanings because of the original poverty of language, or because of our need not to weigh memory down. 311. With too great a number of different forms. 1. Finally, if the same word is considered in each of its several meanings, we shall most often find that these meanings vary between limits that it is sometimes possible and at other times impossible to assign, or in other cases we shall pass through imperceptible nuances in going from one meaning to another. 2. Now, the trick in the use of language consists principally in determining the precise value that each element should receive, or at least in reducing to some extent the field in which intermination is found, so far as the nature of things makes this possible. This is done by referring to the context of the discourse, and by means of mutual reactions among the elements which compose it. It is, therefore, necessary to amend the comparison made at the beginning of this chapter, and to assume that the mosaic artist, wishing to represent a flower, or some other object, has at his disposal fragments whose colors are changeable, and which are able to affect us differently depending upon the reflections and contrasts of surrounding colors, instead of fragments whose colors are fixed and constant. In such a case, the skill of the artist would consist in placing the colored bits in such a way that their mutual reflections and the resulting contrasts would reproduce as faithfully as possible the shadings characteristic of the object imitated. 210. In order to correct the essential imperfection of language which results from the impossibility of expressing exactly ideas which are subject to continual modification and expressing them by means of combinations of distinct artificial symbols, the most common expedient is to multiply symbols or create new words. As a matter of fact, it is easier to increase the number of keys of an instrument the tones of which are fixed than it is to imitate the skill of an artist who knows how to draw out of a few strings all the tones possible within the musical range of the instrument. But while a rough approximation may sometimes be obtained in this way, this advantage hardly ever compensates for the demands on memory and for the amount of work necessary to make new words familiar. Finally, reason, in harmony with taste, recognizes that the true resources of language consist in that elasticity of its elements which gives them more or less extension, and in the reaction these elements exercise upon one another in the exact determination of their individual values. *_V. When the process of thinking bears on precise objects or relations whose variations are not continuous, when it deals with fixed ideas and definite combinations of fixed ideas, it would be unreasonable to have recourse to devices of approximation instead of the rigorous methods that may be used. Consequently, in that case the creation of new symbols and new terms is as legitimate and profitable as it is of little use when it tends merely to establish one arbitrary interpolation in a series in which there are an infinite number of possible intermediary shadings between one term and another. All sciences which give precision to ideas that remain vague among laymen, or which give rise to combinations of ideas unnecessary in the ordinary conduct of life, must, on that account, use special or technical terms. But it must be pointed out again that the sciences draw a good deal less help from the creation of technical terms than they draw from a technical method for the derivation and association of terms. This amounts to saying that the establishment of syntactical rules for combining symbols is generally a more fruitful institution than the creation of new symbols. Thus, the invention of a syntactical form, as ingenious as it is simple, produces all the advantages attached to the use of our arithmetic. The clarity of modern chemical nomenclatures is derived in this way from the system of associating root words, which make evident, in the expression of each compound substance, the presence of the chemical radicals which enter into it and the way they are associated in the compound. At least this is the case to the degree that the nomenclature is understood. 211. Furthermore, it must be kept in mind that language is not only used as an immediate symbol of thought, for if this were the case, its utility would be quite limited. Language is also used as a mediate symbol, in so far as it evokes other symbols which are more suited to the immediate expression of thought. In fact, what do we call figurative language? It is not solely, as rhetoricians have always believed, a means of making an impression on the sensibility, and of stirring the passions by means of images. For, were this the case, when we have recourse to cold reason, when we speak to the understanding about purely intellectual things, all figures would have to be given up. And yet it is easy to see that philosophical language is no less figurative than that of orators and poets. Philosophers constantly proceed by means of 314 comparisons with sensible objects, and those who have wished to make this a matter of reproach in their predecessors have in their turn fallen into the same fault, if indeed it be one. But, far from being a fault, it is a fruitful device by means of which we remedy defects which are native to language and enable it to contribute indirectly to the representation of abstract ideas to which it is not directly adapted. Since the fundamental law of the human mind is that it can raise itself to the conception of the intelligible only by relying on sensible symbols, as soon as language, in itself, ceases to be appropriate for the representation of the intelligible, it clearly becomes necessary for us to call other symbols to our assistance. We select these symbols from among the phenomena of the external world and those which occur within us. We choose them above all, on the one hand, from among phenomena having extension and movement, because these are the most simple, the most fundamental, and those whose image has the greatest representative clarity among all the phenomena subject to the law of continuity, and because the obstacles to the direct expression of our ideas by means of language arise primarily from the discontinuity of vocal symbols. On the other hand, we select them from among the internal phenomena of desire, will, and passion, that we do not imagine at all in the way we do external objects perceived by the senses, but of which we have an internal awareness. When looked at from this point of view, discourse is no longer simply a system of special symbols, a distinctive set of symbols more extensive than algebraic language, but devised for analogous functions. It is rather a framework set up to bring together the most diverse symbols, not directly and, as it were, personally, but through representation by means of vocal symbols which recall them. This property of language seems to be taken account of when the name poetry is reserved preeminently for the art of depicting nature and of arousing the passions by the aid of a language whose exalted form distinguishes it from ordinary speech. Yet the poetic conception may be the essence and, as it were, the soul of all art, and in that way there may be a close kinship among all the arts in spite of the diversity of physical techniques by means of which they are carried out, and in spite of the variety, or rather, the heterogeneity, of sensible materials that clothe poetical thought. 315. But if it is true, as people come to agree, that the artist may propose some other end for his endeavor than pleasing or exciting, that he may be motivated by a philosophical idea and seek to reproduce it in his works under the forms and by means of the expressions which are best suited to him, then there are the very strongest reasons for recognizing that the poetical and figurative forms of language are often a means and sometimes the unique means for the expression of philosophic ideas. In this way philosophy is related to poetry and art, although, on the other hand, it is closely related to the body of scientific knowledge, as will be explained later on. What is more, the strictest science also has its poetic and figurative language, images which we could not prohibit it to use without doing essential harm to its conciseness and neatness and to the clarity of its statements. 212. If the same thing is true of poetry, eloquence, music, and the plastic arts, that is true of those sisters of whom the poet speaks. Not one face in all, nor yet diverse. Everything that is remarkable in the distinctive characteristics of the art of speaking must also be noted attentively. If chemistry is able to furnish painters with new colors which are more vital and more durable, if the invention of new instruments enables the musician to conceive new orchestral effects, what is this increase in material riches to the genius of the artist, when compared to the resources that the poet, orator, or writer may find in a more harmonious, richer, or more flexible language? The artist, like the writer, is shaped in the school of his master. He carries on its traditions and is inspired by the works of his predecessors, but he makes use of material which is, as it were, raw and inorganic in comparison with that wonderful organ which is called language, into all parts of which life and thought penetrate. The genius of the poet or the writer must control this organ, this living machine. He must take it as it is when destiny offers it to him, in its infancy or in its senility, or better, he must know how to make use of its youth or of its vigorous maturity. Not only does language extend or restrict its vocabulary, gain or lose idioms. 316. Purify or corrupt its syntactical rules. Its words are also like coins, the imprint on which is effaced, worn away, or depreciated in circulation, the proper meaning of words falls into oblivion, analogies that have successively introduced various figurative meanings are lost from sight, the agreement that reason demands is no longer found between ideas and images, between thoughts and their sensible expression, and between the material construction of the elements of the language and their representative value. Neologism and archaism, bizarre combinations of words, forced and affected figures of speech, are born in the search for an expressive power which language, in its pure condition, seems to have lost by too long usage. These remarks, which are of so much interest to the philosopher, have often been made, but nowhere will they be found more cleverly expressed than in the elegant preface put, in the name of the French Academy, at the beginning of the 6th edition of the dictionary. Perhaps it would indicate bad form for us to insist at further length on matters which seem to require a delicacy of feeling, a cultivation of literary taste having little compatibility with the dryness of our ordinary studies and with the didactic exactness which we hope to approach in this work, so far as the subject makes it possible. 213. At least, we are able to see, from the preceding discussion, what must be thought of the project of a philosophic and universal language about which the greatest geniuses of the 17th century, Bacon, Descartes, and Pascal, dreamed, but which Leibniz in particular projected, according to his own testimony, to the point of giving serious consideration to the means of carrying it out, as is indicated by passages which have been cited many times. 3. This philosophical language or characteristique universelle, as he called it, which was to be based upon a catalogue of all simple ideas, each one being represented by a symbol or by a catalog number, would have had this advantage over all ordinary languages. It would have used elements having only fixed, determined, and invariable values, with the result that as a consequence of its very perfection, it would have been entitled to the claim of universality. Algebra would have been simply one branch of this symbolic system. All the work of thought would have been manifested by combinations of symbols. The art of reasoning, which would have been to arithmetical or algebraic calculation as the genus is to the species, would, in its turn, have had to be regarded as nothing but a special application of the combinative synthesis, or of the art of forming, classifying, and enumerating combinations. This comparison itself should put us on the trail of an important error with which the idea of a universal symbolism is tainted. How limited the application of arithmetical or algebraic calculation would have been, if they had been concerned only with quantities capable of being expressed exactly by numbers, and freed from the law of continuity. The nature of the idea of magnitude allows us to apply to continuous magnitudes, within whatever limits of approximation we may desire, the processes of calculation directly applicable to discrete quantities or quotas. But disregarding this singular case, how can qualities and relations which vary in a continuous manner be expressed in general with suitable approximation, by means of discontinuous or distinct symbols, which are limited in number, but which have fixed and determined values? In any case, how would the approximation obtained be defined? Condillac and the logicians of his school, whose ideas agree on this point with those of Descartes and Leibniz, a fact which should be noted because it is so rare by perhaps exaggerating the power of the institution of language in general, exaggerate above all the imperfection of individual languages, as usage has fashioned them, by contrasting them endlessly to that ideal type which they call a well-made language. Now, on the contrary, it is in its abstract nature or in its general form that language must be considered essentially defective, while spoken languages, slowly formed under the lasting influence of infinitely varied needs, have warded off that radical disadvantage, each in its own way and depending on its degree of suppleness. In accordance with the genius and the destiny of races, under the diverse influences of zones and climates, languages are more especially suited to the expression of images, passions, and ideas of a certain kind. This is the source of the difficulty and often the impossibility of making translations, a difficulty which is just as great for metaphysical passages as it is for pieces of poetry. What would augment and perfect our intellectual faculties by multiplying and varying the means of expressing and transmitting thought, if it were possible, would be to arrange all spoken languages to suit our liking, and in accordance with the needs of the moment, and not to find already constructed this systematic language which would be, in most cases, the most imperfect of instruments. Of all the works of man, languages most closely approach those of nature in the way in which they are formed, in their slow growth and their ties of kinship, and in the periods of maturity and decadence through which they pass. They participate in some way in the life of a race or of a nation. Between languages formed in this way and the symbolic language, the project for which has intrigued philosophers, there is, so to speak, the same difference as there is between the eyes and an optical instrument, between the organ of speech and the harpsichord, between an animal and a machine. Certainly, when, as in manufacturing, we are concerned with the problem of producing an effect which is determined, precise, and measurable, and of such a nature that it can be divided or broken up into a system of distinct operations, work done by machines will advantageously replace the work not only of animals, but also of man himself. For on the contrary, the most ingenious machinist will never be able to replace the hunting dog with an automaton, that is, with a system of engines and wheels. In general, as soon as we have to deal with nuances, with continuous modifications, what creations of human genius could hope to equal the creations of nature? 214. In addition to algebra, which is, as everyone should recognize, the most extensive application of the principles upon which a universal symbolism would rest, the chemical nomenclature whose foundations were laid by Guyton V and Lavoisier, and the more ideographic than phonetic notation which Berzelius adapted to more modern chemical theories offer other remarkable applications of these principles. Thus, in its present form, chemistry is the most simple and the best defined of the natural sciences. It deals with ponderable bodies only in so far as they are reducible to a small number of fixed, determined, indestructible, and unalterable radicals. It combines these radicals in ponderable proportions which are fixed and determined in the same way. In a word, all the relations, the study and systematic coordination of which are the object of the speculations of the chemist, consist in combinations of elements which are discontinuous or are treated as such. But when we pass on to the study of the infinitely varied phenomena that life produces among organic beings, there is no more discontinuity, no more possible reduction to systematic combinations, or at least such combinations present themselves only exceptionally and by some sort of accident. Therefore, there are no absolute theorems, no more precise and exact methods, no more invariability in the value of elements of discourse when they must be adapted to the expression of facts of this order. The same thing is true, with even greater reason, when we pass from the description of the phenomena of organic and animal life to the phenomena of the moral and the intellectual life, or to the study of relations which arise from social life. 215. Moreover, it must be recognized that even in the context of discourse words often keep all or part of the indeterminateness that they would have in isolation, and yet it cannot be said that this leads to an imperfection in language. Are we not aware that the power of algebraic language is due in part to the graduated intermination of the symbols it uses, and that, on account of this intermination, the order of difficulties is found to be inverted in an advantageous manner? Geometric eons habitually represent by the Greek letter tt the relation of the circumference of a circle to its diameter, a relation that cannot be exactly expressed in figures, although the true value may be approximated as closely as anyone desires. This abbreviatory symbol is convenient because it makes unnecessary the writing of a rather long series of numbers in all the algebraic calculations in which the relation in question enters, and because it allows us to hold off until the end of the calculations the mathematical operations which may rest on the numerical value of this relation. This makes it much simpler to estimate any error that may have been committed, according to the extent to which the numerical value is approximated. But the principal advantage of the use of such a symbol comes about because it frequently happens that although it enters into the expression of quantities that we are comparing, it does not enter into the expression of their relations, and thus disappears from the final result that we had in view. The surface of a sphere having a radius of 1 meter and the surface of a great circle of the sphere are two quantities which cannot be exactly expressed numerically, because the number asterisk, which is, as mathematicians say, a transcendental number, and which cannot therefore be exactly defined or expressed by means of numbers, enters into the expression of them both. But the first quantity is always just 4 times the second, and the transcendence which is found in each is not found in the relation of one to the other. In the same way, terms whose meaning cannot be, or at least up to the present time have not been clearly circumscribed, do not cease to be in current discourse, with the intermination that is. 321. Inherent in them and with advantage to the movements and the manifestations of thought. Take the word nature, for example, understood in the active sense of natura naturans as the schoolmen understood it. No attempt can be made to fix its meaning exactly, by religious faith or otherwise, without resolving the most difficult problem of transcendental philosophy. Nevertheless, it is evident that its use can no more be dispensed with in science than it can be in ordinary conversation. On all sides, this warp of mysterious finality, of which neither the origin nor the goal can be scientifically demonstrated, appears to us like a guiding thread, with the help of which order is introduced into observed facts and which puts us on the track of things to inquire into. Even when it fails to apply, for the purpose of explaining the general harmonic system of the world or any particular harmony, to the intervention of final causes, to the principle of mutual reactions, or to that of the weakening of fortuitous combinations, we do not for that reason have any less need for expressing the idea of that harmony and its necessary consequences, and for expressing it in a language common to all, independently of every philosophical hypothesis and of every religious belief. This is why the most religious person, like the most zealous partisan of materialistic fatalism, uses this idea, subject to supporting on the basis of philosophic debates and religious disputes, the definition of the idea transcendent, wrapped and, as if deliberately, veiled under the expression destined for common or scientific usage, for which the definition is not required. And since we do not believe that the words to which these remarks apply are limited in number, we could just as well have taken the terms matter, force, substance, right, or any one of a great many others whose definitions, being essentially problematic, are the concern of transcendental philosophy and yet the uses of which cannot be dispensed with in scientific circles, before political tribunals and assemblies, in the practice of the arts, and in the most ordinary affairs of life. Yet the transcendental intermination with which these ideas are affected never causes the least ambiguity with respect to questions in which we seek to reach an idea of relation, as in the comparison of one right to another right, one force to another force, or one elementary substance to another elementary substance. In fact, in such cases it is understood that an elimination 322 must be made of the philosophic or transcendent ideas implied under these terms, the scientific definition of which is impossible. And it will be a great day when we have come closer to the notions which, as we see it, are indispensable for the full understanding of what is the essential character of philosophic speculations, in opposition to the positive sciences which are capable of indefinite progress, perceptual verification, and practical applications. 216. The observations we have made concerning terms with which essentially philosophical or transcendental ideas are connected may be applied equally well to terms whose value may someday be scientifically and incontestably defined but the exact definition of which has not been found up to the present time. It may be that a day will come when we shall define the idea of organic species positively. It is also possible that this precise determination implies the solution of the problem of origins, which decidedly lies outside the field of scientific observation and investigation. In all these cases this precise determination has as yet had no place, since the possibility of the mutation of species or of certain species is still being disputed, and because one naturalist sees a difference in species where another finds only racial variations, with neither the one nor the other being able peremptorily to distinguish the variation from the species. 6. But, on the other hand, this ambiguity is found in only a small number of cases in comparison with those in which all naturalists are in agreement on the distinction of specific types, although they do not have the same opinion as to what constitutes the origin and the essence of this specific distinction. Whence comes the basis for the obligation to speak a common language and to apply without disagreement in science terms whose definitions remain problematical among the schools. The solution of the problem may be postponed without postponing on that account the progress of botany and zoology. We discover, catalogue, and classify new species every day, and leave until a later date the matter of exact definition of zoological or botanical species, if that should become possible. In most cases, and in the present order of things, it is sufficient that the distinctions between the species be clear, whatever may be true in other respects of their origin and their fundamental cause. 217. When, in what has preceded, we speak of terms which it is impossible to define, we have not been thinking of definitions as understood by lexicographers and logicians. This latter will be the object of a special discussion in the following chapter. The words number and angle are not definable according to the notion we commonly have of definition, and yet the corresponding ideas are exactly defined or determined. Everyone conceives of them in the same way, even though it is impossible to set up with respect to this matter philosophic discussions worthy of serious attention. On the contrary, philosophy discusses and deliberates ceaselessly not only about the terms nature, force, right, and so on, but also about the ideas connected with them, the determination or definition of which would imply the solution of problems which it raises, but for which it cannot find truly scientific solutions, because it is possible to apply neither experience nor logical demonstration to them. Chapter 15. On Logical Roots and Definitions. 218 By roots, or radicals, grammarians and philologists mean a small number of words in comparison with all those that enter into the making up of the vocabulary of a language which ordinarily have a simpler phonetic form, being even most commonly monosyllabic, at least in languages which are not formed from the remnants of many others. These roots are words each of which, through its ability to receive inflections, word endings, and different modifications, becomes the stock of a family of words whose various accepted meanings may tend to approximate or differ from the full meaning of the radical. It is generally known in our day that the study of linguistic roots is one of the most interesting that can be proposed, and one which throws the most light, not only on the origins of peoples, but also on the development and the processes of the human mind. Nevertheless, such a word is a root in one language, while its equivalent is derived in another. A radical of this kind manifestly can and must be defined by a system of derived words. Therefore, a kind of inquiry is conceived the purpose of which would be to indicate, on the one hand, the words which must be regarded as primitive, and to include, on the other hand, the words which must be thought of as playing the part of secondary symbols on the ground that they are equivalent to a combination of primitive symbols. Such an inquiry would be independent of the material form of the elements of discourse in the different languages. Words of the first category are what we call logical roots. 219 For example, the word plan/eben in German, is a root in the grammatical and linguistic sense, and in the language of mathematicians, it designates an elementary and essential notion, but not a logical root or a logically irreducible idea. For plane is very clearly defined by saying that it is a surface upon which a straight line can be drawn in any direction. In Greek, a compound word, ri.irsov, is the scientific word used for expressing the same idea. To indicate the sort of solid that we call a cube, the account of which serves as a point of departure in the theory of the measurement of the volume of bodies, a frivolous game has provided from another very natural source the comparison of dice, and the word kphios, which was regarded in Greek as a root, has become the technical name of this solid. In German Virgil indicates both the piece used in games and the geometrical figure, but this word is connected with the root werfen, and is not itself a root. From irplu, the Greeks have formed the word irplapa, a word which, on the basis of its etymology, should be given to all bodies bounded by a plane surface or to all polyhedrons. Actually, this name is applied to only one group of polyhedrons, in which the cube is found to be included. Contrariwise, the Greeks resorted to the excessively compounded word raparizemvesovi, to designate a class of solids included within the class of prisms, and including the subclass of the cube. Yet there was no reason to raise it to this degree of complexity in one case rather than in the other. 220 Common languages, with which technical or scientific languages are necessarily connected, at least with regard to the material of which they are composed, must bear the imprint of man's relations with things, rather than the mark of the relations of things among themselves. Only after long effort, if at all, does man reach an understanding of the true principles underlying things. What is simple in things must often be represented as compound in the material of expression, and reciprocally. For the same reason, if we are to avoid a vicious circle, the role of logical roots, or of words that we give up the idea of defining, should, in general, belong to different words, depending upon whether we refer to the intrinsic structure of things, or take as our point of departure the first impression they make on man, without seeking to free ourselves from the conditions in which nature has placed us in the study of them. Thus, chemistry teaches us that oxygen and hydrogen are two non-decomposable gases which, when they unite in the proportion 326 of 2 volumes of hydrogen to 1 of oxygen, give rise to a compound substance to which the complex name oxide of hydrogen should be given, according to the rules of systematic nomenclature. But this substance is not one of those which is known only in the chemical laboratory. It is indispensable to the existence of man. Indeed, it plays the most important role in nature, with the result that philosophers long considered it as one of the 4 elements, and even as the one from which all the others were derived. In a word, this substance is water. So chemists have not fallen into the ridiculous pedantry of designating it by other than its common name. But this name, as used by them, is a simple symbol given to a complex idea which can always be broken down, and which actually is expressed in the complex term oxide of hydrogen, whenever the need for this arises. In the language of the chemist, the words hydrogen and oxygen are simple symbols, root words by means of which the chemical meaning of the word water may be completely defined. On the contrary, in common languages which must be adapted to the totality of natural relations that man has with external objects, and not to a certain determined order of special phenomena, the terms water, wasset, vswp are the true radicals from which the derivatives hydrogen, Wasserstoff have been derived. We will be consistent both with etymology and with the natural development of the human mind, if we define hydrogen as the chemical element, the combination of which with oxygen produces water, and if, after having shown that air is made up of a mixture of two gases, we define oxygen as that one of the two constituent parts of air which is required for respiration and combustion, and which acidifies objects with which it combines in certain proportions. So it is that, depending upon whether we look at the matter from one point of view or the other, the words hydrogen and oxygen, on the one hand, and those of water and air, on the other hand, exchange their roles of primitive and indefinable symbols, or of derived and definable symbols. Instead of a compound like water, with which everyone is so well acquainted, and of substances like hydrogen and oxygen, whose discovery in very modern times could have resulted only from experiments which were conducted with great learning, we could just as well have taken cinnabar, mercury, and sulfur as our examples. Everyone knows sulfur and mercury at least as well as the compound to which we give the name cinnabar, which is formed by the combination of these two simple substances. Consequently, it would be unreasonable to define either sulfur or mercury by means of cinnabar, and, contrariwise, we could hardly give a definition of cinnabar that would not at least allude to its chemical composition. 221. Note carefully that the chemical definition of water, oxide of hydrogen or, better still, the combination of oxygen and hydrogen, in the proportion of 2 parts by volume of hydrogen to 1 of oxygen, is complete in the sense that it excludes every substance other than water. That is, it fixes and determines unambiguously the thing to which the word applies, for there is no other body which, when analyzed chemically, could be broken up into hydrogen and oxygen in the proportions indicated. But the definition by no means makes known the whole group of properties and physical characteristics the idea of which the word water calls to mind. It would not excuse anyone who knows hydrogen and oxygen from, so to speak, making the acquaintance of water, if he wished to form an idea of the role the substance plays in any other matter besides chemical combinations. It is only in relation to this special kind of phenomena that the word water is identically equivalent to the definition of the chemists. What has been said of compound substances may equally well be said of chemically simple substances which we set over against them. Oxygen, hydrogen, sulfur, and mercury have a number of properties which can be made known only through experience. The number of these properties increases for us in proportion as these substances are observed more attentively. In the present state of knowledge, it is impossible to summarize all these properties by means of a definition which potentially contains them all. However, if by definition we understand a description with the help of which it is possible to distinguish a given object from all others or to recognize without ambiguity the object to which the word applies, then it will be possible to give a definition of simple substances as well as of compound substances. And that summary definition or description will allow more or less precision and brevity, depending upon the circumstances. Thus, by regard. 328. In the general notion of metal as being fully established, we shall be able to define mercury as a metal which is liquid at ordinary temperature, too, while it would be difficult to find so brief and trenchant a definition as this for other metals such as iron, copper, and silver. Mercury is clearly distinguished from other metals and is adapted to a number of uses for which it can be replaced by no other substance because of its property of being liquid at normal temperatures. 3. Yet, on the other hand, our knowledge of physics permits us to regard this property as only secondary and accidental, in the sense that no one can discover any connection between this property and other characteristics which everything leads us to consider essential and dominant, when we study the composition of substances considered by themselves, and apart from the fact that they are appropriate to our uses. Descriptions of the sort employed by Linnaeus, of which naturalists now make general use, are definitions of the same sort. They are designed to make known the species to which a certain name applies, or conversely, the name which is applied to a certain species, by the enumeration of characteristics which pertain exclusively to a natural species. But even the most extensive of these Linnaean descriptions would still be far from being sufficient to enable anyone to restore by a pencil sketch or to form a mental image of the animal or plant with which they are concerned. This is so because it is simply impossible to portray the infinitely varied modifications of form, color, and structure by means of words. Except for the triviality of the comparison, these summary definitions or descriptions might be compared to the description which appears on a passport. The description is sufficient to establish the identity of the individual, especially when his appearance presents a combination of very unusual traits or some accidental deformity. But, on this basis, it would be impossible to make a portrait which would give an idea of the likeness and of the expression of the person's face. * 222. We have been drawing our examples from concrete and tangible objects. But if philosophers are greatly concerned with the theory of definition, it is principally because they have in view the ideas in the conception of which reason makes use of its power of generalizing, abstracting, associating, dissociating, and elaborating in various ways the materials furnished it by the senses. The hierarchy of genera and species, upon which Aristotle based his theory of the syllogism should, by a necessary correlation, have served as the basis for a theory of definition, the systematic apparatus of which had the greatest importance in the eyes of the peripatetics of antiquity and of the Middle Ages. Thus Porphyry, followed by Boethius and all the scholastics, has given as the introduction to logic his treatise on the 5 modes, or the 5 rubrics on which the theory of definition and consequently the whole of logic depends. These 5 modes are genus, difference, species, property, accident. For difference is what is added to the idea of genus to form the idea of the subordinated species. Property designates a quality which belongs exclusively to the species, and which is found in all the individual members of the species, but does not constitute it, or is not its essential characteristic. Accident is that which fortuitously distinguishes one individual from another. The species is defined by genus and difference. In this definition man is a rational animal, animality is the genus, humanity the species, reason the difference. Laughter is peculiar to man, but the essential and specific characteristic of humanity must not be made to consist in laughter. When it is said, Achilles is blonde, Socrates is pug-nosed, Caesar is bald, blonde, pug-nosed, and bald designate individual accidents. The categories which form the apex of the hierarchy of genera and species, and the idea of which consequently may not be included in a more general idea, cannot be defined and characterized by genus and difference. The same thing must be said with respect to individuals, below which there is nothing, and which are distinguished from one another in the same species only by simple accidents. The enumeration of properties and accidents does not constitute a definition, in the true sense of that term, but rather a description. Therefore, individuals may be described but not defined. True definition and description apply to things. In this sense they can be opposed to nominal definition or to interpretation. The object of the latter is to use etymology, synonyms, or translation, to make known the meaning of a word to anyone who may be ignorant of it, simply by making known the thing to which the word applies. The word which has been interpreted or which does not need interpretation points out the object, but in a veiled way and by a sort of synthetic intuition, definition unveils and breaks up this notion, by distinguishing the matter and the form, the genus and the difference. 5-223. Very briefly, this is the basis of the peripatetic teaching about definition. In it we see appearing the germ of the ideas that modern science has given us on the different degrees of importance and on the subordination of characteristics in genera, species, and individuals. But instead of being clarified by the notion of the independence and of the interdependence of causes, these ideas are found to be inopportunely complicated by chimerical hypotheses concerning a sort of progressive refinement or purification of substances and essences. This idea may also be taken in a sense which is much too systematic and absolute and which is contrary to the habitual continuity of nature's plans. It is clear from the first that the hierarchy of genera and species can be applied naturally neither to all the external objects of knowledge, nor to all the conceptions of the understanding. The ideas of number and angle are indefinable, and they are neither categories nor ideas of individual objects. In the methodical arrangement of chemical combinations, water and cinnabar may be considered as individual objects, and these objects are perfectly definable. Chemical definition lays hold of their essential and constitutive character, and description is applicable to secondary properties whose existence does not follow for us from the chemical definition, although they are doubtless a necessary consequence of the chemical composition of these substances and of the qualities which belong naturally to the substances which go to make them up. On the other hand, description should apply not only to individuals but also to species and genera. It often happens that we do not perceive among the many characteristics which invariably belong to all the individuals of the same species or genus any rational subordination which is so well marked that we are in a position to say of one, rather than of another, that it is not only a property but also an essential and constitutive trait of the species or the genus. Depending upon the case at hand, such a trait may be regarded as an individual accident or as the attribute of a type. It is an accident that Achilles is blond and Socrates pug-nosed, while the Negro type characteristically has woolly hair and flattened noses. In those cases in which the setting up of genera and species rests only upon the artificial choice of characteristics which are otherwise clearly marked, definition per genus et differentium will be appropriate to make the object to which a certain name is given distinctly known, just as WTE find books in a library by means of a catalogue in which the symbols indicating the sections and the shelves are written beside the title of each book. Yet such a definition will yield no knowledge of the intrinsic nature of the object, or at least it will not indicate a rational subordination among characteristics of unequal value. From this point of view, it will be a verbal definition rather than a real definition. In sum, where it is impossible to establish a clean-cut demarcation between natural and artificial groups, there will be an imperceptible passage from real definition to verbal definition. As an example of an artificial arrangement of characteristics, for the use we are indicating, the method of dichotomy used by botanists may be cited. Through its use, the name of a plant which we wish to identify will be found promptly in a manual of botany by successively dividing each group into two subordinate groups on the basis of the presence or absence of a conveniently chosen trait. Yet this will tell us nothing about the true nature of the plant in the scheme of natural affinities, nothing about the relative importance of the characteristics which have successively directed us to the name for which we were searching. Yet a person has learned something who has found the name of the plant in a systematic catalogue which, while not designed to meet the needs of research, has been constructed in such a way as to take account of the intrinsic value of natural characteristics and affinities as far as possible. 332. Some scholastics have gone so far as to pretend that if it is to be regular, that is to say, if it is to be based on the differences and species which are closest in the descending order in the series, every division into genera and species must be two-limbed. This would make the hierarchy of genera and species, and the definitions based upon this hierarchical distribution entirely comparable to the method of dichotomy of the botanists. But then, without suspecting it, they would be shown to be exaggerating the purely artificial side of their theory. In most cases they would reduce their definitions to nothing but verbal definitions. 224. The notion of the defined object that is given us by definition per genus et differentium varies according to the nature of the genus. The statement that an animal belongs to the genus or the class of birds already tells us a great many things about its structure. It acquaints us with its fundamental traits, in comparison with which those traits which differentiate species have a highly secondary importance. In fact, the type bird is one of the most natural generic types. If, without being natural to this degree, the genus is nevertheless clearly distinguished by properties common to the congeners, when the genus is indicated to us by recalling the common properties observed in the congeners already known, we are informed that these characteristics are found again in different degrees in the object defined. Thus to say that an object belongs to the genus of metals indicates to us that it acts on light, heat, and electricity in the way we know metallic bodies generally act. But such characteristics may actually come and go by degrees. And if only an artificial bond or certain negative characteristics establish the genus as a pure logical entity, definition per genus will give us no positive notion of the object defined. To tell us that a body belongs to the genus of non-metallic things, is to tell us what it is not, but not at all what it is. The scholastics called such genera infinite, that is to say, indeterminate. Briefly, the same thing is true of definition per genus as of syllogistic deduction, of which we will speak later on. Its utility consists in extending our knowledge or simply in putting in order the knowledge we have acquired. This is possible to the degree that the generic idea or the general truth contained in the major premise is grasped by the mind as implying the reason for the joint possession of characteristics are the identity of the conclusion in each specific variety. Contrariwise, it is possible to the extent that these generic ideas and general propositions are only the logical summary of what is given by observation for each particular case. 225. The precept of the scholastics that definition must be made per genus proximum and without skipping degrees in the hierarchy of genera and species is of value in an artificial and purely logical system of classification. But it may be found to be defective if we propose to express the rational subordination of characteristics by means of the definition. For example, take the definition already cited, man is a rational animal. In order to apply the scholastic rule, it would be necessary to say, man is a rational, vertebrate animal, or better yet, man is a rational mammal. But, apart from the pedantic pretentiousness and poor taste implicit in this manner of speaking, it offends us for two reasons. It offends us in the first place because, in the present state of our knowledge, we have no sufficient reason for admitting that the quality of being rational necessarily depends upon organic traits on the basis of which man is classified in the order of mammals. It also offends us because what strikes us with respect to the nature of man is the union of the faculties of reason with the fundamental characteristics of the types of animality, and not at all their union with the organic characteristics typical of the order of mammals. 226. It is by a vague recollection of the scholastic theory of definition that we speak of things sui generis, or things which belong to no genus whether natural or artificial, those things which we are unable to make known, even imperfectly, either by means of a definition per genus et differentium or through the use of a description of the sort that the scholastics pretended belonged to individual objects. A sensation of color, taste, or odor unlike those with which we are familiar, or the articulations of a 4. Strange language which have no equivalent in our own, would be an example of what is meant by this. However, it is clear that these things which may reasonably be regarded as indefinable and indescribable may, nevertheless, be classified by genera and species quite as well as a great number of others that we are in the habit of defining. An odor sui generis is a sensation included in the very 334 natural genus of odors. But it is little better known to us on that account, if we have not experienced it, than is any other sensation which does not fall in the category of the sensations received through the special senses, and which, for that reason, we do not know how to distribute according to genera. Such, for example, is the nervous irritation that the rustling of certain substances produces in some persons, but not in others. When things spoken of as sui generis have a measurable character, they admit for that very reason of a rigorous definition which permits us to recognize them without ambiguity. This is true of musical tones, that we can define by the number of vibrations that a sounding body emits in a given interval of time. Thus, there is no other way to define the meaning attached in France to this expression, the A of the opera, than to indicate the number of vibrations which correspond to this musical tone. Then, by means of a similar definition which, as we see it, is quite foreign to the scholastic method of definition, we shall be able to reproduce the same tone at any time and to be certain whether the tone designated in this way always remains the same, or whether, in accordance with a very probable opinion, it becomes progressively higher with the passing of time. Moreover, it is evident that the measurable character connected with the sensation or with the phenomena which produce the sensation does not make the sensation known but simply furnishes the means for recognizing or reproducing the sensation which we have intended to designate by the imposition of a name. If we are concerned not with a musical tone, but with the timbre of a sonorous sensation or with that other little known process by means of which the vowel sounds of one language differ among themselves and differ from the vowel sounds of another language, then no definition is possible, since we know of no measurable characteristics which distinguish them. When the celebrated optician Fraunhofer discovered in the solar spectrum obscure rays which are extremely fine, and unequally spaced, and which follow one another in a constant order no matter what substance is used in the refracting prism by means of which the white light of the sun has been broken up, he furnished points of reference which are extremely useful for defining with precision the colored ray on which one works in an optical experiment. This is so in spite of the continuity with which the colors shade off, or seem to shade off, into one another in the spread of the spectrum. With respect to the mixed and confused colors which constitute what are called the natural colors of bodies, we set up similar points of reference and characteristics which make it convenient to define them numerically, after the manner of musical tones, or through the use of some other exact method. This is the reason for the vagueness that came to be attached not only to the designation of the colors of particular objects, but also to the names of the colors taken abstractly, or to the expressions which are used in different languages to indicate a certain number of principal shades. And a person well versed in the ancient languages has difficulty in recognizing the shades to which the names adopted by the peoples of antiquity are applied, shades which may very well not be those that modern peoples, who live in a different world and who are fashioned by other habits, have found more striking and have wanted to name. 227. There are a great many generic definitions which may be called correlatives, which imply, or seem to imply, each other mutually. Chemists are familiar with acids and bases which, in general, are endowed with contrasting properties, and the properties of which neutralize each other respectively when substances are combined in such a way as to form the compounds that we call salts. At first, the name acid was based on the property that certain of the most conspicuous substances in the first category have of producing in us tastes analogous to those of wine which has been soured by fermentation. But this is only a secondary quality of variable strength which is not a property of some substances that are evidently chemically analogous to the principal acids. It is necessary to say as much of many other characteristics, such as that of changing blue vegetable dye to red, which are often used, because of their convenience, to enable us to recognize at first glance the acidity of substances. Finally, chemists have been led to recognize as the fundamental property of acids that of combining with bases to form salts in which the properties of acids and bases are found to be completely or partially neutralized, depending upon the strength of the contrasting forces. Similarly, they have been led to accept as the fundamental 336. Property of bases that of completely or partially neutralizing acids by reacting with them to form a compound salt. This results in a circle which cannot be called vicious, because it belongs to the nature of things. It does not allow the mind to pass, by a series of exact definitions, from the idea of acid to that of base or inversely. Rather, it forces us to admit both these notions at the same time as correlatives and as sustaining one another, after the elimination of variable and secondary properties which had originally given rise to the distinction of the two kinds of substances. The categorical division into two kinds even ceases to be possible after we have noticed that a given substance, which reacts like an acid in relation to powerful bases, reacts like a base with substances which have acid properties in a still higher degree. The idea of a distribution into two groups then gives way to that of the division into a single and linear series, in which the contrast between the end terms, which are like the opposite poles of the series, is weakened in proportion as the mean or neutral portion is approached. Each term of the series plays opposite roles in relation to what precedes and to what follows it. But this is a conception that we do not know how to translate by means of logical definitions per genus et differentium. Moreover, the same thing must be said, and with even more reason, of the more complicated conceptions to which we are brought by the study of the natural relations of living things. Thus, in general, it will be possible to define each piece in the skeleton of an animal by its form and its functions, and to give them names suitable to designate the traits, whether functional or formal, which they imply. This can be seen by looking at books which deal with human osteology. But later on, progress in comparative anatomy may bring us to see that forms may change and functions may differ completely in the passage from one species to another, while the relations among the pieces of the skeleton nevertheless indicate traces of a fundamental plan that persists throughout the metamorphoses and the modifications which the organism undergoes in adapting itself to the surrounding environment and to the conditions of animal life. In this case, it must be fully recognized that the essential definition of each of the skeletal pieces, a definition which is valid not only for one particular species but also for all the species included in the same genus or in the same class, must be based upon fundamental and persistent connections. 6. Out of this arises a new sort of generic ideas, which cannot be defined in isolation, but the definitions of which, on the contrary, imply and support one another in a system of which the mind may be able to form a clear picture, in spite of the fact that it is impossible to apply to them the ordinary rules of logic, and notably the definition per genus et differentium. 228. People were wearied by the subtleties of the scholastics. As a reaction against the doctrine of peripateticism, Pascal gives some reflections, marked with the stamp of his vigorous genius, in one of the most interesting of his posthumous fragments, called De Vespri Geometrici, one on the usage and utility of definitions, on the complete impossibility of defining, and on the distinction between verbal definitions and real definitions. These reflections have been put to use by his friends of Port Royal in their Logic ****************************************************************************************************************************************************************************************************************************************************************************************************************************************************************************************** However, we believe the subject not only may but must be more thoroughly investigated, and we shall attempt to present for consideration some observations that it suggests. Among lexicographers, the purpose of verbal definitions is to make known the meaning of a word to those who do not already have a more or less clear or obscure, superficial or profound notion of the thing this word signifies. When we are dealing with a new word, the purpose of the verbal definition is to designate the word by which an author has chosen to indicate a physical thing or a simple or complex idea that has not yet been named. Attention is then entirely directed toward the introduction of the new symbol, which is an arbitrary symbol, except for the proprieties of language and etymology. On the contrary, the purpose of conceptual definitions is to make the nature of the thing indicated better known to those who are already supposed to know to what thing the word applies. As the portroyalists have said, they must be confirmed by reason. This is not intended to mean that their correctness must be proven by means of logical demonstration, for, on the contrary, in most cases the feeling for the fitness of a definition or for the true perception of the essential and fundamental characteristics of the idea will result from a whole group of relations and inferences which convince reason, but which could not be attributed to the setting up of a rigorous demonstration. 229. Some words have been imagined simply for the purpose of taking the place of a periphrasis, and for the convenience of discourse. Nothing is more simple than the role of definition in relation to terms of this category, from among which Pascal has drawn his examples of verbal definitions. Thus, since the study of the properties of numbers continuously furnishes the occasion for distinguishing numbers divisible by 2 from those which are not, the former have come to be called even and the latter odd, for the sake of brevity. It is always permissible to replace a word by the periphrasis which explains the meaning of it, or to substitute mentally the definition for the word defined. In the same way, it has been found convenient to call by a single word, hypotenuse, the side of a right-angled triangle which is opposite the right angle, and it has always been possible to substitute the periphrasis for the term which is the conventional abbreviation of it, without altering in any way the basis of the ideas, although the expression of the thought is more difficult. Algebraists use a perfectly analogous device when, in order to facilitate certain calculations, they replace a complex expression, except for reinstating, at the end of the calculation, in all the places where the auxiliary letter is found, the complex expression for which it was substituted. But, without going outside the field of geometry, which always furnishes the clearest and simplest examples in matters of this sort, it is possible to cite technical terms whose role is entirely different and whose definition must not be looked at in the same way. Thus, when we study the properties of the oval curve which results from the intersection of a cone by a plane, and which we call an ellipse, we find that inside this curve there are 2 points so situated that the sum of the distances from each point of the curve to these fixed points equals a constant length, and that this length is that of the long axis of the curve. These 2 points are called 340. The foci of the ellipse. But the utility of this technical term is not limited to dispensing with the use of a periphrasis, as was the case in the preceding examples. For the foci of the ellipse are characterized not only by the property which serves to define them, but also by a great many others for which they might furnish as many other different definitions as the case requires. In giving these remarkable points a name, we have indicated their existence and called attention to them, at the same time making anything arbitrary or fortuitous in the choice of the characteristic property by means of which they were originally defined disappear entirely. If I say that the earth moves in an ellipse of which the sun occupies one of the foci, I put into convenient terms a truth the statement of which retains no trace of the particular ideas which may have led the author of a treatise on geometry to take a given trait as a definition or as a point of departure in the exposition of the theory of foci. What has just been said about the foci of an ellipse may be said about the ellipse itself, since this curve may be generated in an indefinite number of ways and possesses an indefinite number of different traits, any one of which could serve to define it and to characterize it without doing any damage to logic. 9. To give a name to an ideal object, such as the curve of which we are speaking, at the same time that one of its characteristic properties is stated, indicates that the object must be conceived in itself, independently of the circumstances which are responsible for the choice of this property for its characterization, or at least, it has put the mind on the track of a similar conception. Such definitions, which call attention to an object and make it known to us, clearly deserve to be called conceptual definitions or real definitions, in contradistinction to the definitions which we considered above, which have only a verbal or logical value. But Pascal and the Port Royal School seem to have confused both in the class of verbal definitions, in as far as their object was to impose an arbitrary name on the thing defined. 230. Inversely, there are very common and very widely accepted definitions which, when first considered, might be taken as conceptual definitions, but which are really only verbal definitions. When we read in a dictionary or in the beginning of a treatise on mathematics that arithmetic is the science of the properties of numbers and that geometry is the science of the properties of extension, we have not gained a clearer or more extensive idea of the object of arithmetic or of geometry than we had before knowing the definition. But whatever notion we may have had already concerning the properties of numbers or of figures, after the definition, the idea causes the terms arithmetic and geometry to cease being words devoid of any meaning and like the articulations of an unknown language, as they would be for an infant, and as infrequently used technical terms are for educated persons. The acquisition of new terms facilitates the interchange of ideas, even when the new terms are not immediately accompanied by the acquisition of new knowledge or by the clarification of knowledge previously acquired. Consequently, whenever they are possible, summary definitions of this sort, although having no great utility, must not be regarded as being entirely useless, and it is well to distinguish terms which permit of such a summary and, fundamentally, purely verbal definition from those which do not. For example, while, as we have seen, it is very easy to give a definition of arithmetic and of geometry worthy of being included in a dictionary or being placed in the beginning of a textbook, it is, on the other hand, very difficult to define algebra. The very different definitions of it that have been given are obscure and unintelligible to those to whom algebra is not already familiar, and they present great disparities according to the systematic views of those who have adopted them. 10. It is when definition plays essentially the role of conceptual definition, and when it is very difficult to grasp by thought and impossible to express in a concise statement, that the eminent and distinctive characteristic of algebra, in its successive developments and in such diverse applications, is revealed. 231. Some definitions, being originally only definitions of words, have the virtue of leading to conceptual definitions. In that way they render a service which has an entirely different importance than that which would consist in the abolition of a periphrasis. Thus, after having given the technical name multiplication to the arithmetical operations which consist in repeating one number as many times as there are units in another number called the multiplier, men were not slow to perceive that, in the use made of numbers in the measurement of continuous quantities, the multiplier might very well not be a whole number, that it is a whole number only by chance, because of the arbitrary choice that has been made of a certain determined quantity to serve as the unit in the measurement of quantities of the same kind. Consequently, it is necessary to look for another definition of multiplication which fits the case of fractional as well as of whole multipliers. This generalization is not conventional or arbitrary. On the contrary, it is necessitated by the obligation to do away with what was originally too particular and too limited in the manner in which we subordinated to the arbitrary choice of the unit, the notion of a relation between quantities which are known not to depend upon this arbitrary and conventional choice. But in the particular circumstances in which we are placed at first because of the natural order of the operations of the mind, the imposition of the name is what gave rise to the perception of the idea with the generality which intrinsically belongs to it and, consequently, to the generalization of the original definition. If a choice is to be made between different definitions of the same idea, for the purpose of giving the idea the proper extension it should have, and for the purpose of grasping what is truly essential and dominant in it, we believe that the disputes over this matter are not disputes about words, as has often disdainfully been said. Consequently, we believe that or_p is justified in calling such definitions conceptual or real definitions, as opposed to verbal definitions. 232. No one could fail to understand the immediate utility of the definition of an idea so far as the clarification of acquired notions and the profitable direction of the subsequent efforts of the mind are concerned, when the purpose of the definition is to get away from the vague and indecisive meanings a word has in common language. This is particularly true when the definition does this in such a way as to fix precisely the idea to which this word should be applied in the language of philosophy and of the sciences by assigning to this idea its fundamental and essential traits. Everyone continually uses the word chance in connection with events which involve something irregular, fatal, extraordinary, or unforeseen. Ordinary conversation, dramatic dialogue, and even the accounts of history, as it is ordinarily conceived, being decked out in animated and picturesque forms, may adapt themselves to everything obscure and vague in all those accessory ideas which are arranged in such a way as to give value to poetic imagination rather than to austere reason. But how can a scientific theory be built on the notion of chance unless that which is fundamental to it has been established? And how could the applications of the theory not fail to differ depending upon whether we started from Hume's definition, chance is our ignorance of true causes, 1 or from the position we stated earlier, the idea of the concurrence of many series of independent causes in the production of an event, as being that which is essential and characteristic in the notion of chance. The idea of chance, as we understand it and as we undertake to define it, is not an artificial product of the ability to make abstractions. It is the expression of a fact whose consequences, being theoretically foreseen, are continually established by means of the observation of phenomena. But conceptual definitions may also have the purpose of stabilizing artificial abstractions. The merit of these definitions will consist in leading abstractions of the sort that we reach by the most direct or the most convenient route to an exact or approximate understanding of the things which we may wish to study and cannot study directly in their natural state of 344. Complexity. From this point of view, the theory of conceptual definitions becomes confused with the theory of abstract ideas, the outline of which we have given in Chapter 11. 233. It is not necessary to conclude, on the basis of what has been said in section 229 about the variety of definitions which may be given of the same ideal object, such as a geometrical curve, that all the characteristics of an object are equally suitable for defining it. In the rational concatenation of different truths, a concatenation which does not conform to a linear series which is equally tight throughout, like, for example, that of cause and effects, some belong to the series without dominating it, so that there is no determinate reason for making one take the role of antecedent, the other the role of consequent. But there are also some among which a subordination is evident and in regard to which an inversion of roles, while compatible with the exactness of logical demonstration, would not agree with the idea we have formed of things and of their natural relations. The curve which geometricians call a parabola may be very clearly defined by saying that it is given by the intersection of a cone and a plane which is produced parallel to one of the generating lines of the cone. But among the multitude of definitions that can be given of a parabola, some will appear to be as convenient, or even more convenient than the one just stated, depending upon the order of abstractions in which it will be placed. Others will be rejected without hesitation, as expressing derived or secondary properties, because the statement of them is complicated, or still more because they are subject to limitations and restrictions which are incompatible with the idea we have formed of a fundamental and primitive property. 234. It is regarded as a perfection of logical order to bring into the definition only the properties absolutely necessary to characterize the object. But this perfection, which has to do only with form and is connected with a systematic view of the mind, may have real inconveniences, if it arbitrarily subordinates to one another characteristics which are presented together and are of the same degree of importance in the notion that we have naturally of the object. For example, without having studied geometry, all men have naturally the idea of the similarity of two figures, whether they are plane or in relief, and recognize at once that one is a larger or smaller copy of the other. This notion includes two others, namely, first, that all the lines of the figure are reduced in the same proportion when we go from the large to the small, and, second, that all the lines are equally placed and inclined in relation to one another whether in the large or the small copy. Thus it can be said that two polygons are similar when all their angles are equal and all their corresponding sides are proportional. It can be said that two polyhedrons are similar when corresponding faces in the two polyhedrons are similar polygons formed in the same way, and when the planes of each are inclined to one another at the same angle. Now, although all these concepts enter simultaneously into the idea we naturally have of the similarity or the resemblance of figures before any scientific study has been made, geometricians have noticed that a certain number of these conditions are sufficient in order to infer the others. Then they have taken it upon themselves to find definitions which bring together only that number of conditions which is strictly necessary, and this can be done in various ways. But, in this artificial arrangement of premises and consequences, we separate that which is united naturally in the idea, 12, and we reject, among the secondary and derived notions, a truly primitive idea, not without prejudice. 12. Only a mediocre knowledge of elementary geometry and a little reflection are necessary to convince us that the imperfection of the theory of parallels, to use the accepted expression, arises from the refusal to admit as natural and primitive the notion of similarity, or the idea that a figure being given, it is always possible to imagine another which differs from the original figure only because the scale has been changed, or because all the lines of the figure have been proportionally increased or decreased. From this primitive notion, for which it would be fanciful to seek a pretended analytical demonstration such as Legendre sought to give in a note attached to his Elements de Geometry, it follows immediately that equiangular triangles have proportional corresponding sides, or conversely. Once this proposition is admitted, there is no need in the theory of parallels for Euclid's famous postulate, nor for any other which is substituted for it. Inversely, the necessity of this postulate or of an equivalent, which has been proved by the uselessness of efforts which have been made to rid geometry of it since it became a science, well indicates that our artificial systems are unable to prevail over the nature of things, and that, if a natural and primitive idea is mutilated in the interest of pretended logical perfection, it will never be possible to connect by simple logical links the part cut off with the part retained. It will always be necessary to fall back upon immediate intuition and to admit as a premise in one place or another, under one form or another, a logical equivalent to the portion inopportunely rejected. 346. Even with respect to the logical exactness in view of which the artificial argument was set up. 235. Coming back to the remark made at the beginning of the present chapter, we see how important it would be to have a methodical catalogue of logical roots, that is to say, of indefinable words which serve to define other terms, and for the understanding of which, as Pascal has said, nature sustains where discourse is wanting, whether it is a question of notions derived from sensations or from ideas which are grasped only by the mind. We should need this catalogue in order to take account of the functions of language, and before any effort is made toward a universal symbolism. To carry out such a project, a number of things would be necessary. We should need to take account of the diverse roles of definition, to distinguish verbal definitions from real definitions, to distinguish those which indicate the essence and which consequently implicitly determine all the properties of the thing named, to determine those which designate it only by means of some distinctive trait without being exempt from recourse to the intuition of the thing for knowledge of its other fundamental or derived properties, and, finally, to indicate those which tend only to substitute a simple symbol for a complex expression. It would be necessary to pay attention to the conditions which surrounded the circumstances of the formation of each particular language, to those which result from the general laws of the formulation of language and from the natural development of man's faculties, and, finally, to those which are given in the intrinsic nature of things. It would be possible to set up as a goal a purely artificial and logical perfection which would consist in reducing to a minimum the number of roots or the degree of complexity of the definitions for the words defined by means of radicals, just as we should be able to lay aside that goal of perfection in form for the purpose of being able to represent things and their relations as faithfully as possible, in proportion to the degree of simplicity or complexity that nature has given them. But that itself is sufficient evidence that the achievement of such an enterprise would be something of a summary of all science and of all philosophy, and we must not be surprised if the preliminary outline of it has not even been attempted. Chapter 16. On the linear order of discourse. On logical construction and the syllogism. 236. We move on now to some considerations of a different sort, but equally important, if we wish to take account of the influence exercised on the development and on the conduct of thought by the form of the instrument which molds it and by means of which it exercises its influence. These new considerations bear on the necessity that the use of discourse imposes on us to present our ideas in a linear order, and so that the reader may better understand the meaning of this statement, we must return to some fundamental notions which we have already mentioned, but only incidentally. One of the most general ideas, perhaps the most general of all those to which the mind can attain, is the abstract idea of order, which Bossuet said is the natural object of reason. This idea becomes specific and receives particular forms which are more determined when it is applied to time and space, or when it is associated with other ideas which are more abstract and further removed from sense impressions, like those with which algebra deals. When we consider a series of successive events, we are able to take account of the intervals of time which separate them, but we are able to abstract in this way only for the purpose of considering the order according to which they succeed one another, the order which accounts for the fact that event A has priority over event B, and that the latter has priority over the event C, with the result that A or I has priority over C, and so on. Similarly, if we consider a series of points arranged in a straight line, or even laid out along an open curve, it is possible to take account of their distances. Once more, the order according to 347, 348, which these points succeed each other, and which determines that if the point A is behind B, and B is behind C, then A or I the point A is behind C, and so on, can be abstracted and considered by itself. For this comparison it is sufficient to present and set up a basis for abstracting what is common to the series of events A, B, C, N and the series of points A, B, C, N. This common arrangement is called arrangement in linear series, or more simply, linear order, because in stating an idea, we prefer to particularize it in a form which yields an image. In this case the image is a series of points arranged along a straight line. If the points A, B, C, N do not lie along a straight line or along any other line capable of being infinitely extended, but lie along a circle or some other closed curve, we shall have the model of a particular order that may be called circular or closed. It is sufficient to recall such proverbial expressions as these: the extremes meet, we move in a circle, and similar ones, to make us aware that the geometrical image, in this case as in the preceding, does nothing more than give a tangible form to an abstract and general idea capable of being realized in other forms which in other respects have nothing in common with the representation of things in space. Carried over into time, circular order becomes what is called periodic order, and becomes one of the most remarkable and most frequent forms of the succession of natural phenomena. 237. The nature of the idea of time is so simple and so little suited to generating diversified combinations that the idea of order cannot be realized in time under very diverse forms. But, for the contrary reason, a multitude of different orders are represented in the countless variety of geometrical conceptions. This is the basis for genealogical and encyclopedic trees, of chronological diagrams, of historical atlases, and of synoptic tables of all sorts. In questions having to do with an artificial classification, or with an order artificially set up among given objects for the purpose of facilitating research or study concerning them, we are often content to arrange the objects in a linear series on the basis of certain characters or symbols which recall them. This is shown by the very frequent use of the alphabet for this purpose. Each term of the series may be represented by a number which gives its position in the series, so that by assigning a number the corresponding object would be implicitly assigned. Such a series is what mathematicians call, in their technical language, a single-entry series. If the objects dealt with are too numerous, or if, for any other reason, the linear order cannot be conveniently used, it is possible to arrange the objects by squares marked out on the surface of a plane, as on a piece of graph paper. To fix the ideas, if we assume that the squares are arranged on a vertical plane, each division will be determined by the serial number of the horizontal and of the vertical sections in which it falls. This obviously allows us to take account of two distinct characteristics in one process of classification, for example, to classify books according to the subject matter with which they deal and the language in which they are written. A series of objects classified in this way or arranged according to two series of indices or recall numbers, is called a double-entry series. A triple-entry series is one in which each object is determined by a system of three indices or serial numbers. It can be represented geometrically by imagining tiers of compartments placed horizontally and superimposed upon one another in such a way that, in order to indicate a specific compartment or object, it would be necessary to give the serial number of the tier in the vertical series, plus the two positional numbers which fix the position of the compartment with respect to the horizontal plane of the rack. Finally, there is no reason why we should not conceive of quadruple or quintuple entry series and so on, except that the relations of order or the ideal situation that such a conception assumes could not be represented by a geometrical construction analogous to the preceding cases, since we are unable to find more than three dimensions in extension. 238. In order to understand how relations of order, arrangement, and ideal construction, as complex as, or even more complex than those of which we have been speaking, may be proposed for our study and be understood by reason, we need only to refer to what already has been said about the relations between specific types and the objective existence of such relations, independently of every artificial method. But it will not be out of place to make some more detailed explanations with respect to this matter. 350. We are familiar with what Bonnet 1 and other naturalists of the last century understood by the chain of being, an idea the germ of which is already present in Leibniz and Aristotle, and which is even the basis for the doctrine of emanations with which so many theological and theurgical systems born in the Orient and in Greece are connected, in every period of man's history. 3. In order to restrict us in the application of this idea to that which concerns specific types of organic beings, Bonnet and the other naturalists of whom we have spoken admit that each specific type is conceived between two others, one of which is more simple and the other more complex, the plan of nature having consisted in developing gradually from the simplest being, such as infusoria, to the most perfect being from the point of view of organic complexity, namely man, just as in following a chain we move gradually from one link to another. If sometimes the chain seems to be suddenly interrupted, it is so either because the intermediary links correspond to types that have been destroyed by particular or general causes, such as the ancient geological upheavals of the earth, or because discoveries are yet to be made by us which will someday fill in the gaps. It has not been difficult to point out all the aspects of this theory of a continuous chain which are arbitrary and inexact. It is even evident prior to any discussion that this is not a question of continuity in the proper sense of the term, since this would require that there be an infinite number of species which could not be distinguished from one another by any clearly marked trait, which is in contradiction with the notion of organic species itself. Moreover, we clearly understand that if the dimensions and forms of a multitude of structures which have to enter into the organization of a living being were made to vary simultaneously, there would have to be a whole series of combinations incompatible with the preservation of life in the individual, or in which the individual is subject to such great chances of destruction that the species would have no chance of survival and would necessarily or very probably disappear as a final or stable form. Thus we can account perfectly, a priori, for the gaps in a series of specific types. We understand that there may have been sudden jumps from one type to another, not only because intermediate forms have disappeared, but because they are not possible. This is very much like the case in which there is a sudden change from one position to another when a body capable of assuming different positions of stable equilibrium is turned in various ways on a plane surface. Yet, if in the series of specific types we were to recognize only breaks depending upon causes of this sort, we should still be able to say that the series is continuous in the sense that nature had brought into existence all the possible intermediaries or had submitted an identical basic form to all the possible modifications. This is probably the way the defenders of the philosophical idea commended by Bonnet would argue the matter. But even in this sense, it is contradicted by observations which give evidence of a very great inequality between intervals, and sometimes of such large gaps that the hypothesis of regular gradation, which recalls or simulates continuity, must be completely given up. On the contrary, breaks in the chain seem to depend upon capricious and irregular causes of the sort that have brought about the continents and the oceans, and which reveal, even in their regular and permanent order, the fortuitous circumstances of their original formation. 239. Although the idea of continuity in transitions is disposed of in this way, the idea of arrangement in linear series always 352 remains. This is the idea to which modern classifiers have been obliged to cling, not only because it brings the most general traits of the plan into clear relief, but still more because it is better suited than any other to the needs of didactic exposition. When we look particularly at what has been done in connection with the vegetable kingdom, which is less complicated than the other, we see that the work of the Jesuits and of botanists of their school was to form groups called genera, families, and classes, on the basis of a certain evaluation of organic characteristics as a whole, but an evaluation which cannot be submitted to fixed rules. These groups were then arranged into a general catalog or into a linear series, the links of which may be thought of as being differently spaced without disturbing what is properly called the order of the series. However, to fulfill the absolute conditions of order, this series would have to be such that each term resembles in more numerous and more important ways the two terms between which it falls than it would the terms which precede and follow these two. As a matter of fact, each term must have a greater resemblance to some particular term than it has to any other term which precedes or succeeds it in the series. In this situation, it makes no difference whether the degree of resemblance has been made to depend upon the number or upon the importance of the characteristics. In order to satisfy the conditions of this abstract schema in the best possible way, whether these conditions are formulated or not, modern botanists have taken full advantage of the tentative efforts, and have successfully rectified the mistakes in classification made by their predecessors. But they all recognize that it is impossible to satisfy these conditions completely. Linnaeus was aware of this when he proposed to give up comparing the vegetable kingdom to a chain or linear series, in favor of the analogy of a geographical map on which botanical families would be represented as so many large states, the genera as provinces, and the species as centers of population. It is not necessary to give up hope that someday this idea of a great master may be realized in a useful way, as Gandalf believed. 240. Reduced to its clearest terms, and devoid of every metaphorical image, the idea suggested by Linnaeus amounts to replacing a linear or single-entry series by a double-entry series. If we preserve the metaphor and continue to represent each term as a link, it is as though the centers of the links, instead of being limited to maintaining a certain alignment, may be distributed over a surface like the meshes of a net. It is clear that with this new arrangement the points of contact and the ways in which they are related would be multiplied in such a manner as to facilitate, by a sensible image, a truer conception of the methodical arrangement of the resemblances among the different terms. It must be clearly recognized, however, that Linnaeus' geographic map, or any other conventional device of this sort, would still only imperfectly represent relations as varied as those found among plants when we take account of the structure and the functions of their numerous organs, their habitation, their geographical distribution, the properties of the substances that can be extracted from them, and all the aspects of their history. In other words, the natural order of resemblances among plants has no geometrical analogy among all the sorts of methodological arrangements which may be worked out on an extended surface having two dimensions, although these may be infinitely more varied than those which can be represented by a linear series. 241. If we wish to submit this conception of Linnaeus to an analogical extension, after having substituted the comparison of a plane or a map for the common one of a chain, it would be necessary, in turn, to substitute for this latter the image of a relief map made of a transparent substance so that its internal sections could be studied. This would make the three dimensions of space elaborate in the representation of relations of order for which we seek a sensible image. Putting the matter in purely abstract terms, a system of triple entry would replace that of double entry which has already taken the place of the linear series. But in order that the method of coordination and the system of different types of the organic structure of plants may be expressed perceptually, or may be portrayed or modeled truthfully, it would be necessary that extension permit not of 2 or 3, but of an infinite number of dimensions. On the other hand, if we are dealing simply with objects among which the possible relations are restricted by a limited number of aspects, it would sometimes be possible to express the scheme of their relations completely by means of double or triple entry series, although they could not conveniently be expressed by means of a linear series. 6. 242. Now that the meaning of our expressions has been made known, we will return to our point of departure by saying that one of the radical imperfections of written or spoken discourse is that it constitutes an essentially linear series, that its mode of construction obliges us to express successively, by a linear series of symbols, relations that the mind does or should perceive simultaneously and in another order. For this reason we dislocate in speech what is connected in thought or in the object of thought. This matter will be apparent to everyone when an attempt is made to use words to describe not a picture or a landscape, for we have already found in the continuity of forms, nuances, and magnitudes, another cause which makes exact translation by means of discontinuous symbols impossible, but a system which is made up of discontinuous parts, like a timepiece. From whatever point of view we undertake to describe the parts of the timepiece and their reciprocal play, and whatever order we follow, we shall find the greatest difficulty in making the mechanism understood as a unity by the use of discourse alone, and we shall be able to give only a very imperfect idea of it. The reason for this, manifestly, lies in the necessity of describing the pieces one by one, and in the impossibility of passing from one of them to another which is immediately connected with it, without at once losing hold of all the other pieces which are also immediately connected with the first. Now this simultaneity of connections, these mutually dependent relations, are found not only in things which are extended, material, and perceptible, but also in everything that becomes the object of speculations of the understanding. How often we have experienced difficulty in putting in order, as we say, ideas which present themselves to us simultaneously. And after many attempts, we often find this order which has cost us so much effort is not a faithful reproduction of the order whose prototype we think we possess subjectively, and which we seek vainly to indicate to others or to stabilize for ourselves with the aid of symbols, handicapped as we are by the nature of symbols, by the law of language, and by the sensible form of this instrument of our thoughts. No matter on what scale we work or what form of abstraction we use, the same influence makes itself felt in the same way. Our treatises, our scientific methods, our histories, our systems of law are so many attempts whose purpose is to coordinate in linear series, to link, this is the proper term, facts, ideas, phenomena, and relations which most often do not submit to such linking without being forced. The result of this is that some things are found to be separated which really are intimately connected, that the description of some relations cannot be sufficiently complete without causing confusion or disturbing the general plan of the work. Everyone wants to substitute a better plan for the one in which he recognizes defects. Everyone seeks artifices of diction best suited to disguise incoherencies, just as a composer of music seeks to mitigate a necessary dissonance. In seeking the solution of an insoluble problem we use up energies which often could be more profitably employed. 243. In certain cases, however, we have fully recognized imperfections inherent in the form of discourse, in this alignment to which it submits ideas. We try to correct these imperfections by constructing synoptic tables, trees, and historical atlases, types of tables of double entry, in the outlining of which we are more or less successful in representing two dimensions of an extended surface, so as to indicate systematically relations which are difficult to disentangle within the concatenation of discourse. The difficulty of material execution is opposed to our being able to turn the three dimensions of space to account for the same purpose, although, in the order of abstract conceptions, analogy may lead in that direction. But it must be remarked that these synoptic tables have had a thoroughly real utility only when they have been adapted to relations which lend themselves to enumeration, and which consequently are connected with an order of ideas or facts which is not subject to the law of continuity. When the opposite is true, these tables only serve to bewilder thought by introducing a determination and a fictitious discontinuity into what is fundamentally undetermined and continuous. Thus, a genealogical tree is the simplest and best device in the world for expressing clearly the system of relations which connect among themselves all the members of a family, while an encyclopedic tree or table cannot avoid giving only an imperfect picture of connections of the sciences and their mutual dependence. 244. In discussing the consequences which result from the linear construction of discourse, we have had in view the massive constructs which constitute oratorical or didactic order, rather than the detailed construction of each separate sentence which makes up grammatical order. If the formalistic dryness and precision of scholastic argumentation were used in ordinary language, if a discourse of any length and of any importance could be formed. 358. By a superimposition of syllogisms, enthymemes, and dilemmas, as a column can be by the superimposition of courses of stone, then there would have to be a correlation between grammatical phrasing and the natural division of the operations of thought. But usually the grammatical phrasing of forms, which is subordinated to the exigencies of the ear, to the attentive capacity of the mind, and to other accessory circumstances, has no more fixed relations with the general ordering of discourse than the dimensions and form of an undressed stone, in a piece of masonry, have to the architectural lines and proportions of a building. When we examine discourse in detail and sentence by sentence, we not only find that the words of each sentence are bound to succeed one another in a linear order, as do the sentences themselves. We also find that their numerical sequence is assigned with more or less fixity according to the genius of the language and by virtue of certain syntactical rules. The languages that permit inversions, those which are the object of our admiration and of our classical study, are those in which freer syntax allows the writer to choose more readily among all the linear forms of construction the one which is most graphic, that is to say, the one which most faithfully portrays the order according to which the mind of the speaker or writer has perceived the ideas that each word, in its turn, should awaken in the mind of the hearer or reader, if, keeping entirely within the linear order which prescribes the essence of language, we find so many differences as to the force of expression as we go from one language to another, and if these differences are due above all else to certain syntactical liberties, what would the situation be if the writer were free to go outside the circle of combinations limited by the linear form of grammatical construction? 245. We must not regard these two characteristics of discourse being composed of discontinuous elements and developing in a linear series as being of the same order of importance. The first characteristic is found in every other system of artificial symbols, the second is more particularly determined by the organic conditions of the activity of speaking. Even though the graphic symbol of thought had not been formed on the basis of the spoken word, it would still have developed the imperfections pertaining to the first characteristic that appears in discourse, and to the same r/degree. But it would differ essentially from discourse in the way in which elementary symbols would be arranged and consequently would open up other avenues to the development of thought. Thus, an algebraic formula is better suited than ordinary writing for presenting, in the form of a synoptic table, the idea of symmetry with which four elements of a formula are grouped and combined. Moreover, any system of graphic symbols, together with any special resources it may be able to offer, in the end would always be found to be inadequate to represent all the kinds of orderliness and connections that nature reveals to us and that reason conceives. It is for this reason that mathematical images soon cease to hold the attention of the analyst through their correspondence with the conceptions of pure analysis. Therefore, mathematical analysis rests only on ideas of a very particular and even of a very special nature, among all those to which thought applies. 246. In a didactic treatise, it is possible to give an exposition of a science only by following a linear order which presents obstacles to the exact representation of the relations among the various parts of the science. But it is not necessary to conclude from this fact that the imperfections of the didactic order may not be corrected so far as the ideas that have already made the science familiar are concerned, and still more in the thought of a man whose genius enables him to master it. On the contrary, it must be admitted that such a man, throwing away the scaffolding by means of which his genius has reached its present attainments, or preserving only the useful portions of it, correctly perceives the system of relations of all the parts among themselves, and is guided by this mental picture in the investigation of facts and relations as yet unknown. But since this entirely subjective perception cannot be translated into discourse, or can be so only imperfectly, it constitutes an individual, changeable, and perishable trait. Only ideas capable of being fixed by means of symbols may be transmitted identically and enter into the system of science which instructs and grows continuously. 247. We have already learned to distinguish between rational order and logical order. This is a very important distinction, and one that, contrary to what is usually the case, etymology alone would fail to recognize. We know that rational order is 360. Adapted to the order of things and that logical order is related to the order of our faculties. We also know that logical order is essentially linear, whereas we perceive no necessary limits to the variety of forms rational order may assume. Moreover, since these forms are most usually capable of sensible representation, our idea of them presents this peculiar characteristic: we do not know how to give adequate expression to the idea, yet it is useful as a term of comparison, for the purpose of choosing those from among the forms capable of sensible expression which lend themselves least imperfectly to the translation of the natural relation of things. It is like the ideal type that the artist possesses, and to which he tries to give adequate expression through his pencil or chisel, but without success, since, although the ideal form does not exist among tangible forms, he may run across things that resemble it and that he can use, up to a certain point, for communicating his idea to minds which are capable of understanding it and to spirits which are in harmony with his own. It is always possible to prove that we have been mistaken in the rules of logical deduction, and that a given demonstration cannot be accepted because of a vicious circle or because of incomplete enumeration. Yet there is no way in which we can rigorously demonstrate that a given arrangement among the theoretical axioms conforms to the rational order or deviates from it. This is the point at which philosophical insight comes into play. The judgments which rest on this insight can neither be precisely confirmed or refuted, nor can they be imposed on the reason of other persons. We may guess that a glimpse of the most important truths has first been caught sight of by means of this philosophical insight which precedes rigorous proof. As a result, we should not be surprised if, in such sciences as mathematics, where logical exactness is prized above everything else, it often happens that even though we accept the discoveries of inventive minds, we are not always satisfied with the demonstrations they have given for their discoveries, as though they had poorly contrived what they had so well discovered, to use the piquant expression of an ingenious mathematician. 7. This tendency toward exactness has certainly been abused. And in any case, the worth of the discovery, even when accompanied by an imperfect demonstration, always carries with it much more worth than a subsequent improvement which gives, or seems to give, greater logical exactness to the proof. But nevertheless, the process by means of which the mind grasps new truths is often very distinct from the procedure by which it logically and demonstratively connects truths with one another. That which results from the order imposed by the forms of logic is not always the order that best expresses the reason of things and their mutual dependence. 248. We shall have reason to make some observations about the logical order which are perfectly analogous to those which we made in the preceding chapter concerning the theory of definition. Just as it is necessary to admit logical roots, or indefinable words which serve to define others, so some principles or axioms which serve as the basis for all later demonstrations must themselves be admitted without demonstration. The perfection of the logical order consists in reducing as far as possible, on the one hand, the number of principles and axioms admitted without demonstration, and, on the other hand, the number of links or intermediate propositions by means of which one proposition is logically connected with another. 8. It is toward this perfection of logical order. That mathematicians, and particularly ancient mathematicians, have especially striven, and the taste for this kind of perfection is regarded as one of the important traits of the mathematical mind. 9. But so long as a person applies himself to perfecting the logical order in this way, he must expect to disturb frequently the essential relations, the analogy, the symmetry, and, in a word, the rational order among the different parts of a scientific construct. 10. The degree of evidence which determines that a proposition may conveniently be taken as an axiom does not always belong to the original truth. To what reason conceives as being the principle and the source of the others. On the contrary, in many cases it pertains to something far removed from this primordial truth, which, by the aid of accessory circumstances, is presented to the mind in a more favorable light. It also happens that the simplicity or the complexity of demonstrative arguments is not always proportionate to the simplicity or complexity of the ideas on which hang the propositions which are the objects of demonstration. In other words, it sometimes happens that demonstration takes an easier or more expeditious turn when we go from the compound to the simple than when we go from the simple to the compound. Thus, although the complexity of constructions, calculations, and demonstrative arguments generally increases as we pass from the propositions of plane geometry to their analogues in solid geometry, it has long since been noted that, by exception, construction in space and the arguments about three-dimensional figures are sometimes more easily introduced to demonstrate certain properties of plane figures. The object of statistics is less simple than that of geometry, since in it the consideration of forces is added to the consideration of forms. Nevertheless, it happens that we have been able to put statistical notions to work ingeniously in order to establish certain properties of figures more simply and more briefly than could be done by means of geometry alone. Similarly, we apply geometry to algebra and the different parts of the calculus to one another in such a way that an increase in construction or complication in the rational order results in a logical simplification. The examples of such inversions are innumerable. But, without having to go into technical details which lie outside the province of this book, we may note the variety of methods followed by mathematicians in establishing the same axiomatic principles, and the numerous verifications to which they never fail to submit each important theorem. These instances show clearly enough that some of these principles, which proceed from one another and recur in accordance with diverse series, and which are all logically connected, are almost like those forms which mineralogists relate to the same crystalline system, each of which, when taken as a point of departure, reproduces all the other forms when it is submitted to a series of regularly defined modifications. These observations hold even though some members of the group may be much more simple, and some may reasonably be taken as points of departure in the successive transformations. 249. The importance of the syllogism 1-1 in peripatetic logic results from the role that the doctrine of universals and of definition * per genus et differentium plays in it. The genius of Aristotle admirably grasped and coordinated all the parts of the system, and we must follow it even when combating his theories in so far as they are too absolute or too extreme. There is reason to make the same distinction in regard to the major premises or general truths, from which we wish to deduce a particular truth by means of the syllogism, that we have been making concerning generic ideas and abstractions of every sort. Some are artificial or purely logical, others are natural and are based upon the rational subordination of things. If the general proposition contained in the major premise is nothing but the summarized expression of particular judgments based on each species of the genus, the syllogism is an artificial construction which may be useful for putting acquired knowledge in order, but which is ineffective for the purpose of extending or developing our knowledge. If, on the contrary, the general truth is conceived as entirely independent of the particular and the concrete forms that a general and abstract idea can assume, and if it is also conceived as being not the logical resume of, but the reason and the basis for the particular truths, then the syllogism becomes a method of extending our knowledge and of increasing our understanding of the properties of particular things, by suitably applying general ideas to them. This is so because the syllogism expresses the subordination of our judgments in a manner conformable to the intrinsic relations of things or in a manner conformable to the order according to which facts give support to one another and truths emanate from one another. All metal is opaque. This is a proposition which cannot be used as a major premise in a syllogism which can increase our knowledge in certain respects. We acknowledge the truth of this general proposition only because we have verified the fact that every kind of metal that is known has the property of being opaque. It must be directly verified in the case of any metals that may subsequently be discovered. Before the discovery of sodium and potassium, it might just as well have been said, all metals are heavier than water, or, better still, before the discovery of mercury, that all metals are solid at ordinary temperatures. On the other hand, the proposition, all mammals breathe by means of lungs, can very well be used as a major premise. As a major premise it will serve to increase our knowledge or to prove that any extinct animal breathed by means of lungs even though we know nothing else about it than that it was a mammal. This follows not simply because there are no exceptions to this observed fact, that all animals provided with mammary glands have lungs, but even more, and principally, because the knowledge acquired as to the mutual adaptation of parts in the total organic structure of the animal permits no doubt as to the fact that being viviparous and suckling the young, are conditions of existence which are subordinated to a condition of greater importance, namely, that of breathing by means of lungs. It is in this way that logical proof, which results from the connection of propositions in the syllogism, may have a philosophical inference as its preliminary condition and a probability for its foundation, but a probability of the sort to which reason is forced to assent. 250. Nevertheless, this is not true in every case. The principle of morality and of law, that no one has the right to enrich himself at the expense of others, is a maxim that reason finds in itself. It does not need to be established on the basis of repeated observations or by invoking analogies or inferences of the sort we have called philosophic. Therefore, when a lawyer argues from this general principle or from this major premise in order to prove that the owner who recovers his goods ought to reimburse the possessor fairly for any expense he has had, in proportion to any improvements which have been made on them, or to decide any other more subtle question whose solution is less evident, his deduction will be free from any previous induction. He will pass directly from the general truth to the particular truths which must really be considered as so many emanations from this general truth, as distinct from cases in which the general proposition exists only as a logical expression and as a collective symbol of particular truths. The distinction of major and minor premises and the syllogistic construction which follows from this is shown particularly in arguments before the bar, in which the major is ordinarily called a question of law, and the minor, a question of fact, or sometimes the case in question, as a remnant of the influence of scholastic traditions. It is perfectly clear that in a lawsuit between an owner who reclaims his goods and the person who has possession of them in good faith, the solution of the question of law of which we have been speaking, or of any other analogous one, is independent of the knowledge of the particular case and of the proof of the fact. 366. That the possessor acted in good faith, that he has incurred some expenses, and that his expenses increased by that amount the total value of the things reclaimed. The syllogistic distribution, prescribed in this case by the nature of things, is entirely to the advantage of the orderliness of ideas and the clarity of proofs. On the contrary, sophistry and bad faith will be favored, if the argument hangs on ideas whose value it has been impossible to determine invariably because of the continuous modifications which these ideas permit. The sophism could be resolved by distinctions in the case of simple equivocation, that is to say, if the terms have only a certain number of distinct, determined meanings. But this is most frequently not the case, and it is then that the apparatus of logical forms disturbs and falsifies judgment instead of clarifying and strengthening it. We shall delay no longer the development of these considerations, although we shall apply our principles especially to the theory of judicial questions. 251. We are able to abstract, as we say, the matter from the nature and the origin of the ideas and judgments which make up and constitute the syllogism, so as to consider only the form or the kind of propositions, that is to say, their characteristics as general or particular, affirmative or negative. For, as these characteristics are variously combined in the three propositions which make up the syllogism, it will be possible to distinguish many moods and figures of the syllogism, and to set up rules in order that a syllogism may be valid and conclusive, or, contrariwise, may be deficient in form regardless of the intrinsic truth or falsity of the conclusion or of the premises. Hence, arises a curious theory, every aspect of which is perfectly rigorous, and the invention of which long precedes that of algebra and the general theory of combinations, although it calls attention to this latter theory, and although it bears a very close analogy to the elementary rules of algebra. In fact, although the species may not be contained in the genus in the same way as one quantity is contained within another, there are, nevertheless, principles of such generality that they may be applicable to either mode of comprehension or of extension. We are able to say that from the two propositions, A includes B, B includes C, the proposition A includes C results. This is true, whether A, B, and C designate homogeneous quantities, or whether these same letters are used to indicate generic terms which are subordinate to one another in the hierarchy of universals. The rules of synthetic combination, adapted to the syllogistic series, must therefore have the greatest resemblance to the rules of the calculus that is called in mathematics the calculus of inequalities, and consequently they also resemble very much the rules for the calculus of equalities or equations. But this great resemblance is found only at the starting appointment. The fruitfulness of mathematical principles and the loftiness of the structure for which they furnish the materials result from the great simplicity of their forms and from the great regularity of their syntax. The calculus of inequalities, compared with that of equations, rests upon principles which are less simple and which are subject to more restrictions. Thus, this branch of mathematics has remained in what may be regarded as a rudimentary state as compared with the vast developments that have been made in the theory of algebraic equations. For a similar reason, the theory of the syllogism would in no way include scientific developments comparable with those of algebra, even though it were not to have a practical use which is as limited as the applications of algebra are numerous and important. 252. Can all reasoning be reduced to syllogistic forms? Aristotle himself did not think so, and he early noted that mathematicians do not use the syllogism because, as he put it, they make no use of the notion of genus and species. But there is a better reason than that. For, how can the theory of combinations be established syllogistically when the rules of the syllogism themselves are dependent upon the very theory of combinations? And how can the rules of algebraic calculation be made to depend upon a syllogism, since the relation of the conclusion and the premises in the syllogism is supported neither by more nor by less evidence than the rules of algebraic calculation? The algebraic argument, A is equal to B, and B is equal to C, therefore A is equal to C, which is not a syllogism since we can distinguish in it neither a major or a minor premise, nor a major, middle, or minor term is as self-evident as the relation of the conclusion to the premises in this common example. All men are mortal. Kings are men. Therefore, kings are mortal. 368. If the probative force of algebraic argument came from the fact that it could be converted into syllogisms, it would be necessary, on the same basis, that we should be able to prove by syllogisms the very rules of the syllogism, and we could not escape from a vicious circle. The device which consists in making evident the relation of two terms or ideas through the mediation of a middle term or of an intermediary idea is not something unique in syllogistic argumentation. Nor can it be found only in the rules of algebraic calculation. It is one of the most general procedures to which the human mind has recourse to assist its weakness, and the mind uses it continuously under the most varied forms. In order to compare the surfaces of two rectangles having neither the same base nor the same height, we conceive of a third rectangle having the same base as the first and the same height as the second, the surface of which serves as a term of comparison between the surfaces of the two proposed rectangles. Such a figure has a function analogous to, although not precisely identical with, that of the middle term of the syllogism. In general, in order to compare quantities we measure them. That is to say, the unit of measure is the middle term by means of which we obtain the relations between quantities of the same sort, which, in most cases, can be neither physically related nor completely compared. In commerce, the precious metals are the middle term by means of which we compare the exchange value of objects which are unlike in every other respect. In a geodetic survey, objects which are too distant from one another to be seen from the same station are connected by means of signals and intermediate stations, and so on. 253. In treatises on logic we find rules concerning the conversion of propositions by means of which it is permissible, under certain conditions, to draw rigorous conclusions by going from the particular to the general. This manner of drawing a conclusion is often called induction, as opposed to deduction, which consists in going from the general to the particular, and which is the procedure that we practice in the syllogism properly so called, per genus et speciem. Thus, it often happens that the observation of a single fact is sufficient to upset a general theory. But the same induction, submitted to formal conditions which are as clear and precise as those of syllogistic deduction, is, like the latter, a logical demonstration, a rigorous calculation, which must not be confused with philosophic induction, the nature and role of which we have stated in Chapter 4. The same thing must be said of a feat of understanding which is very often used in mathematics, and which is also called induction. This consists in proving that if, in a series which may include an infinite number of terms, one or more consecutive terms are brought under a certain law, the next term can be similarly brought under the same law, and so on from term to term. As a result, it is sufficient to establish the law for one term or for a finite number of terms. Then a rigorous induction extends it to the whole series of consecutive terms, which are infinite in number. As a matter of fact, this is clearly an instance of going from the particular to the general. But this feat is not the only one mathematicians delight in performing. It continuously happens to them that when they wish to establish the properties of a class of figures, they first consider the figure in a particular or rather a singular state, in that it introduces simplifications which are exclusively characteristic of it, and they then show that the general case may be brought back to the particular from the genus to the species, as Aristotle would put it when they deal with the general case first of all, in order to deduce the particular case from it as a corollary. Passing in this way from the general to the particular or the singular, there is ordinarily nothing which recalls syllogistic construction. Finally, and still more frequently, the terms and propositions maintain the same degree of generality throughout the series, as happens in the type of arguments of which the description of an algebraic theory represents the typical notation. On this basis, it cannot be said in such a case that the mathematician proceeds by means of deduction rather than induction. Analogous observations can be applied to the course of reasoning, whatever objects we reason about, although mathematics always enjoys the privilege of furnishing the clearest examples of this sort, and of being, in all respects, the best school of formalist logic. The truly essential distinction in all things is that which consists in contrasting logical or demonstrative proof and philosophical induction, the origin and nature of which we have previously tried to make known. As for logical or demonstrative proof, it sometimes proceeds by deduction and sometimes by induction, depending upon the case involved, from known to 370. Unknown, depending upon whether there is more or less generality in the known truth than in the unknown truth. Sometimes, by means of a contrary course, it proves hypothetical premises by falling back upon known consequences. Finally, in a great many cases, the premise and the conclusion have the same degree of abstraction or generality. And in order to include at one time all the different cases, the most suitable term is construct, the meaning of which will be still better fixed by remarks contained in the chapter which follows. Chapter 17. On Analysis and Synthesis. On Analytic and Synthetic Judgments. 254. In speaking of the formation of abstract ideas and of the progressive elaboration of the primary materials furnished to the mind by the sensibility, we have already had to say something about analysis and synthesis. We have even had to establish an important distinction between the abstract ideas resulting from the analysis or the breaking up of sensory images and those which come from the need that reason feels for bringing together and coordinating scattered impressions. From the point of view of logic, these are the processes of elementary analysis and synthesis, since they result in the formation of ideas or of terms which serve as elements in the series of logical propositions, arguments, and constructions, no matter what position the terms may have in the scale of generalization or abstraction. Logicians have dealt with analysis and synthesis principally with respect to method. That is to say, they have considered these two acts of thought more especially in so far as they include a complete series of judgments and arguments which are capable of formal statement and of logical coordination. We shall also treat analysis and synthesis from this point of view by attempting to describe and explain, on the basis of our principles, the different meanings these terms acquire in ordinary language and in various scientific dialects, but principally in the language of mathematics, in which they are so frequently used, and in which they acquire a technical value which it is interesting to compare with the value which logicians attach to them. 255 If we go back to etymology, the word synthesis simply means combination or construction, while the word analysis means decomposition or, better still, resolution. But it is well to observe that the two correlative terms, in passing from scholarly language into ordinary language, have not had the same fate. Ordinary language has completely taken over the one, the use of which has become most common, the other has never emerged. 371. 372. From the didactic style, or, if it is tending to lose the style at the present time, it is the result of a pretentious neologism. Since there must be a reason for everything in the organization of language, we have already been led to infer from this comparison that one of the two terms recalls an operatiop which is more natural to man, the other a more reflective and scholarly operation. Nevertheless, in many cases, the term composition may be considered as the true correlative of that of analysis. We speak of the composition of a discourse, of a poem, or of a picture, just as we speak of making an analysis of a tragedy or of a discourse. In general, the term analysis is commonly taken to mean a breaking up of intellectual objects into their elements by thought, as contrasted with material or mechanical separation into parts. Here its use depends simply upon a perpetual metaphor. We see clearly that the idea connected with the word analysis cannot lend itself to a rigorous definition when we are dealing with a subject which is as complex, as abstract, and sometimes as vague as any system of ideas, of arguments, or of images which a book is intended to produce. Among the ideas to which this word gives rise are many which no more call to mind decomposition in the strict sense of the term than they do composition. Finally, unless we propose to stop speaking, it is necessary to use this term as well as others with the intermination with which it is affected, by endeavoring not to carry this intermination over into the essential forms and characteristics of thought. To the degree that the subject matter becomes more simple and better defined, the metaphorical allusion to the common notion of composition and decomposition acquires a greater precision. Thus, when a grammatical phrase is analyzed for a child, a real decomposition or resolution is made of the statement into the grammatical elements which compose it. These isolated elements are dictated to him, and he must join them together again according to the laws of grammar. This latter process is a real instance of composition, a synthesis, or a syntax, for these terms may be considered as synonyms, except that in the use of the latter term there seems to be a more direct allusion to the relations of order and position among the associated elements. Finally, the child becomes more skillful, and as we discover by acquainting him with a dead language, the study of which lends itself to the methodical development of his mind, he is able to do what we call translations and exercises with the assistance of a two-language dictionary. But this has already become too complex an operation for a metaphorical expression to be perfectly adapted to it. Yet, when we reflect on it, we shall see that the work of translation is more like what we call analysis, and that synthesis or syntax is dominant in doing composition exercises. There is another science in addition to grammar in the vocabulary of which the terms analysis and synthesis always have a precise meaning which never gives rise to any equivocation. This science is chemistry. The reason for this is evident, since this science deals with physical objects to which the ideas of composition and decomposition may be directly applied without the use of figurative style. 256. In his writings, Condillac incessantly reconsiders analysis and synthesis, to prove that the analytical method is the only proper one and the only one founded on nature. Indeed, this seems to be the sole object of all this philosopher's writing. However, it has long been noted that Condillac has made an entirely different use of synthesis and that his treatise on sensation in particular, in which he attempts to reconstruct a man out of whole cloth by successively giving his statue each of the five senses, is preeminently a work of synthesis, and we may observe that the faults of the work follow precisely from the use of synthesis in a subject with which it is incompatible. If a watchmaker wanted to explain the mechanism of a watch, it would make absolutely no difference whether he began by taking it to pieces, i.e., by making an analysis of it, or, conversely, by putting together disassembled pieces, i.e., by first making a synthesis of it. Probably the student would have a clear and lasting idea of the mechanism only after both these operations had been repeated many times. The same thing might be said of all theories relating to complex objects whose parts may be put together and taken apart in this fashion. It is of little consequence whether they are stated by means of analysis or synthesis, or rather, when they are presented, it is almost impossible to follow exclusively either analytic or synthetic processes. Even when this difficulty is overcome in the editing of a didactic treatise which has been thought about for a long time, the theory would really include only that 374, with which the mind has become familiar by means of these alternative compositions and decompositions, and with respect to which it would have become equally easy to proceed analytically or synthetically. Instead of the watchmaker who explains the mechanical structure of a watch, we might just as well have considered a teacher who explains the skeleton or the bony structure of the human body, a structure composed of a known number of distinct pieces whose natural relations to one another are maintained reasonably well by means of artificial ligaments. In this common case as in the other, we say that it will make little difference whether the teacher separates connected parts or puts together isolated parts, that is, whether he makes an analysis or a synthesis of the skeleton. But in living animals, the skeletal structure is related to other systems of organs, in the study of which we can move only from the whole to parts, and not, conversely, from parts to the whole. This is so not because these systems of organs lack stability, for with patience and skill the circulatory system and the nervous system can easily enough be isolated, and the art of injections is specifically intended to make the vascular system visible, but results rather from the fact that these organs are endlessly ramified, from the fact that innumerable flexions and inosculations exist, in a word, from the fact that they form a continuous whole and not an assemblage of pieces. Thus, as etymology indicates, anatomy is simply the analysis of organs, the corresponding synthesis is not known, for obviously physiology is something altogether different from this synthesis. Human osteology is complete and the synthesis of it can be made. The opportunity for anatomical discoveries will never be exhausted so far as the vascular and nervous systems are concerned. New optical instruments may push back the boundaries of these fields indefinitely, but that shows the impossibility of making a synthesis of these systems of organs. 257. Note well that, when synthesis is impossible because the real elements are never reached, strictly speaking analysis is also impossible. Yet there is this essential difference: the analytical or anatomical procedure tends toward the indefinite attenuation of errors, to a more and more distinct and true knowledge of the object, while the synthetic method, or the reconstruction of the whole out of parts which are not its true elements, tends toward the accumulation of errors, and should it happen that errors do not accumulate, but, on the contrary, compensate for one another, this compensation is purely fortuitous. When we are working with objects which are capable of continuous modifications, whether these objects belong to the physical world or to the world of ideas, the construction of a theory implies the substitution of an artificial system for a real one, that is, a system of the sort that is presented to us by nature. But the artificial system, the product of an analysis which is performed on the whole, may constantly be brought to resemble the real system, yet the latter may deviate indefinitely from the one which we might construct by bringing together artificial members or elements. 1. The different parts of a machine may very well be made by as many different workmen as there are different parts, and the parts will be made in this way with greater rapidity and with greater precision, according to the well-known principle of the division of labor. On the contrary, if we wished to have a copy of a statue, it would be a very bad policy to have one artist make an arm, another a leg, a third the trunk, and so on. Each of these parts might be copied with sufficient exactness, and yet the statue formed by putting the various pieces together would be an unsatisfactory piece of work. The same perception of the unity among relations which guides the artist is what guides, or should guide, the analyst. The same accumulation of errors or of deviations from the real relations which is manifest in the piecing together of the separate members is a consequence of synthetic procedure based upon theory. 258. It has been said that analysis is the method of discovery and synthesis the method of exposition. The fact is there is no method of discovery, and we should not consider, and actually we do not consider, anyone a discoverer who does nothing more than apply a method. We tried above to make the reason for this understood, only rarely may the method of exposition be exclusively analytical or synthetical. This has been observed by everyone who is not dominated by the systematic temper. When rigorous synthesis is possible, it ordinarily surpasses analysis in conciseness and clarity. If philosophers and those who have wished to become the interpreters of nature have more frequently been misled by the synthetic method, the reason is that, so far as we can judge, continuity is the rule and discontinuity the exception. Nevertheless, since progress in the knowledge of things results principally from the operation of the mind by means of which we distinguish, in the complex data of perception, that which originates in the nature of things themselves from the circumstances which result from our point of view or from the conditions in which we are placed when we observe them, it is clear that in this sense the method of discovery is necessarily analytical. On the other hand, we shall conform to the order of phenomena, and consequently shall simplify the exposition of them, by first making things known with respect to the circumstances of their intrinsic organization, then by examining the circumstances in which we observe them, and by finally explaining through a combination of the two processes, the complex phenomena which are the objects of our immediate observation. Because of the perfection which it has acquired and because of the simplicity of the magnificent object with which it deals, astronomy offers us a very clear example of the use of both methods. In the less perfect sciences, in which we are not sure that we have grasped the fundamental laws and the true theoretical elements, synthetic construction may lead to the accumulation of errors, and through that itself become the touchstone of the theory when the results of direct observation are compared with those which had been deduced from the synthetic construct. In this way synthetic hypotheses and constructions contribute to the perfecting of our knowledge, even though they are premature and faulty. From these remarks it is seen that when the term analysis is applied to the sciences, it refers less frequently to the breaking up of a whole into its integral parts than to the distinction of the principles whose combination furnishes the reasonable explanation of a complex phenomenon and not simply the description of the phenomenon. When we make an analysis in this sense it is not, as is customarily said, because of the weakness of our intelligence, which does not permit us to embrace the different parts of a whole all at once in a clear view. On the contrary, it is for the sake of using the most noble attribute of our minds, our ability to know the reason and to discern the fundamental truths of things. These remarks hold whether the analysis is made by the aid of reason alone, or with the assistance of intelligent experimentation, which brings into prominence the essential circumstances of the production of a phenomenon by separating from it the accessory circumstances or disturbing causes. Consequently, logicians say that we proceed analytically when we go from the particular to the general, from the concrete to the abstract, by seeking to recover the general principles or the abstract truths which should result in its solution through the examination of the particular and complex question that we wish to resolve. On the contrary, they say that we proceed synthetically or in a doctrinal manner when we go from the general to the particular, from the abstract to the concrete, or at least from a more simple abstraction to a more complex one, by combining general principles and thus by pushing the theoretical construction. 378. Until we reach the combination which, because of complexity, is immediately suited to the particular and concrete question. The former course is the procedure followed by a lawyer in his brief or in his pleading, or by a judge in his official account on the matter of litigation which has been submitted to the decision of a court. The other method is that which is followed by a professor of law in his course, or by an author in the redaction of a treatise on jurisprudence. 259. When we consider a series of connected propositions which taken together constitute a proof, it may very well be that the last term has exactly the same degree of generality as the first. It is possible to reverse the series by adapting another didactic plan for the whole theory with which the series of propositions is connected, and to deduce the first proposition from the last without changing the general character of the method. and this may be done without having any reason for distinguishing the two coherent orders by speaking of one as analytical and the other as synthetical. To find examples of such inversions of partial series, and of transposition of this sort among propositions having the same degree of generality, it is sufficient to compare elements of geometry organized according to different plans. But, on the other hand, from the point of view of logic, there will be an essential difference between the methods. In the one method we always go from one demonstrated proposition to another which is a consequence of propositions previously demonstrated, and which in its turn is found to be demonstrated that way. In the other method we go directly from the proposition to be demonstrated, as an hypothesis, by pursuing the consequences which result as much from this hypothetical proposition as from other accepted truths, until we reach a proposition which has already been recognized as true, and whose truth involves that of the hypothetical proposition which serves as the first term in the particular series of deductions. This is the inverse method of which the Greeks thought Plato was the inventor, and to which they gave the name analysis, that is to say, the method of resolution to first principles. Or of inverse solution, applying the term solution to the method of synthesis or construction by the direct method. In this latter method we move from one truth to another that the preceding one affirms, just as in constructing a building we go from the lower courses of stone to those which are superimposed upon them, without appealing to hypothetical concessions which, in this kind of construction, have the function of temporary shoring, similar to that used to support a building when we wish to repair its underpinning. 260. In this last meaning of the terms synthesis and analysis, which is very different from those which have previously been set forth, there is an allusion to two modes of construction, direct and inverse. But reference is not made either to the assembling of parts and to the breaking up of a whole into its integral parts, or even to the passage from the general to the particular and from the particular to the general. For, as we have already observed, it ordinarily happens that in the series of geometrical propositions to which the definitions of Theon and Pappus which are cited above apply, the different propositions of the series have the same degree of generality. Therefore, it should be possible to change the general method of doctrinal exposition in such a way that the order of the terms of a partial series may be reversed in it, and that the same order, which was direct or synthetic on the basis of the first method, would become indirect or analytic in the second. The proposition which originally served as a hypothesis analytic method or as consequent synthetic method now serves as the known quantity or the antecedent, with respect to propositions which now precede the partial series, and which, in the original method, were consequences of it. The analytical procedure of the Greek mathematicians was that of reductio ad absurdum, in which, in order to demonstrate the truth of a proposition, one started by setting up the contradictory proposition as a hypothesis, in order to reach, consequent by consequent, a proposition of recognized falsity, or one which contradicted a proposition recognized as true. This entails the absurdity of the hypothesis, and consequently, the truth of the contradictory proposition. Even now, in doctrinal exposition, the analytic method of the ancients is still used in this form. It is used in order to avoid the logical difficulties which the passage from discontinuity to continuity in the synthetic or direct method involves. But this same analytical procedure, which is indirect in doctrinal exposition and in questions which have to do with the logical sequence of theorems, becomes the direct method in dealing with problems to be solved. For then, nothing is more natural than to consider the problem as having been solved. For example, we assume mathematical objects upon which the problem rests with respect to the relations of magnitude and situation which we wish them to have. Then we follow out the consequences of this. Hypothetically, until we have reached constructions we know how to make, calculations we know how to perform, or, quite the contrary, constructions or calculations which are impossible and absurd, and which will prove that the problem cannot be solved. 261. The language of algebra, as it has been established by modern algebraists, is marvelously suited for dealing with mathematical problems in this way, since it furnishes means for submitting quantities to the same operations of calculation without distinction between knowns and unknowns. Consequently, we have related to the contrast of the two logical methods set forth by the Greek mathematicians the contrast between analysis and synthesis that is laid down in the mathematical language of modern writers. The term analysis now means the science of calculation, taken in its complete extension, whether considered in itself, or as applied to geometry, mechanics, physics, and so on, while the term synthesis is applied to geometry as this was dealt with by the ancients, without calculation but with the aid of figures and graphic constructions. Nevertheless, those who concern themselves with the philosophy of the sciences have not failed to observe that, when understood in this way, synthesis and analysis no longer form two logically distinct procedures. They know that it is possible to make an analysis with figures and graphic constructions, and to carry through a synthesis with algebraic symbols and calculation. This is true whether we attribute to the terms analysis and synthesis the logical meaning the ancients attached to them, in the statements of Theon and Pappus, or whether we take them in another of the logical meanings already indicated. These comments are fair, and yet we believe the meaning which the terms analysis and synthesis have assumed in the idiom of modern mathematics, simply as a result of usage and without anyone ever having attempted to take full account of it, may very well be explained and justified theoretically. This meaning is connected with a logical distinction which is more profound and more important than those with which we have already been concerned in the course of this chapter. This is the distinction that Kant made between analytic and synthetic judgments, which will appear lucid and simple if it is separated from the scholastic forms in which the great logician too often becomes involved. 382. 262 In fact, when we study an object we may start out from certain properties of the object as expressed by definitions. Then, without needing to fix our attention further on the object so long as we are careful not to violate the rules of logic, we reach the conclusions or judgments which Kant called analytic, and which, properly speaking, clarify and develop our knowledge of the object rather than extend it. These are analytical judgments because we were thought to have been given implicitly, in the notions expressed by the definitions with which we began, all the consequences that logic is able to deduce from them. Or else, on the contrary, we may need to leave our attention fixed upon the object itself, in order to find, either through experience or through some consideration or construction that the nature of the object suggests to us, a property of this object which was not implicitly contained within the terms of the definition, and which could not have been deduced from it by the force of logic alone. The judgments by means of which we affirm the existence of such properties in an object are those that Kant called synthetic and that truly express our knowledge of the object. The synthesis is empirical, if it is necessary for us to have recourse to experience in order to obtain this increase of knowledge. In the contrary case, the synthesis is a priori, and this latter synthesis is that of which pure mathematics makes use. For example, I propose to prove that two triangles are equal when they have a side and two adjacent angles equal respectively. To accomplish this, I imaginatively place one of the triangles on the other in such a way that the equal sides and the equal angles coincide. When this has been done, it is enough to go back to the notion or to the definition of a triangle in order to recognize that this entails the relation of all the similar parts. The synthesis or ideal construction is necessary in order to establish the proposition set forth on the basis of the definition of the triangle. It forms the essence and the probative force of demonstration. 263 We should call synthetic method that which consists in successively drawing, from the special nature of the object, the constructions which are suited to make known the truths we seek to establish. Similarly, by contrast, it is convenient to call analytic method that which consists in defining an object once and for all and then drawing from the progressive development of this definition all the properties of the object. In this, it is irrelevant whether this progressive development requires only that we commit ourselves to the rules of universal logic, or whether it requires that we borrow the rules of development of a science whose object is more special than universal logic, but less special than the science we wish to construct with its help. We have such a case when we use rules, in dealing with geometrical figures, which apply not only to geometrical quantities, but to any quantities whatsoever. This is precisely the sense in which modern mathematicians have been led to make use of the terms analysis and synthesis. For them, analysis includes, in addition to algebra properly so called, all branches of the calculation of quantities in which we work by means of general symbols in which every trace of the concrete, special, or particular in the nature of these quantities has been made to disappear. Once the rules of calculation have been established for a small number of fundamental properties of abstract quantities, calculation becomes a language, a logical instrument which functions by itself, so to speak, and in such a way that attention need not be fixed on anything but the observance of the rules of calculation. The advantage of the analytic method as thus defined lies principally in the generality and the regularity of its procedures. On the other hand, the synthetic process, which never makes us lose sight of the special object of our research, enables us to grasp the characteristic most immediately applicable to the manifestation of the property we have had in view, and often has the advantage of simplicity and brevity as compared with analytical procedures. Moreover, it ordinarily happens that this characteristic, which simplifies and abridges the demonstration, is what contains the immediate reason for the fact to be demonstrated. Thus, the superiority of the synthetic method consists rather less in the convenience of the course the demonstration takes, than it does in the manifestation of the true relations according to which the abstract truths which are the object of our speculations are rationally connected. Finally, the analytic method is suited to the nature of our mind in such a way that the regularity of the procedure and the symmetry of the operations gives rise to a continual application. But the synthetic process is amenable to the variety of 384 relations that nature has established among things, without being limited to systematizing them according to laws of combinations which better suit our minds and which are the basis of our logic. 264. After having attempted to emphasize the importance of this distinction perceived by Kant, we must be permitted to criticize the use he made of it in order to set mathematics, which, according to him, is always based upon an a priori synthesis, over against metaphysical speculations, which he says should consist only of analytic judgments. From the beginning, mathematics has had no less need for analysis than it has had for synthesis, even in the meaning he gives these terms. The distinctive character of the corollary is that it is implicitly given in the proposition or propositions from which it follows and can be deduced from it analytically, without a new synthesis. Yet the task of making evident certain corollaries of a proposition is no less important because of that. The results of a calculation are implicitly contained in the information given in the calculation. Yet a rare sagacity is often required to deduce them from it, and a talent of high order is needed, as is the case with every other language, to write the language of calculation with the elegance and the simplicity which it allows. The purpose of the organization of methods in mathematics, as well as in other sciences, is to reduce the work of synthetic judgments and to dispense with talent for discovery which tries to find new constructions and to work out unforeseen relations, in order to bring to light an unknown truth or to demonstrate a known truth more easily. We find in mathematics the most beautiful examples of such methods, which are powerful auxiliaries to our limited intelligence. On the other hand, if it is true that philosophy is unlike the sciences primarily because the work of the scientist tends toward the growth of our knowledge and toward new discoveries in the inexhaustible domain of nature, while the work of the philosopher tends to clarify the principles of our knowledge, and to carry out the analysis of the laws of the human mind * to which the ignorant submit quite as much as the philosopher, then it is also true that induction, analogy, the feeling for order, and all the elements of what we have called philosophical probability, supply judgment, so far as philosophical speculation is concerned, with the bases that give it the ideal construction or the synthesis a priori in pure mathematics and experience or empirical synthesis with respect to speculations about the nature of the laws of the sensible world. Kant did not take account of the latter because, in his skeptical system, he regards as null and void all truths which do not permit formal demonstration, because of which we are able to reduce sophistical contradiction to absurdity. All the reasons we have put forward against this system militate against the consequences that the author has drawn from it, so far as concerns its impact upon analytic and synthetic judgments and the applications which they make possible. 265. We have already had occasion to take exception to Leibniz's idea that the contrast between mathematics and metaphysics follows essentially from the fact that the one is founded upon what he called the principle of identity and the other on the principle of sufficient reason. We have shown that the notion of the reason of things, and that regulative principle of the human mind, namely, that nothing exists or appears unless there is a reason for its being or appearing, find their application in mathematics quite as much as in other sciences. This is the place to point out that it is by no means true that mathematical reasoning consists essentially of a series of identities, although Leibniz has said that this is the case and Condillac has charged himself with the development of the doctrine in regard to this point. This proposition, which is the counterpart of Kant's, itself fails for being too absolute. No doubt mathematics includes series of propositions with respect to which the whole art of reasoning consists in showing the identity of different expressions of the same quantity, in showing that each proposition, in spite of differences of statement, is nothing but a transformation of that which precedes it. But every time the operation of synthetic judgment intervenes, the mind grasps new properties which belong to the object by the direct contemplation of it. A science founded upon a series of operations of this kind can no more be said to be based on the principle of identity than this can be said of physics, or of any other science constructed through the aid of observation and experiments, and successively enlarged, either by the progress that has been made in the art of conducting experiments, or by the discovery of new instruments which extend the power of the senses. 386. 266. To clarify this matter still further through the use of other examples, suppose the point in question is to establish the proposition known as Archimedes' principle, namely, that a solid body immersed in a liquid loses a part of its weight which is just equal to the weight of the volume of liquid which it displaces. We can gain knowledge of this truth or demonstrate it to others by means of a direct and easily imagined experiment which is described in all treatises on physics. This is a very simple example of empirical synthesis. But we can also give a purely rational demonstration of the same truth. For that purpose we imagine that the fluid mass whose place the body occupies after immersion becomes solidified or congealed with no change in density. That is to say, the molecules of which the mass is composed, while maintaining their positions, are thought of as being connected among themselves in an invariable way, like the molecules of a solid body. The fluid mass, which we have assumed to be solidified in this way, would be in equilibrium in the midst of the surrounding fluid, for there is no reason why the connection among the molecules, which would undergo no change except that of losing some of their mobility or having their movements more restrained, should upset an already established equilibrium. Therefore the pressure which is exerted by the surrounding fluid against the solidified portion, and which tends to raise it, is exactly equal to the weight of the solidified portion which tends to make it sink. But this pressure depends only on the dimensions and the form of the solid body against which it is exerted and has nothing to do with the internal structure, the density, or the other properties of the matter of which it is composed. Therefore, if we come back to the real solid immersed in the fluid, the pressure which the surrounding fluid exerts on this body is exactly equal in intensity to the weight of a mass of liquid having the same form and the same volume, or simply having the same volume, since form has nothing to do with weight. Therefore, the body loses part of its weight as a result of being immersed in the fluid and as a result of the pressure which the surrounding medium exerts upon its surface, and this part of its weight is just equal to the weight of an identical volume of displaced liquid. This is the principle of Archimedes which we set out to demonstrate. One need not be versed either in mechanics or in physics to follow this series of propositions, and this is what allows us to enter into the details of this example, which is as clear as anyone could wish. In fact, in this case, the ideal construction or synthesis obviously consists in imagining that a portion of the fluid, having the same volume and even the same form as the immersed body, is solidified, although its molecular structure undergoes no other change than that which a change of density may induce. Moreover, we see an application of the principle of sufficient reason intervening in the judgment, by means of which we state, on the one hand, that there is no reason why the solidification should disturb the already existing equilibrium, and on the other hand, that the effect of the pressure of the surrounding fluid depends only upon the dimensions and the form of the immersed solid, and has nothing at all to do with the internal constitution and the molecular structure of this solid body. But the intervention of the principle of sufficient reason is connected in a necessary way only to this method of demonstration and synthetic construction, and not as the very basis of the proposition which we are trying to establish, and which can be reached by entirely different arguments. 268. Mathematics is peculiar in that every rational or, to use Kant's term, a priori synthesis may be checked by means of an empirical synthesis. In this way it is distinguished, on the one hand, from the physical and natural sciences, which are based primarily upon experience and upon induction, which generalizes the results of experience, on the other hand, from the sciences which rest upon the ideas and relations that reason conceives, but which do not come within the ken of the senses. After a lawyer has analyzed a contested question with the greatest care, after he has stated the principles of its solution in a form whose clarity is most satisfying to reason, he is not able, if it is necessary to do so, to furnish experiential proof of the validity of his reasonings and the exactness of his deductions, as a mathematician can do. There is another and also a very important difference between the doctrine of the lawyer and that of the mathematician. This arises from the fact that the latter deals with very simple ideas and relations, while the former is concerned with very complex ones. Therefore, while a mathematician may connect to a primary synthesis, or to a fundamental property which is given by 388. The immediate contemplation of the object, a great number of consequences, which can be deduced from it by logical combinations or by using the devices of calculation, the lawyer is frequently obliged to interrupt the series of logical deductions in order to derive new theorems or rules, which come to be combined with principles already admitted, from the direct contemplation of the object. 3. Mathematics, because of the simplicity of its subject matter, and jurisprudence, because of the complexity of the matter with which it deals, are so many types by means of which we are able to take account of the organization of the sciences and of the nature of the processes the mind follows in raising them to the position of a body of doctrine. Moreover, it may be true that in the study of the intellectual faculties of man, as in that of all the functions of life, it is not necessary to start from the rudimentary condition in which everything is confused, but, quite the contrary, from the condition of perfection in which the development of all the parts distinguishes them from one another. This being the case, might it not be better to throw light on the theory of judgment than to study the organic development that the faculty of judging must have undergone in becoming appropriate, not to the government of the individual, but to that of the collective body of the citizens, in becoming one of the molding or regulative forces of the body politic, and in creating institutions in which the individual activity of man is exercised, but always in such a way that the stamp of individual personality is wiped out so far as possible in the system of doctrinal decisions or in the series of particular judgments. Etymology should be sufficient to indicate that the judgment of the public official, charged with making decisions about laws and the fate of citizens, is what more than anything else deserves to be called judgment. Etymology should also indicate that, in some degree, it is the formal standard, borrowed by philosophers from the life of the community, in order to fix more precisely the idea of what goes on within man, and in the order of wholly personal phenomena. For therefore, following certain reflections on the scientific organization of law, we will introduce others on the nature of decisions and on the organization of judicial bodies. If one wishes to regard it as such, this will be a digression, but a digression for which we shall ask to be pardoned, since it will give us a perfectly natural opportunity to clarify, by applying them, most of the notions of general logic we have sought to bring into prominence. Should any lawyers glance at these pages, they will also pardon us for any ideas that may appear strange to them, either because of matter or of form, by remembering that we have been unable to do more than outline the subject, and to treat it in a way that is not too much different from our study as a whole. Chapter 18. Application to the mode of the organization of law and jurisprudence. 269. Nothing varies more among different peoples than the sources of their national laws, or than the historical origin of the fundamental maxims on which, from a certain period in the civilization of these peoples, the reasoning of the lawyers is carried on in such a way that it gives rise to a body of doctrine which assumes the characteristics and proportions of a science, and to which we give the name jurisprudence. The elements of law do not come only from natural equity and from the physical and moral needs that all men experience, they are also derived from the habits and the beliefs of every people, from the instincts and the fortunes of every race. They may be connected with an interest in public order or the financial system, with the need to strengthen a political institution or to wipe out the vestiges of a proscribed institution. Most of the principles or the materials of law may and actually do change with the society. In spite of the influence of the spirit of imitation and the authority of the traditions of learned men, our legislation has hardly anything in common with that of the Rome of the patricians and of the emperors. Yet the scientific form of law has varied no more than have the laws of the human mind, and the jurisprudence of Rome has remained the model for ours because of logical form. To know the laws of a country completely, including all its legislation, written or customary, is to possess a body of knowledge that is very useful in the affairs of life, and that can never be acquired in a country such as ours, in which each decade gives birth to an enormous mass of legislative and regulatory provisions. Nevertheless, no one would dream of putting a study whose objects are so variable and whose applications are so particular among the sciences properly so called. There are positions in the academies for doctors, scientific agronomists, and economists. There are none for the man of public affairs and the barrister. Anyone who does not restrict himself to learning the laws of his country and of his time for some practical purpose, but who studies ancient and contemporary legislation in order to compare them with respect to their common subject matter, and in order to recognize the general forms and to lay hold of the analogies between the different forms, sets up a veritable science in doing so. Finally, the study of law is conceived in its highest terms and in the manner which is of the greatest interest to men by anyone who seeks the reason for bodies of laws, for the causes of their decadence and their fall, and reciprocally, for the manner in which legislatures influence the genius and the history of people, in the history of man, in his moral and physical conditions, and in his relations to the external world. Such a person has raised himself to the philosophy of law. But from whatever point of view we may wish to consider the science of law, we must not confuse it with the techniques or logical procedures which serve to develop systematically the application of legal provisions, and which apply in the same way to external laws born of revolutionary turmoil or of the whims of a despot, as well as to the laws which give rules for the greatest interests of society and to the regulations invented in a scrupulously careful spirit of financial red tape or monopoly. Therefore, in jurisprudence as elsewhere, the problem is to distinguish matter and form, the material which is organized, and the organizing force. 270. In order to make this distinction easier to understand, we shall turn to some examples and shall mention the rules which, in our French law, govern the status of property in the association of man and wife. From what source are these regulations derived? They spring from a clearly simple usage like the mores of the peoples who have adopted them. 1. All profits are held in common during marriage. At the death of one of the spouses, his heirs take the real property which belongs to him in his own right. The surviving spouse, in turn, does the same with his personal goods. Then the goods acquired as a result of the labor and the savings of the couple during the marriage are divided into halves, each party taking half. Finally, the personal goods which furnish the home or the common habitation and which have been worn out and replaced from the joint revenue, become the common property of the couple. Whatever the origin of these goods, they too are divided in half. Among other peoples, whose mores impose on the woman a greater degree of dependence and restrain her outside life more, things are not done in this way. Sometimes the husband buys his wife. More often the wife gives a dowry which must be returned in case of divorce or of widowhood. Sometimes the wife is received as a slave, or sometimes as a guest, under the marital roof. In such a situation she has no interest in the labor and profit of her husband. Here we see the beginnings of total law. When, as a result of the progress of civilization, of industry, and of luxury, the Maoris have lost their original simplicity, matters affecting interests become complicated. Custom can no longer foresee every circumstance, yet it will still provide principles of solution, but it will be necessary to combine them systematically in order to adapt them to the indefinite number of combinations or cases which will require a solution. 271. Thus it is clear that nothing is more natural in the mores of a poor people than the difference established by the French common law between real property, such as fields and houses, that belongs to each spouse, and the furnishings that outfit the home. The former remain separate, the latter intermingle in the very nature of the case. But suppose a people becomes industrial and commercial. Then they will create great assets, such as working capital, credits, public funds, and shares of vast enterprises. Will the mores or customs, which express them, teach us what law must be enacted in regard to these newly created goods? Undoubtedly not, and if we wish to go back to the natural origin of the custom and enact laws in keeping with its spirit, circumstances alone would not determine arbitrators endowed with a sense of the fitness of things to decide sometimes in favor of separating, and sometimes in favor of lumping together goods of this sort, to include them in the joint possessions or to exclude them from them. However, in most cases, those making the decisions would be unable to give an exact account of the motives behind them. Moreover, and without having to suppose a very advanced development of civilization, many of the different combinations will become more complicated and make it more difficult to apply the customary principle. The couple will inherit fortunes encumbered with debts or easements, they will have real estate to reclaim or to seize, debtors to prosecute in person. This is when the law is systematically organized and becomes the object of an abstract science called jurisprudence, so that it will be possible to fix exactly the respective rights of each spouse. Reasoning by analogy, legal experts conceive of fictitious real and personal property. Then, once in possession of certain abstract ideas or forms, they follow out the logical consequences of these ideas indefinitely, and in this way derive from the simple and the abstract the solution of the most complex and the most particular cases. 272. Throughout Roman law we find examples of the simple, crude, or even barbaric customs which have given way to the development of a scientific and systematic jurisprudence, so that already nothing remains in the mores of that which the original custom determined. We shall limit ourselves to indicating the distinction between things mancipi and nec mancipi. 2. It was natural that among a poor, agricultural, and illiterate people, custom would require certain ceremonies or symbolic demonstrations such as the assistance of the libripens 3 and witnesses when the ownership of the most precious goods, such as plots of ground, slaves, horses, and cattle, was transferred. Later, when the Romans had developed the use of gold and silver, when bronze and marble were used in the decorations of their dwellings, when writing, having become common, gave them the most convenient and the surest means of recording their transactions, they were no longer in the condition of society which would give rise to this distinction. But a religious respect for the institutions of their ancestors caused this practice to be preserved as a principle of law, and the abstract consequences which were deduced from an outmoded practice by rigorous logicians gave birth to one of the most ingenious theories of the Roman law. Even today this theory taxes the sagacity of interpreters. 273. Finally, to cite a last example not taken from particular customs or special needs, we shall notice that the laws have sanctioned a principle of public and universal morality by excluding from the inheritance of a deceased person any heir who has turned against him by violent acts or by other capital offenses. On the other hand, it conforms to humanitarian feelings and to goodwill fruits of the softening of the mores by not punishing innocent children for the crimes of their fathers. How does it happen then that, according to legal experts, the children of the disinherited will receive the inheritance of their grandfather if their father is an only son, or if their uncles have been renounced, and that in the contrary case they will be excluded from this heritage. According to public morality, humanitarian feelings, and natural equity, is not the position of these children the same whether there are or are not other heirs having the same status as their culpable father? Yes, certainly, but jurisprudence intervenes with its abstractions and legal fictions. In the case in which the persons disqualified do not have joint heirs of the same rank, the children become the principal heirs, as being the closest relatives after the exclusion of those disinherited. In the contrary case, according to the abstract rules of law, they should be allowed to share jointly with the closer relatives only in so far as they may represent the disinherited person and may succeed to his rights, but, on the one hand, no one succeeds a poursuivant who is still living, and, on the other hand, the disqualified person is unable to transmit to them rights which he has lost through his own fault. 274. In order to understand better what jurisprudence is theoretically, it is necessary first of all to have its practical purpose in mind, the purpose without which it would be merely an ingenious game, or rather, would not have undergone the scientific development that we know. Jurisprudence is organized for the practical purpose of determining the solution of a judicial question, and of imposing on the judge a rule of decision. The correctness of this maxim stated by Bacon that, notwithstanding the imperfection of the rule and its frequent inconveniences, it is still better than the arbitrariness of the judge, was perceived at an early period. For now, if there are certain decisions which no one would hesitate to declare iniquitous and certain statutes which everyone would regard as pernicious or immoral, it happens still more frequently that we find no clear line of demarcation drawn between honesty and dishonesty, between equity and inequity, between utility and injury. Innumerable nuances fill the interval between the extreme terms. These are the nuances the conscientious evaluation of which should be submitted to the enlightenment and integrity of an arbitrator, whether his function is a public one or not. But such an evaluation would neither be capable of a rigorous analysis, nor, consequently, of control. It would have all the inconvenience of an arbitrary decision. It has, therefore, been necessary to outline artificial divisions, to establish an ideal discontinuity in the system in which nature proceeds through continuous transitions. For this purpose, certain fixed principles have been set up, and certain legal fictions have been invented, by means of which it is possible to reach a determinate decision in each case through the force of reason and analogy alone. Jurisprudence is organized in this way. Nevertheless, whenever the logical consequences plainly do violence to equity, to the mores, or to public opinion, as may be the case in the last instance cited above, it has been felt to be necessary to reduce what is called the severity of the law, by returning once more to its natural sources, that is to say, to feelings of equity, honesty, and the public good. This is done for the sake of drawing from them new juridical principles which must be taken into account in subsequent analyses and constructions, as well as of the anterior principles from which they detract. This accumulating of principles, some of which are more general and others more circumscribed in their application, creates all the perplexities of jurisprudence and places it in a theoretically inferior condition vis-a-vis the other abstract sciences, which derive only a very small number of primordial data from the common notions, and which are regarded as being more perfect in proportion as this number is still further reduced. 275. In practice the terms law and jurisprudence are included among those whose meaning may be extended or restricted as the case requires. But from the point of view of good logic and for the correct understanding of the scientific organization of law, all the juridical principles, no matter what their source, that science admits as so many primitive and incontestable data must be regarded as law, or at least assimilated to law properly so called, that is to say, to the will of the sovereign expressed in a written formula. This clearly includes the maxims of equity, morality, and public benefit, which are sanctioned through a unanimous consent, as well as the traditional customs which the Roman jurisconsults said resemble the law. Actually, however, positive laws may have been created on the whole in imitation of traditional customs, which have preceded them everywhere. The term jurisprudence is used especially to designate the body of doctrine established by the decisions of courts and by the opinions of renowned lawyers. However, if the courts and the lawyers have proceeded not by the method of logical analysis and deduction from principles already laid down in the law, but by the method of estimation or evaluation in a case with respect to which the law declares nothing more implicitly or explicitly, if the authority which attaches to their decisions and to their opinions is based not on the presumption that they have been well thought out, but on the presumption that they have properly weighed these decisions and opinions after they have acquired the authority necessary to set up legal principles, as we say, then they really share in the nature of the written or customary bodies of law that they supplement or which they complete. 5. On the contrary, if the legislator does not limit himself to the proclamation of principles, but charges himself with combining them and deducing their logical consequences, he really plays the role of the legal expert. In this part of his work a real science of law clothed in legislative forms must be recognized. 276. Jurisprudence attained the high degree of scientific perfection that it did among the Romans only because of the small number of their laws and because of the religious respect they so long maintained for the Code of the 12 Tables, the simplicity of which was well suited to the rude and strongly pronounced traits of the first Roman civilization. Until the fall of the Republic, one finds only a small number of laws or plebiscites for the modification of the civil legislation supervening, and the very form of these acts, which necessarily produced their extremely concise wording, obliged one to limit oneself to writing some principles implicit in them. Thus the jurisconsult could concern himself entirely with the rigor of logic, use reasoning and analogy to follow out the ultimate consequences of an abstract principle, and finally erect that systematic and learned edifice that Leibniz admired so greatly that he placed it just below geometry. 6. The legislation of the 12 Tables fell into disagreement with the Mores only too soon. When this happened, it was, if not abrogated by the Praetorian Law, at least nearly annihilated, and jurisprudence should have become more complex as a result of the loss of its regularity. However, since in the long run the Praetorian Law was formed through successive developments and amendments of a text which was sacramental, we understand why it placed fewer obstacles in the way of the scientific organization of jurisprudence than would have been set up by a voluminous collection of written laws, each of which was drawn up out of whole cloth, and the text of which would have had a sacramental value. 7. When, in turn, the Praetorian Law finally ceased to be a vital thing, and when the emperors, with that facility which is the attribute of absolute power, had thrown away legislative provisions, Roman legislation was still quite capable of receiving important improvements, several of which have been worth carrying over into the law of modern peoples. But jurisprudence was tending toward its decline, and finally, the science of the jurisconsult gave way to the erudition of the commentator and compiler. 277. The moment the legislator attempts to stabilize jurisprudence by means of a systematic code, either he intentionally derogates the logical consequences of the principles laid down by it, and as a consequence of doing this lays down new principles which give rise to all the more numerous and more complex combinations which must lead to a judicial decision, or his intention is to perpetuate the logical consequences of the fundamental principles. But he is liable to make errors, and even though he makes no mistake, he may be misunderstood because of the way in which he expresses his thought. In either case he hinders scientific development, he alters the regularity of relations, and, what is more serious, he increases the number of contested points by the very provisions which he thinks are appropriate to reduce the number of them. In fact, when the number of written laws is small, and they perpetuate only principles or affect only the simplest cases, it is necessary, if they are to be extended and made the basis of a system, to take their spirit and not their letter, to convert into a general and abstract idea the particular and concrete idea which is directly connected with the terms used by the legislator. Once this preliminary work is carried out, and it is ordinarily favored by concise or proverbial forms or by archaism of style, the task of the legal expert is no longer simply that of combining ideas. On the contrary, the more a code is extended, the more it encroaches upon doctrinal discussion, and the more jurisprudence tends to descend from the combination of ideas to the comparison of words. As for the task of the judge, if codification makes his work easier as far as the anticipated and apparently the most frequent cases are concerned, it complicates it in relation to unforeseen cases, increasing the number of texts to be related and the number of elements to be combined. 278. The predilection of moderns for the written word, a predilection which makes them regard as null and void all that is not in written form, has already been pointed out many times. In the present state of civilization, we attribute to the written symbol that sacramental value which the ancients attached to ceremonial words, to symbolic gestures, to ceremonies, and to religious rites. Thus, if we were to believe some modern philosophers and legal experts, the perfection of jurisprudence would require that we recognize no other rules of law than the written texts and official formulas. This would be the means of avoiding everything arbitrary in the administration of justice and of warding off the abuse that has long been made of such vague expressions as equity and natural right. Jurisprudence would finally take on the characteristics of positive science, which is so esteemed in our times. But, for the same reason, would it not be necessary that the law should officially establish the rules of good sense or of logic according to which the judges would have to interpret and apply written laws? Can we believe that Article 1315 of the Civil Code 8 has added to the force of this natural law, onus probandi incumbit actori, reus excipiendo fit actor? On the contrary, it has hidden it by applying it only in a special case. The legal expert and the judge must free the abstract principle from the wrapping the legal text has given it. If it never occurs to anyone to 400. Contest the generality of this maxim, if it is certain that among us a judgment would be quashed for having refused to apply the principle in any other matter than that of obligation and payment, has not the article become superfluous, and does it not offer the disadvantage of promulgating as a rule of positive law something which is only a particular application of a general maxim, the force of which exists independently of the written law, and that we have reasonably judged unnecessary to insert into it? It is not so much legal texts which limit the arbitrary power of the judge, as it is the proper organization of judicial powers, their hierarchical relations, and the manner in which they are controlled. Later on we shall have occasion to examine the way in which our judicial organization tends to fulfill this end, and how among us the nature of things has pretty much made the Court of Cassation 9 the judge of the logical application of the principles of justice, under whatever form they are expressed in law, and even when they are not expressed in it. Yet, in the minds of the founders of this institution, the Court of Cassation was to have been only the guardian of a sacramental text. 279. There is no more proverbial adage, not only among courts but also in the world at large, than this: the letter kills and the spirit makes alive. For all that, I do not know how the true principle of decision may be accounted for with sufficient clarity in arguing, according to the need of the case, sometimes from the text and sometimes from the spirit of the law, trying to make the scales of justice tilt alternately to one side or the other. Are we to understand that under the legal phrase, under the combination of words by means of which the legislator has stated his thought more or less happily, for he does not possess the qualities of the philosopher and the writer to the highest degree, it would be necessary to know how to recognize in all its generality and abstraction the principle which he has sought to establish, and the ideas he has attempted to relate and the nature of this relation? If that were the case, nothing could be more true and more important than the adage we have just cited. But do we want to say that it is necessary to go back to the spirit of the law in this sense, that if the legislator has been guided by motives of equity? 9. Interpretative law is either only the logical conclusion or the analogical extension of principles laid down in earlier laws, or it lays down new principles which may become the root for subsequent deductions, or, finally, it attributes a meaning to words that present none or present an ambiguous one. In the first case, interpretative law is useless, and it must be blamed for the defects of judicial organization, if the rigorousness of deductions and the fitness of analogies do not prevail in the end, after some transitory aberrations of slight importance from the point of view of general interest. In all countries having good judicial institutions, After the formality of the proofs which ordinarily precede interpretative law, it would be unreasonable to expect to find in the man or in the groups of men in whom the legislative power is vested, no matter what it is called, greater guarantees against logical error than is offered by judicial proofs. But there is more to this matter. The legislative power makes the law, it lays down principles as a result of an evaluation which is supreme and beyond control. It habitually rules on the basis of what seems good to it, and not on the good or bad, but logically necessary, consequences of what has appeared good to other groups at other times. Therefore, for these very reasons, the legislative power is less fit to interpret a pre-existing law logically than would be a judicial body in the functions and practices of which, on the contrary, such an interpretation reappears essentially. 11 This ineptitude will be all the more apparent when the legislative power is exercised by a larger body, under the forms which lend themselves better to instinctive estimation and less well to decisions based on abstract ideas and logical construction. On the contrary, and whether the point in question concerns general laws or special laws, a particular kind of functionary or the citizens as a whole, where the legislative power is concentrated in the hands of a less numerous council, in which case its form is more like that of judicial bodies, we are able to obtain a truly interpretative decision. And we shall have to consider such an action as having some of the characteristics of opinions and of law, of opinions in so far as it is only the logical consequence of earlier laws and as it governs past events, of law, in so far as it makes rules of a general sort, and for the future. 281. There remains to be examined the case in which the interpretative decision, which is appealed because of the inadequacy or the obscurity of existing laws, should contain new principles of juridical solution or give a determinate meaning to a text whose meaning is confused or ambiguous. This is just the case in which the maxim we mentioned should be applied, for to interpret the laws in this way is really to make a new law which can no more be enacted except for the future, without being sullied by the defect of retroactivity, than can any other law. However, this is not the opinion of most lawyers. But an estimable writer has refuted it so well that we will limit ourselves to quoting his words. It is difficult enough to give a reason why we have seen in an interpretative law something other than a new provision, subject to all the forms and conditions of a previously unknown law. Each person is the best interpreter of his own expressions, in the sense that he knows what the ideas are which he wishes to express. But this is the case only so long as his ideas appertain to him. No one who has entered into a contract would be allowed to pretend that he has attached to his statement a meaning contrary to what it had given to the party who serves as his security. Still less could legislators claim the right to declare the meaning of the law, should this meaning be contrary to the terms in which it is stated. After its promulgation, the law becomes public property. The rights that individuals have acquired as a result of this law, the obligations it has imposed on them, are existing facts and cannot be made to depend upon a declaration which, in explaining the meaning of the terms employed, distorts, alters, or modifies the state. 404. Meant. It should not affect those who have acted, agreed, or contracted as a result of faith in the law, in its original state. To put the matter in a word, it can only affect the future, just like a completely new law. 12. If judgments, says Montesquieu, became a matter of the particular opinion of the judge, we would live in society without knowing exactly what obligations we had contracted in it. 13. But what would be worse than ignorance of this sort would be to be submitted, too late, to an imperative provision concerning things in regard to which we had been led, at the moment of performing an act or entering into a contract, to count on the benefits of a conscientious evaluation and on all the latitude of an application suited to the circumstances of the particular case. 282. In the interpretation of laws, it is not always easy to distinguish the part reserved for the legislative power and that which reverts back to the authority of the judiciary. It is still less easy, for reasons embedded in the nature of things, to define clearly the prerogatives of the power which makes the laws, and those of the power which has as its essential task to provide for the carrying out of the laws and is, for that reason, invested with the right to prescribe regulative stipulations which are equally obligatory for all citizens and which have the greatest sort of affinity to laws properly so called. Indeed, these stipulations often have even more affinity than there is among the resolutions to which official form allocates the common denomination of law, because these resolutions emanate entirely from a like power which is officially called legislative power. To vote alone, a levy of men, a declaration of war, a treaty of peace, a budget, an approval of accounts, a tax, or a political, administrative, penal, or civil law, is to fulfill functions among which there is a greater difference than there is between the functions of legislative power taken in their entirety and those of other public powers. When, in regard to all these matters, the legislature must consult the nation as a whole or those assemblies which are constitutionally provided to represent it, we willingly acquiesce. But must the manner of consulting them and of getting their response be the same? Is it convenient to apply the same forms of procedure to acts so essentially different? Today everyone clearly understands that the judicial decisions gathered together under the common name of judgments and decrees do not have the same nature. In civil matters, the institution of recourse to appeal; in criminal matters, the introduction of judgments by juries make us aware of a distinction which is none other than the distinction between conscientious appraisal and dialectical judgment, as we shall try to show in the following chapter. It is understood that judicial functions of different sorts are no less distinct for being entrusted sometimes or even most ordinarily to the same person, as is the case with us in our inferior and appellate courts in both civil matters and misdemeanors. Similarly, our legislative assemblies reconcile functions analogous to those of judge and jury, with this difference, which comes from the nature of the object and not from the nature of the intellectual act, namely, that more often than not they make rules that apply generally and not to particular cases. To organize the legislative procedure in such a way as to separate these functions, to surmount so far as possible the obstacles which in practice tend to maintain confusion, is, we believe, one of those essential improvements with which the public mind will have to concern itself if such questions are ever to be treated without partisanship, except in those periods of political crisis which seem to be diminishing gradually in intensity if not in frequency. At least this will be necessary provided we admit that, in the economy of human societies as well as in the physical world, everything must, in the long run, tend toward a stable condition and a permanent order. 283. Let us see how authority, guided by public good sense, proceeds in these matters outside of politics. Let us suppose the question at issue is to judge the worth of a work of art, a statue, picture, or musical composition. Shall we get the opinion of a celebrated artist or of an academy of artists? No doubt we could do this, and this is a course administrators sometimes take, but it is often found to be bad. The judgment of experts is upset by the public, as we say, and these are decisions of the public which posterity, a judge from whose decisions there can be no appeal, usually confirms. On the other hand, if the question is one of judging the worth of a discovery in mechanics or chemistry, we address ourselves to the Academy of Science, which is a more 406 competent body than the public. The Academy will refer the memorandum to a committee or to a section which is better able to appraise it than the Academy as a whole would be. The section, in turn, will select to make a report those of its members who have specialized training in that branch of science with which the memorandum seems to be concerned. If we admit, in the case of a scientific problem as in that of a work of art, that personal passions or interests do not obscure the reason or pervert the taste of judges, the guarantee of the excellence of the judgment seems to be increased, in one case by augmenting, and in the other case by reducing the number of judges. It might be possible to say that special instruction is necessary to understand anything related to questions of mechanics and chemistry, while only eyes or ears are necessary to find a picture beautiful or ugly, or a musical composition melodious or strident. The first part of the assertion is incontestable, and this is an excellent reason why we never dream of making the reputation of a mechanic or a chemist depend upon the masses. But it is false to assert that the degree of training of the poetic or musical sense has no influence on the worth of the appraisal made of a tragedy or an opera. If I must take a chance on the opinion of a man of the street, of a man of the world, or of an academician, I should go to the last rather than to the two others, provided only that I have reason to believe he is neither interested nor partial. But although the opinion of an artist, or of an expert, as we say, may prevail over each of the individual opinions which concur to form the general or common opinion, this latter opinion must prevail over the opinion of the artist. This is so because in these matters, in which the question is one of evaluation and of inexplicable judgments as Leibniz put it, one for rather than of dialectical or explicable judgments, it may be said with good reason that no one person has as much wit, or even better, as much discernment as all persons. 15284. A conclusion of this sort may be accounted for in two different ways. Where things that do not permit of logical precision are concerned, the opinions of men influence each other reciprocally, errors on the part of one counteract the errors of another. We look for the sound evaluation of things within the limits between which we find most of the persons making a judgment, and thus we reach a common evaluation which is the result of all the individual gropings. It is in this way that, through the mutual reactions of a mass of molecules disturbed by confused movements, a common movement is definitely established which tends to perpetuate itself with regularity. Disregarding the reciprocal influence that the appraisers exert on one another, even when we consider their appraisals as so many isolated and independent facts, there would be good reason why the average evaluation among a large number of individual evaluations would, in general, give more protection than any single evaluation, taken at random from the group which most frequently makes them. This reason, which is connected with the mathematical theory of chances, is the same as that which determines that the value of an angle will ordinarily be obtained with greater precision, by taking the arithmetic average of a great number of observations made with a somewhat imperfect instrument, than if we were to limit ourselves to one or two observations made with even a very perfect instrument. Obviously, the situation would be entirely different if we had reason to believe that the construction of the instrument caused it to tend to make more errors in one direction than in another, for example, errors of excess rather than errors of deficiency. If this were the case, by multiplying observations with a defective instrument, far from decreasing the probable error of the average value, we should increase it. Similarly, if we have reason to believe that the judges who make the evaluations are under the influence of a strong feeling or of a prejudice which acts in the same way upon most of them, then the more numerous the judges, the greater the chance that the conclusion of the average evaluation will be notably erroneous. 285. If we return to the subject that gave rise to these explanations, our attention will be focused upon one important point among many others which might give rise to innumerable comments. In provisions pertaining to legislation, the legislator evaluates or he arranges. For example, he evaluates when he lays down the principles of civil law, when he elevates into imperative maxims for the magistrate the rules suggested to him by equity, public utility, the mores and the customs of the country, he arranges when he applies himself to the work of codification. He evaluates when he fixes the condition of the age or property qualifications that must be met to be a voter or to be qualified to be elected to office, he arranges when he organizes the forms of the election. He evaluates when, from a feeling for the needs of his country, he decrees a loan, a tax, or a bill of indemnity, he arranges when, in a system of political economy, he sets up a schedule of duties or when he organizes a tax schedule on the transfer of property which gives rise to complicated jurisprudence. What has reason to say about this, when freed from prejudices or interests which may be set up to sustain what is called the prerogative of such and such a power? In the first place, that the legislative mandate is a chimerical fiction in the present condition of peoples, that a legislative assembly does not represent the country from which it has been elected in the way the representative represents his constituency, but that in accordance with the conditions of election, there may be more or less probability that the opinion of the majority of the assembly squares with that of the majority of the inhabitants of the country, or at least with a majority of those eligible to vote, where all the citizens without distinction are not called upon to take part in the election of members of the assembly. That, All things being equal in every other respect, this probability is increased as the assembly becomes more numerous. That, in the hypothesis which, perhaps, is destined to apply only to the utopian state for a long time, according to which the decision of the assembly will be protected from the influence of political passions and prejudices, the probability of the excellence of the evaluation which motivates it increases, at least within certain limits, as the number of voters increases. That if, coming back to the actual situation, we take account of this influence, increasing the number of voters will have the effect of making more probable, not exactly the excellence of the evaluation, but its conformity with the evaluation which would be made by inhabitants of the country under the same circumstances, if they could be directly consulted. Therefore, we completely understand the intervention of large assemblies in legislative declarations, every time these declarations are connected with a judgment of evaluation which is not broken down into a series of abstractions and logical constructions. But if the question concerns the matter of grouping, of logically organizing the consequences of a principle, what need is there to insist on what has become the object of daily observations by everyone, namely, that large assemblies have to surmount inextricable difficulties in order to bring such a task to a successful conclusion? We have seen that for magnanimous resolutions, for acts of lofty politics, large assemblies find the vigor, the decision, and even the surety of judgment and the clarity of views which may be missed in a gathering of a few capable persons seated around a council table. But why speak of assemblies when the public square offers us an illustration of the same facts on a much larger scale? Has not the common sense of the pedipal become proverbial? And what do we mean by common sense if not the habitual correctness of its instinctive judgment, when it is not given up to those violent emotions which can make it change momentarily into a blind instrument of destruction? 410. 286. The ancients understood this very well, and, among the Romans especially, the populace would respond yea or nay, like our juries, to the proposition of a magistrate from whom the law takes its name, because he was regarded as the author of it. No one would think of discussing amendments in the forum, the people accepted or rejected the whole instrument, as is reputed to have been done sometimes in our own day, in the case of those laws which are regarded as fundamental and which we call constitutions. Would not this role of national jury be the natural role of modern political assemblies, which, as we must fully recognize, have at one and the same time the qualities and the faults of the great popular assemblies among the peoples of antiquity? Would not the proper organization of legislative power require that we should concentrate the logical work of editing and coordinating the laws more on it, and that we should separate this more completely from the function which consists in an instinctive and conscientious evaluation? No one should expect to see such grave and such complex questions, which we deal with here only incidentally, treated with the serious intention of demanding innovations or of indicating reforms. No one respects more than we do the practical spirit, and no one is more struck by the immense gap found between the conception of an idea or an abstract form and its application to the realities of life. But, on the other hand, every abstract or philosophic conception is capable of practical consequences which may serve as tests and proofs in the judging of the very value of the idea, and it is not unprofitable for us to pay attention to that claim at any rate. It is for the same purpose and with the same caution that we move on to deal rapidly with some no less important questions that underlie the organization of judicial power, by showing in what way these questions are connected with the points of logic which interest us. R. Chapter 19. Application to judicial organization, n. Particularly to the distinction between questions of fact and of law. 287. We shall speak first of criminal justice, the administration of which more nearly resembles the form of political organization than does that of civil justice. Not only are the life, the honor, and the liberty of citizens more precious goods than those which are the object of civil disputes, but also the confusion which has prevailed for so long between public crimes and private crimes. One would have surrendered to the judicial power all the institutions of the country, if in free states we had not assumed the task of limiting the jurisdiction of the criminal judge. On the contrary, wherever despotism is identified with the national mores, the administration of criminal justice has been a pure emanation of despotic power. The deputies of the ruler inflict corporal or pecuniary punishments, yet we cannot believe that their ignorance or their partiality in carrying out this function, which is prejudicial to certain individuals, alters the political constitution. Everyone knows that the English have always regarded the intervention of juries in criminal matters as the measure of their political freedom, and that one of the first acts of the Constituent Assembly was to establish in France the institution of the jury in cases involving major crimes. This institution is among those which, having persisted in spite of all political reactions, may now be considered as being a part of the constitutional or fundamental law of the country. 288 However, for our present purpose, which is to examine from the point of view of certain abstract and theoretical relations an institution on which so much has already been written, let us begin by setting aside the idea of judgment of peers, which is an artificial resurrection of the traditions of another age, which perhaps never conformed exactly to a historical reality. But, as a matter of fact, at the same time that the institution of the jury was being perpetuated in England, the other nations of Western Europe, which are also descended from Germanic tribes or at least were molded by their domination or impregnated with their spirit for a long time, quietly allowed the bench to assume a sovereign power in regard to criminal matters. If this was so, it was the natural result of the modification of the mores and of the progress of society. It was no longer a question of murder, rape, pillaging by armed forces, peculation, or patent corruption on the part of the most important personages as it had been in barbaric times, or even in the republics of antiquity. For some time past, the class of malefactors has not been recruited from the upper classes of society, except in rare instances. Where the political passions had been allayed, where the Inquisition did not succeed in setting up its formidable tribunals, the chance of falling victim to a slanderous and capital accusation was so slight that most citizens cared little about the need for obtaining guarantees against the magistracy armed with the sword of justice. Now the same causes are continuing to act. And from that day when the distinction between offences against the political order and those against the moral order shall have been introduced into the laws as completely as it exists in opinion, we shall be interested in the system of criminal procedure and jurisdiction because of love of humanity, order, and justice, rather than from motives of safety or of personal guarantees. We shall seek possible improvements in this part of legal organization, just as we seek those that permit the regulation of prisons and penitentiaries without being seriously afraid that we may ourselves be placed in the condition of condemned men or convicts. Therefore, let us put aside every political consideration and suppose that we are dealing simply with offences against the general order of society. Let us see what the guarantees of the accused and of society, of humanity, and of justice may and should be in terms of this hypothesis. 289. Three elements concur in the formation of a judgment in a criminal matter: there is a fact to be established, an action to be evaluated, and a penalty to be determined. Ordinarily the accused denies certain deeds which are imputed to him. Collaterally he contests the character of criminality that is attached to it, and, finally, he raises questions as to the application of the penalty. When efforts were made to allot the judicial functions in criminal matters on the basis of theoretical considerations, one of the benches of the court was given the first 2 points to decide, under the heading of questions of fact, at one time distinguishing them clearly, and at another time confusing them by the way in which the questions are stated. 2. The third point was given to the other bench to settle, under the heading of questions of law. As we see it, all three questions are by the nature of things questions of fact and not of law, in the sense that in most cases they cannot be settled in accordance with a system of fixed and general rules by means of abstraction and logical construction. But for each particular case submitted to the judges, the solution of the three questions depends upon a conscientious evaluation in which the most learned may err, for want of scientific rules. 3. The physical fact which is the ground for the accusation either has or has not taken place. Nothing can be more categorical than this disjunction. What is susceptible of continuous variation is the probability of the fact. This is almost never certain with a certainty comparable to that given by the testimony of the senses. And, since in most cases of this sort we must be content with high probabilities or run the risk of paralyzing the action of justice or of seriously compromising the security of the citizens and of the social order, it is impossible to assign the point at which probability ought to determine the affirmative response of the judge about the truth of the fact. A twofold appraisal necessarily occurs at this point. First, an appraisal of the probability of the fact, affirmed by the indictment and denied by the defense. This probability, which is capable of all degrees of variation, is certainly not one of a type which results in an evaluation which can be submitted to the general processes of calculation. In the second place, there is the judgment that this probability either is sufficient or is not sufficient, depending upon the circumstances of the case, to lead the judge to declare the fact to be established. It is incontestable that the judge will and should show himself more or less exacting with respect to the evidence of the fact, depending upon whether the verdict will have more or less serious consequences for the accused, and whether there will be more or less danger to society in not being content with evidences of the sort which are found in the particular case. For example, the case of domestic theft, the unrest that it introduces in families, and the difficulty of proving independently the declaration of the master will be sufficient to lead the judge to declare a fact of domestic theft indubitable on the basis of testimony which would appear insufficient for facts of another sort. It is apparent that the evaluation of the moral character of the action, based upon inferences drawn from different circumstances, may no more be submitted to invariable rules than may judgments of evaluation relative to the establishing of physical facts. Finally, the scale of penalties can only be graded in such a way that everyone senses its insufficiency for the exact correlation of the penalty with the offense. 290. Nevertheless, legislators have sought to establish scales of penalties, and in general they have thought it their duty to seek to proscribe arbitrary penalties, a laudable aim if it can be attained. In the same way, in regard to matters of civil interest, it frequently happens that the legislator would rather offend natural equity than leave the solution of all the disputes which may be raised among the citizens to the arbitrary action of the civil judge. It is better to run the risk of there not being a perfect correlation between the harshness of the punishment and the seriousness of the offense, than it is to run the risk of error or prevarication by the judge in criminal matters, in the dispensation of his discretionary powers. Moreover, since penalties are instituted only in the general interest of society, and rather less to punish the culpable than to assure the maintenance of laws through salutary fear, the matter of estimating the penalty which should make this fear efficacious and of deciding to what extent the interests of individuals need to be sacrificed to a general plan of social organization falls within the functions of the legislator rather than those of the judge. But, in that case, the system must be complete. Rules, that is to say, legal presumptions, must also be established both to determine the physical fact which gives rise to criminal proceedings, and to determine its criminal character. It is necessary to come back to the system which has so often been attacked, and so reasonably so, because the life, the honor, and the liberty of the citizens is not to be put at the mercy of legal presumptions, because even considerations which touch upon the public interest should yield before considerations which touch upon individual interests of this kind, because a criminal judgment which has moral effects should always be invested with a character of morality which may not square with the logical and artificial combinations of a system of legal presumptions. To wish to split up such a system, to accept one part and reject another, to proscribe here fixed rules and legal presumptions for the purpose of giving the judgment a moral character, to establish their fixed rules for the purpose of excluding the arbitrary, is a chimerical pretension whose illusory character is perfectly demonstrated by the practice of the courts and by the history of our modern legislation concerning the organization of criminal justice. When we entrust the function of declaring the culpability and that of applying the penalty to different courts or to distinct members or distinct benches within the same court, it always happens, or at least it should generally happen, that the verdict of guilty adjusts itself to the legal formula of the penalty in such a way as to satisfy the conscience of the deciding judge as much as possible, or to deviate as little as possible from the end his conscience would have wished to attain. As gaps in the system of penal legislation become more perceptible, decisions of the discretionary power will present more incoherence. The judge will say yes or no in nearly identical cases, he will acquit purely and simply or he will condemn to capital punishment, because a slight weight will incline the balance to one side rather than to the other, and because the law has left to him no mean term between yes and no, between acquittal and a death sentence. 291. Because of the common notions that are connected with the terms fact and law, it is supposed that the simplest and in some way the plainest of the elements which concur in forming the judgment of guilt has to do with establishing the material fact. 416. This is so because it is fancied that neither experience nor perspicacity beyond the ordinary are necessary for this, and that ordinary good sense is sufficient. It is also thought that this is the reason why it is convenient to give over the task of establishing the fact to citizens chosen by lot. On the other hand, the question of law, that is to say, the application of the penal law, requires special knowledge and professional study and must, for these reasons, fall within the prerogative of permanent magistrates. What is surprising is that such a doctrine not only has been set forth by speculative minds, but also has been admitted and stated with approbation or at least without debate by men versed in the practice of criminal matters, whereas the experience of legal disputes daily contradicts it. In most cases, would not the task of the defense be completed after the jury had given its verdict, had the law not left to the judge a certain latitude in the fixing of the penalty? Do we not often see that after this verdict contests begin between the lawyer for the defense and the public prosecutor, contests like those in which they engage prior to the verdicts of the jury, discussions like those which could not fail to give birth to a civil suit, however unimportant they might be? The fact is that, in most cases, barring a very imperfect editing of the penal law, nothing is more simple and gives less occasion for controversy than the application of this law, while, except for cases of flagrant offense, a combination of rather unusual circumstances is necessary before it is impossible for the accused, overwhelmed by the weight of the evidence, to try to arrange the facts and the witnesses in such a way as to leave doubt and hesitation in the mind of the jurors, at least momentarily. 292. If the interests of the accused and those of the accuser are presented on the same basis, if the only thing we have in view is to reach the judgment most protected against the chances of error, whether these turn out to be to the detriment of the accuser or of the accused, if, nonetheless, in order to protect the citizens against the excess of power or of the overeagerness of a permanent magistrate, we proceed to separate the judicial functions in criminal matters, then certain conclusions are clear. The best thing would be to entrust chosen persons, real experts, with that function which is ordinarily most difficult, namely, that of evaluating the probability of the physical fact and of deciding if it ought to lead to our affirmative verdict, except that afterwards adventitiously chosen judges would make a decision about the moral character of the actions, of which every man of upright mind makes a just evaluation, or about the determination of the penalty, which no longer requires special knowledge or aptitudes. But in making the accidental and inexperienced judge responsible for the task which is ordinarily most difficult, the legislator has had another end in mind. He has wished to turn the very inexperience of the judge and the diffidence which results from it to the profit of the accused. He has wished that there may be many undeserved and poorly grounded acquittals, and he has prejudged the human heart by thinking that nearly always when the juror senses that the verdict exceeds his courage, when his judgment has been confused by the eloquence of the lawyer, when the length and complexity of the pleas has exceeded the limits of his attention, he would nearly always render a verdict of acquittal. However paradoxical this assertion may seem to be, we have no hesitation in saying that what moves juries or inexperienced judges to intervene in a criminal action in order to establish the facts of the case is not the easiness but, on the contrary, the difficulty of the question submitted to them. At least this is the case when this intervention is independent of all political considerations. Moreover, in judging the fact, it is natural that jurors indirectly judge what is called the law. That is to say, they virtually decide, although in a roundabout way, on the application of the penalty, on the basis of the correlation that they do not fail to establish between their verdict and the prescribed form of the penalty. The legislators of the Constituent Assembly and those in France who have gone on with the acclimatization of the jury have vainly wished that the verdict should be given without regard for the penalty by making it the object of ceremonial instruction to the jury. Their efforts have foundered before the superior laws of the human heart, and the omnipotence of the jury, proscribed by the text of the law, has become an actual truth which is made more venerable with each passing day. Whatever a person may have done, the jury has the penalty in mind in the writing of its verdict. If, on occasion, something is lacking or it is mistaken in its views, it hastens to make a protest against the mistake in the only way the laws leave open to it, by an appeal for mercy. Instead of contending against an irresistible predisposition, Leg. 418. Legislators should have seen that the morality of a judgment of guilt consists in evaluating the culpability and fixing the penalty, rather than in the preliminary declarations of the truth of the physical fact. And they should also have seen that the character of morality, sought for in such a judgment, can result only from a conscientious evaluation, protected from invariable rules. 293. But in admitting the incontestable fact that jurors virtually decide on the penalty, there are still good reasons why their power in that respect can only be indirect. On the one hand, the ideas concerning the organization of public power, ideas which we became familiar with long ago, would be harmed if the sentence to punishment were to come directly from temporary judges, ordinary citizens, and not from permanent judges who are invested with a public character. On the other hand, and this consideration is still more decisive, the ordinary citizen who wishes unequivocally to lend assistance to the law and who knows the consequences of his vote with respect to the application of the penalty could not easily persuade himself to be the direct instrument of the severity of the law or to appear to fix directly the penalty of which he is, nevertheless, the true arbiter through the correlation he establishes between his verdict and the legal scale of punishment. There is something painful and often harrowing in fulfilling such a function, for which the honors of the magistracy are a poor compensation, and from which it is well to spare ordinary citizens, especially for fear that their all too natural repugnance may paralyze public prosecution. Therefore, there can be no question either of abolishing the scale of penalties or of transferring to the jury either the fixing or the direct application of the penalty. It is important only to convince oneself that, once the jury has been admitted into criminal matters, it becomes the natural and necessary judge of everything that falls within the scope of conscientious evaluation, and that it falls to its lot to determine the degree of culpability as well as the decision as to the penalty. Then, far from contradicting this natural tendency by written laws, we shall adapt the laws to this tendency in such a way as most nearly to approach the desirable end and especially to escape the inconsistency of judicial decisions. We shall see in the graduated series of penalties only a framework offered to the jury to excuse it from a dreaded initiative, and in the sentence of the magistrate only a solemn sanction given to the opinion of the jury. This solemn sanction should be of the same sort as that which the president of the Court of Assize gives to the verdict of not guilty, as a result of his order of acquittal. This sanction should require no further review or logical deduction on the part of permanent judges. Indeed, this assumes, on the one hand, that the law does not charge the permanent judges with the task of fixing the penalty within certain limits, on the other hand, that the forms of questions and answers for the jurors are limited to being found in such simple correlation with the penal formulas that there can be no doubt as to the consequences of the verdict. Now, it seems to us that the legislator should work out this double hypothesis. In the first place, when in a great many cases we have trusted the judgment of the jurors for such delicate and difficult evaluations as that of establishing a physical fact or even that of fixing the degree of moral responsibility, it is strange that later on we should fear to trust them to estimate, between the legal limits, the severity of the penalty, a kind of evaluation for which experience and special knowledge are least necessary. For, in the second place, the jury, uncertain of the consequences of its decision because of the latitude of evaluation left to the permanent judges, rarely fails to adapt its verdict to the case in which the latter would assess the maximum penalty. This will render the moderating power of the permanent judges illusory or will upset the organization of penal law. For the same reason, if the jury feels uncertain about the correlation of its verdict with the rule of punishment, it will formulate its verdict in view of the hypothesis which is most unfavorable to the accused, which will often decrease the penalty even below the standard to which the humanity of the jury wishes to reduce it. 294. But, if these principles are admitted, what part will be left to the permanent judges in the disposition of criminal justice? It will remain for them to decide questions concerning jurisdiction and procedure, pleas and prescriptions which, in criminal cases, are the only questions which may properly be called questions of law. Great as is the discretionary power that the legislator should leave to the judges concerning the matter, it is equally important to maintain in judgments concerning the issues involved that character of morality which can result only from a conscientious evaluation, protected from the authority of fixed principles, and it is just as indispensable to define with certainty and to maintain invariably the conditions which give rise to the occasion for this discretionary power and which indicate the bounds beyond which it must not go. Everyone senses that the social order would be upset if it were left to the discretion of the judges to extend or curtail their jurisdiction, to invert the methods of accusation or defense. Everyone senses that there is no middle ground between being under and not being under the jurisdiction of a court, between observing and transgressing judicial forms, that the solution of all questions that may be raised on this subject should come from a system of rigorous deductions, that these are questions of public order to which that character of morality fundamentally inherent in matters of criminal judgment is not connected. From the moment that accidents of procedure may affect the issues involved, when, for example, they tend to extend or to restrain the means of defense, they clothe the issue with an inherently moral character, they fall indirectly within the domain of the evaluator. Thus it would be fruitless for the law to forbid to the accused certain discussions of principles and the production of certain witnesses. It would be useless for the law to say fictitiously that certain facts and documents that have a real and physical existence are null and void. It would be vain for the magistrate, in obedience to the law or in the use of a discretionary power with which it had invested him, to draw up similar limits for the defense. The jury would judge as if the alleged facts had been proven, and as if the witnesses to whom audience had been refused had testified in support of the statement of the accused. 295. The question of the number of judges advisable for the composition of the permanent bench of the criminal court has often been discussed. The solution evidently depends upon the nature of the functions that are attributed to this bench. If these functions are limited to clothing the evaluations of the jury with a ceremonial ratification, to pronouncing the verdict of acquittal or penalty which has a necessary correlation with the verdict, one magistrate is sufficient, since there should be nothing for him to deliberate upon. If the permanent bench is vested with a power of evaluation in regard to such matters as fixing the penalty within limits which are often very wide, there is reason, as there is in all judgments of evaluation, to demand the intervention of a greater number of judges. This is so because, in general, the guarantees of justice in judgments of this sort are increased with the number of those who have a share in them and whose opinions reciprocally influence each other. When the permanent section is formed of 3 judges, as it is according to the French law in force at the present time, we should be appalled at the exorbitant power with which 2 men are invested in certain cases of extending or shortening the imprisonment of a citizen many years, of deciding the amount of a fine between limits one of which is minimal while the other would completely exhaust the fortune of the condemned person, if it were not true that for other reasons we are nearly always sure that the verdict of the jury is formulated in anticipation of the maximum penalty, and that the person has been virtually condemned to this maximum by the agreement of at least 7 judges, who are naturally more inclined toward indulgence than toward severity. 296. The distinction between fact and law, in the judgments rendered in civil suits, is seen more or less clearly depending upon the nature of the judicial institutions and the forms of the procedures in use in various countries. In Rome, where the magistrate charged with affirming the law and dispensing justice would have been inadequate for the examination of the particular circumstances of each suit, he would make a distinction between law and fact, between the abstract and the concrete, between the rule and the arbitration at the beginning of the proceedings. The praetor, in drawing up a prescribed form that is comparable to the English writ, would deduce the consequences applicable to the case being tried on the basis of the law or of the maxims of jurisprudence which he had set up as a rule. He would subordinate the application of the prescribed form to the verification of certain facts, to the appraisal of certain circumstances, for which he would send the parties before the judges, arbitrators, or experts, to whom the prescribed form is addressed, and who should by limiting them. 422. Selves to the wording of the prescribed form, condemn or free the party against whom the action was directed. Judex esto, or recuperatoris sunto. Si parat. Condemnato, si non parat, absolvito. 5. This was a syllogism, of which the magistrate, or the chief justice, laid down the major premise and deduced the consequences by presenting the minor under the form of a hypothesis, the truth or falsity of which would have to be declared by the judge delegated by him, who was a veritable jury with respect to civil matters. Quite unlike our jury in criminal matters, the judex would derive from the delegation of the supreme magistrate the power of himself pronouncing condemnation or acquittal, but this difference holds less in regard to the substance of the issue than to the form, and to the ideas of each people as to the organization of public authority. Moreover, by force of circumstances, the Roman judex, like our jury in criminal matters, was called upon not only to establish facts but also to recognize the laws resulting from the facts. The prescribed forms given by the praetor were sometimes relative to the law, sometimes relative to the fact, just as in English procedure the parties join an issue either of law or of fact. The forms may even be in jus and in factum at the same time. 6. Some times the prescribed forms suppose the fact to be established, sometimes they leave it to be established by the judge, sometimes they determine exactly the amount of the pecuniary punishment that the judge should pronounce, after he has recognized the truth of the fact or the correct application of the law, without being able, at least on the basis of personal responsibility, to sentence to the payment of a greater or lesser sum. Sometimes they only assign a limit that the sentence by the judge should not exceed, sometimes they leave it entirely to his evaluation. Therefore, the functions of the judex are not limited to the establishment of a material fact. He is also charged with giving an opinion concerning what is good and equitable ex bono et equo judicare. He even passes on the strict right, in this sense, that he discovers, according to the elements which gave him an understanding of the action, and in conformity with the indications of the prescribed form, the right to reclaim the ownership of goods, the right to demand a sum of money or the rendering of a service. Yet he has not, according to the ideas the Romans were used to, the power of restoring the ownership of goods, or of compelling the performance of a service, but only that of fixing a pecuniary compensation or, as we say, damages. As a matter of fact, he has a right to pass judgment on everything not decided in advance, in a general way according to fixed rules, independently of all knowledge gathered from the circumstances peculiar to the suit. His decisions as to the law, motivated by the evaluation of circumstances which are particular and essentially variable from one case to another, are those which cannot be made by jurisprudence or which do not concur to give its systematic development and its rational construction to the interpretation of legal statutes and judicial aphorisms. This latter belongs to the jurisdiction of the praetor. Consequently, since the greatest number of lawsuits, as much among the Romans as among us, should not have presented those difficulties which follow from the scientific development of law and which are concerned with doctrine, it would most frequently happen that the intervention of the praetor, for the purpose of stating the prescribed rule and the designation of the judge, was an act of authority rather than a judicial decision. It was an act comparable to that by which, among us, a court names experts or submits the case to arbitrators for whom the function is reserved of confirming the decision, in order to give them executory force by bestowing on them the seal and the bond of public authority. Now, it is perfectly clear that when among us, for example, in accordance with the direction of the law, a court sends the judgment in a suit that arises between commercial partners back to the arbitrators, The latter not only have the duty of establishing the facts but also of evaluating such reciprocal rights and obligations between the parties to an action as result from the facts which have led to the suit. It is no less evident that, if the legislator has prescribed that suits of this nature be sent back to the arbitrators, the reason is that it is because he wished the decision in each case to be the result of an evaluation which is both conscientious and made in good faith and is made by persons acquainted with business affairs. He did not want the decision to result from a rigorous application of certain logical rules, as is the habit of ordinary judges, for whom making decisions. Fundamentally, the system of prescribed forms is nothing but a clever means of setting up a jury in civil matters. It is necessary to proceed from the principle that the judge is not a magistrate, but simply a citizen, that he has, consequently, no other prerogative than those which are conferred upon him by the magistrate. Outside of the terms of the prescribed forms, he is without power. The wording of the forms is, therefore, the principal point in the procedure. Juridical science directs all its attention to this and works on it unceasingly. The analysis and concatenation of its conclusions, the conciseness and correctness of its terms are admirable. Every law, if it needs ever so slight a shading, is foreseen, for every law requires a special prescribed form for its operation. The prescribed forms are drawn up in advance, incorporated into jurisprudence, inscribed on the album and laid open to the public for examination. The plaintiff, coming before the court of the magistrate, indicates what he asks for. The elements of the case are debated between the parties, the form adapted to the particular case, and finally delivered to the praetor. 8. Then the judge, the appraiser of fact or of law, depending on the case, listens to the parties, makes proper verifications, resolves the problem which has been presented to him, and renders his decision within the limit of the powers conferred upon him by the prescribed form. Thus, so far as we are able to judge, following the discovery of valuable fragments, and especially that of the manuscript of Gaius, which have thrown their light on this previously very obscure point of Roman institutions, the organization of the judicium and of the formulary procedure was naturally adapted, not to the distinction between fact and law, in the narrow sense which has for so long a time falsified our ideas as to the role and functions of the jury in criminal matters, but rather to another distinction which has its fundamental cause in the nature of the objects of thought and in the laws of thought itself, and which does not permit judgment by means of logical construction and judgment by means of conscientious evaluation to be confused, any more than it is possible to confuse the power of calculation and the reliability of taste. Is this to say that, in the time of the Scipios and the Gracchi, the legal experts of ancient Rome had taken account, through profound logicians and philosophical generalizers, of the different paths the human mind follows, and the different aptitudes that it develops depending upon whether it reasons or evaluates? Far from it, nothing is more characteristic and, from our point of view, less liberal and more strict than the prejudices and the traditions of city or of caste which have progressively introduced this philosophical and learned organization. This follows from the very simple reason that the laws of logic and the permanent conditions of the human mind in general come, in the long run, to prevail over accidental causes and traditional influences in institutions, by imprinting a definitive form on the structure of which the materials alone bear the trace of the earliest beginnings. The formulary procedure was substituted in the 6th century of Rome for the ancient procedure of actions at law, true ritual by means of which the patrician class was able to get back into its hands the tie which connected the political and civil institutions with the religious institutions. The author we have just cited says, the prescribed form was a simplified derivation of what was important and fundamental in the actions at law. The demonstratio, which indicated the object of litigation, replaced in a purely intellectual way those pantomimes, gestures, deposits of objects or of symbolic remains, the purpose of which is to make this demonstration tangible in the action at law. And it may be noted that the intentio, which indicated the claim of the plaintiff, was evidently enough copied from the very words pronounced by the plaintiff in the action at law. For example, the plaintiff said, Hunc ego hominum ex jure quiritium mern seaio, 9. In the sacramentum in actions concerning things rather than persons, by touching with the lance, the vendita, the man against whom he complained, si parat hominem ex jure quiritium aliegri ise, 10 said the praetor in his prescribed form for real action. These are the same ideas materialized in the action at law, spiritualized in the prescribed forms of the praetor. 9. 10. Application to judicial organization 427. But there are some ceremonial acts, symbols, or signs by which people express and fix their ideas, when they give to these ideas the value of political and civil institutions, like the ordinary symbols of language with respect to ideas which are in no way official, or which do not touch upon the government and administration of the city. Words are impaired by circulation, meanings are misused, traces of etymology are lost, and language becomes perverted. In the same way, legal and juridical ceremonies, whether they consist in symbolic demonstrations, as is the case in the early periods of the Fief of Peoples, or in ceremonial words, or in written formulas, lose their primitive force and their original meaning little by little. They are weakened by use, fall into disuse, or are abolished when they become nothing more than awkward formalities. Therefore, once the Praetorian law was fully established, it was in the nature of things that in the course of time the delivery of the prescribed forms by the praetor became something analogous to what we call, in our modern fashion, letters of chancery, that is to say, a pure formality. Furthermore, the change in the political constitution, by leading to the abolition of the Praetorian jurisdiction, was bound to involve that of the system of procedure which is no less worthy of the most careful attention. Its full vigor corresponds to the time during which law among the Romans, already freed from its religious trappings, and no longer shackled by the prolix or incoherent laws of an absolute power, had attained its highest degree of perfection as scientific doctrine. 298. Using the accepted terminology, what the institutions of the Romans seem to have done, at a certain period in their history, was to distinguish questions of fact and questions of law, that is to say, actually, to distinguish judgment by means of conscientious evaluation, valid only in the particular case, and dialectic judgment, valid as a doctrinal decision. What their institutions did, we suggest, to introduce this distinction from the first stages of the proceedings, institutions of an entirely different sort have done among us, but in such a way that the determination of these two elements might be, on the contrary, the crowning achievement of the proceedings and might appear with clarity only in the highest judicial trials to which a civil suit can be submitted. When our kings, in the interest of their power, organized under the name of parliaments permanent courts of final appeal which called them 428 selves supreme courts, they came to fear the independent spirit of these bodies of legists, which had served them by throwing down feudalism. For the purpose of maintaining the supremacy of the royal power, the kings authorized litigants to enter before their privy council their appeal against judgments which might include infractions of the royal ordinances. When the ancient regime fell, new legislative authorities showed themselves to be no less jealous in maintaining the subordination of the judicial bodies. A Supreme Court was created whose principal function was to annul, on the request of the parties involved, all proceedings in which the forms had been violated, and any decision which involved an express contravention of the text of the law, but which was without power to deal with the issues involved in lawsuits, and on condition that decisions as to these issues would be returned to the ordinary courts, after the appeal of the proceedings or of the previously entered judgment. 11. In establishing, or rather in strengthening this great institution, the beginnings of which go back to the royalty of the Middle Ages, the founders of the new order of things did not have as their sole purpose the defense of the legislative power and of the text of the law against the slight inclinations to independence and opposition on the part of judicial bodies. In keeping with the spirit of the times, they were bound to propose to strengthen national unity more and more, and, in order to do this, to prevent through the regulatory action of a supreme tribunal, the diversities of jurisprudence which could not fail, in the long run, to alter seriously the uniformity of the law from one jurisdiction to another, in spite of the uniformity of the statutes and codes. but it is clear that this latter purpose would have been attained only indirectly and imperfectly by the institution of a court of appeal, if it were held to the letter of the law which, in order to attain an altogether different political object, that of preventing the courts from resisting the legislative power, confers on the court the right of review only in case of an express contravention of the text of the law. Either contraventions of this sort rest on a manifest and accidental error, which is not of such a nature as to perpetuate itself or to become a precedent, or they arise from the effect that the law does violence either to public opinion or at least to the opinion which prevails in the magistracy. Such errors are little to be feared in ordinary times and in the midst of a well-ordered society. In general, therefore, the diversity of jurisprudence, from one jurisdiction to another, can be established only in doubtful cases in which the text of the law may be differently interpreted or completed by persons who lack neither insight nor good faith, without giving rise either to an express contravention of the law or to an opening for an appeal, in the strict sense of the legal definition. In such a case, it should happen that the Supreme Court would reject the petition, no matter what decision has been reached by the courts to which the decision had been deferred. The highest court should always have the power to correct judicial errors, but it should not have a regulative power in the true sense of the term. Its intervention should place no obstacle in the way of differences of jurisprudence which gain strength and tend to disturb the uniformity of law, from one jurisdiction to another. In fact, the Court of Cassation has understood and accomplished its mission differently. This mission has been magnified in public opinion, to the degree that the highest court, declaring the law on doubtful points and clarifying obscure aspects of legislation, has made decisive, although reserved, use of this powerful jurisdiction, which the literal provisions of the constitutive law do not seem to have conferred upon it. Although there have been many more denials than appeals because a favorable prejudice is attached to the case that has been decided, and because we should more frequently encounter obstinacy among the litigants than errors among the judges, the number of cases in which the Court of Cassation has refused to settle doubtful questions, by rejecting the appeals for one reason or another, is surely very small as compared to those in which it has resolutely taken part. This is contrary to what should have happened if it had held rigorously to the legal definition of its functions, and if it were not in the nature of things that the logical principle or general idea, the rudiments of which are contained in a judicial institution, finally freed itself from the arbitrary restrictions of the original definition. 299. It has been admitted not only that the highest court checks express contraventions of the text of the law, but that it also regularizes the interpretation of it, by establishing principles. 430. And subordinating them to one another on the basis of their degree of abstraction and generality, by deducing their logical consequences, proceeding in these matters by way of analogy and similarity. In a word, the court participates in the systematization of the law just as the Roman praetor did in other times, although it does so by different means. Therefore, it was necessary to distinguish juridical error, subject to the censorship of the highest tribunal, from faulty decision, whether as to law or as to fact, which escapes this censure and which rests on points that the judges of the lowest court have power to decide without appeal. Now, here again we find that the radical distinction is not between fact and law any more than it is between matter and form. A question of form or of procedure may depend at one time upon a juridical interpretation, and at another time on the evaluation of proofs or upon the significance of a fact, just like a question concerning the matter of litigation. The law might have left to the conscience of the judge the evaluation of the right of the parties, as this is established on the basis of the averred facts or on the basis of precise clauses or authentic actions, as well as the interpretation of the intention of the acts, the will of the parties, and the evaluation of the means by which the proof of a fact or of an intention can be established. Or, on the contrary, the law might have defined and set forth the proof of a fact, the worth of a clause, the intention of an act, as well as the nature and the consequences of the law to which the fact, the agreement, or the contract furnishes an opening. Whether it is a question of law or of fact, of form, or of matter, there would be no violation of the law in the case in which the judge, given the authority to evaluate on the basis of his conscience, has made use of a necessarily discretionary and consequently sovereign power, after one has gone through all the degrees of ordinary jurisprudence. On the contrary, the law will be violated if the judge has evaluated the issue contrary to the legal definition of evidence, contracts, and facts which are defined and characterized by law, as much as if he had infringed upon a rule of procedure, or misunderstood the stipulations of the law as to rights properly so called. 12. But, on the other hand, the basis for for appeal does not require an explicit contravention of the text of the law, the establishment of which would really fall within the powers of a political bureau rather than within those of a court on which we wish to bring together so many luminaries. It follows that the appeal would have occurred not only if the judge had gone against the express terms of the legal definition, but even if he had gone against the logical consequences, whether these consequences are proximate or far removed, that can be derived from this definition or from a system of similar definitions by means of deduction and doctrinal discussion, independently of a conscientious evaluation of the particular circumstances of the suit. From this it follows, finally, that the principle which will guide the highest court in the determination of its competence, when this is controversial, presupposes the distinction between judgments delivered after conscientious and sovereign evaluation and those arrived at by the logical application of principles that the law proclaims. The judgments may be amended, if a better logical discussion demonstrates the falsity of the application. Whether we can or cannot clearly take account of this fundamental distinction, from the point of view of theory, whether it is or is not expressed in a general way, we believe that if the particular motives of each decision are zealously analyzed, it will be discovered that the feeling for the logical distinction on which we insist has constantly guided the highest court, always careful to leave to the judges the free exercise of their discretionary power wherever this is authorized by the law, and to circumscribe the exercise of it within the limits fixed by the law. If it happens that the Court of Cassation substitutes its evaluation for that of the judge, wherever the law has not stepped in with precise definitions, and has left the field open to conscientious evaluation, it is in exceptional matters in which there is reason to fear not the error of good faith, but the revolt of the judge against the authority of a law considered harsh, or which is contrary either to common law or to natural equity. This is also the case in the matter of the imposts, in which the interest of those who are liable to taxation usually is given more consideration than that given the treasury. Then the Supreme Court, in which doctrinal distinctions and general principles may not act to obliterate the political commission with which it is invested, enters into the evaluation of the matter, because this is the only way to maintain the authority of the law and to forestall its systematic evasion. But the exception itself proves the rule. In everything which touches upon the government of societies, there are some necessary impairments in the most firmly established maxims, the rigorous application of which on every occasion would be convenient only in those ideal republics created by philosophical imagination. But it is no less important to grasp in their intelligible purity the rules toward which the conduct of human affairs tends, and which it approximates more closely in proportion as societies have become more perfect as a result of the progress of time and of the general reason. 300. The question of introducing a jury in civil matters has often been raised in this country. If this innovation, that we are far from wishing to advocate and that seems repugnant to the secular traditions, were ever attempted, it seems to us to follow from all the preceding explanations that, in the organization of the procedure adapted for such an institution, the legislator should have in view primarily the distinction between dialectical judgment and the judgment through conscientious evaluation, whether of fact or of law. All questions which depend upon a conscientious evaluation should be given over to the decision of a jury, and the decision in all others should be confined to the sagacity of magistrates or permanent judges. This fixing of the prerogatives would certainly give greater clarity to judicial discussions. Perhaps this would expose it to more chances of error on the part of inexperienced judges, and in any case it would require an unusual care on the part of the legislator to regulate in advance, according to 434. Special functions, not the cases but the substance of disputes and, by way of general decision, the distinction of powers. At least, we should not wish to confer upon a magistrate of inferior rank a power comparable to that of the supreme magistrate, such as the Roman praetor, who not only could resolve points of law in his own way but could even circumscribe the competence of the juror or of the judge delegated by him. We cannot pursue these remarks further, and we shall terminate at this point a digression which perhaps is already too long, in order to return to questions of pure philosophical speculation. We have concluded what we wished to say about the functions of the understanding and their logical instruments. Now it is necessary to take up again the series of general considerations with which we began, and to submit to a new and rapid examination the system of our knowledge concerning the world in the midst of which man is placed, and concerning man himself. This should be done in such a way as to set forth throughout the system the distinction and the contrast of three elements: the historical element, the scientific element, and the philosophical element. This will be the object of the chapters which follow. Chapter XX. On the contrast between history and science, and on the philosophy of history. 301. When the genius of Bacon undertook to summarize in an encyclopedic table the classification of human knowledge and to point out its principal connections, he arranged them first under three great categories or rubrics: history, poesy, and science, corresponding to the three principal faculties of the human mind: memory, imagination, and reason. Later on we shall have to come back to this celebrated classification, which has been praised and criticized so much. We shall also have to consider the modifications that D'Alembert made in it in the essay put at the beginning of the 18th century French encyclopedia. We cite it here simply as evidence of the contrast of two elements, the one historic, and the other scientific or theoretical, which enter into the arrangement of the general system of our knowledge, and we attempt to grasp its nature and its distinctive traits with precision. Moreover, these two elements are not combined solely in the system of our knowledge. We shall come across them again, sometimes combined with each other and sometimes opposed to each other, when we leave literary or philosophical speculation to enter the field of practical application and the world of actual experience. When these two elements are looked at from the vantage point of our contemporary understanding of social institutions and of the conditions required for the life of peoples, we recognize that one part of these elements goes back to traditional influences and to the circumstances of their origin, that is, to facts to which history alone holds the key; another part goes back to the conditions bound up with the permanent nature of things, which constitute an object of study for reason independent of all historic precedent. This contrast is so striking with respect to everything which refers to the law and juridical institutions that it has led. 435. 436. Naturally to the formation and though antagonism of two schools of legal experts, the historical or traditional school and the school that, in opposition, is called rational or theoretical. A tendency of society to organize itself according to a systematic and regular plan, in conformity with theoretical conceptions, and a struggle against the obstacles that historical precedents put in the way of the realization of the systems and theories is most clearly evident in the revolutionary crises of modern times. Sometimes society is seen to be entirely freed from pig-headedness, sometimes inevitable reactions have given the ascendancy to the guardians of historic precedents and of the traditions of the past, and, finally, sometimes these have sought to come to terms with the new spirit, by upholding on the grounds of theory what could only have real force through the influence of historical precedents. The excesses of thought have consisted chiefly in a cult of intolerance, in an exclusive partiality for one or the other of the two elements which must be taken into account and to which a legitimate part of authority in the organization of societies will always come back. Besides, it is evident that, in proportion as less attention is paid to individual lives, absolutely or comparatively, as inequalities of all sorts are leveled, and as ideas and passions become generalized, the influence of historical precedents must lose its strength. At the same time, the course of events should tend to conform increasingly to a certain theoretical order that is no longer disturbed to the same extent by accidents arising from superiorities of classes, of talents, and of temper. But we must not understand by history only the account of political events, the description of the destinies of nations and of the revolutions of empires. The intervention of moral causes, the play of liberty and of human passions in the struggle with external necessity, which enflame the imagination of the historian, color his pictures, and give dramatic interest to his narrations, do not belong to the essence of history. The sciences, the arts, and literature also have their history. Great natural objects and phenomena of the physical order likewise admit in many cases of a chronology, of annals, and of historical narration. For example, one can write the history of a volcano just as one can write the history of a city. Therefore, let us try to find out what the essential characteristics. Contrast between history and science 437. Of the historical element are, without fearing the dryness of abstract conceptions, by trying to disentangle the fundamental idea from the accessories which complicate or embellish it. 302. Let us take the simplest illustration among purely mechanical phenomena, that of the movement of a billiard ball rolling on a table as a result of an impulse it has received. If we consider this ball at any instant while it is in motion, we need know no more than I(s) position, its present velocity, the nature of the frictional and the other resistances which act on it, to be able to assign its position and its velocity at either an earlier or a later time than the one we are considering, and, finally, to be able to predict the spot and the moment when these various resistant forces will have brought it again to a state of rest from which it cannot move, at least not until new forces act upon it. But if we start with one of the instants after the ball has come to rest, it is clear that neither its present state nor even the state of surrounding objects which gave it its original propulsion any longer offers traces of the phases through which it has passed while in a state of motion. However, it would still be possible to indicate the phases of rest and of motion through which it will pass in the future, from the knowledge of its present state, as much in the case of the billiard ball as in that of objects which, as a result of their present motion, may later strike against it and communicate a new impulse to it. In general, and without spending any more time on the conditions of this example, which may perhaps be too homely, we understand that the conditions of theoretical knowledge are not the same for past and for future events. This is due essentially to the fact that, among series of phenomena which are linked together because they are successively effects and causes of one another, some series come to an end and others are prolonged indefinitely, just as, in the sequence of human generations, some families die out and others perpetuate themselves. In order to avoid becoming involved immediately in scholastic disputes concerning what is called man's free will, let us limit ourselves to begin with to the consideration of natural phenomena in which, as everyone acknowledges, causes and effects are finked together according to a rigorous necessity. In this case it will certainly be true to say that the present is large with the future. 438. And with the whole future, in the SQNSE that all subsequent periods are implicitly determined by the present one in accordance with the action of permanent laws or external decrees to which nature is obedient. Yet, we shall not be able to say without qualification that the present is similarly large with the past, for there have been periods in the past of which no traces remain at the present time and which not even the most penetrating intelligence could recover on the basis of theoretical knowledge of permanent laws and the observation of the present state of affairs. On the other hand, that would be sufficient to enable an intelligence provided with faculties analogous to, although more powerful, than those of man, to discover in the present state of things the sequential order of all future phenomena, or at least to take in a larger part of this order in proportion to the greater perfection of its faculties. Thus, however bizarre the assertion may appear at first glance, reason is better adapted to know the future scientifically than the past. The obstacles to theoretical prediction stem from the present imperfection of our knowledge and of our scientific instruments, and may be surmounted as a consequence of progress in observations and theory. Lost in the past are a multitude of facts whose nature is essentially hidden from any theoretical investigation based upon the verification of present facts and on the understanding of permanent laws, and which therefore can only be known historically, or which, for want of historical tradition, are and will always be for us as if they had never happened. 1. Now, if theoretical knowledge is capable of indefinite progress, the references of historic tradition, relative to the past, necessarily have a limit that all the researches of antiquarians will not be able to push back. Here we have a contrast of prime importance between theoretical knowledge and historical knowledge, or, if this way of putting the matter is to be preferred, between the theoretical and the historical element in our knowledge. 303. Astronomical tables enable us to predict eclipses, the conjunction and opposition of the planets, and all the circumstances of the movements of the stars which compose our planetary system for periods very far removed from our own times. As these tables become more perfect, we shall be able to penetrate further into the future and to make the calculation of future phenomena more precise. In this matter we may do the same thing with respect to the past that we can with the future. Once these tables have been perfected as much as possible, we shall no longer have to borrow anything from historical knowledge in dealing with phenomena of this sort. On the contrary, we shall be able to apply and, in fact, we already apply science to history, by using it, for example, in calculating the time of an eclipse which occurred in the distant past in order to fix the precise date of an event that historians tell us was contemporaneous with that eclipse. But if we wish to deal with an astronomical phenomenon like the appearance of the star of 1572, which suddenly disappeared without leaving any trace, it is quite necessary that history come to our aid. The most highly perfected theory, even when it can explain to us the causes of such a phenomenon as this, and even when it enables us to say which among the stars now shining are doomed to such a fate and when these events will occur, could not make known to us, without historical evidence, the existence of stars which attained great brilliance in the past but are now extinct and forever excluded from our view. Perhaps some day we shall have a sufficiently clear understanding of the constitution of the earth and of the theory of the forces which move it to assign in advance the date and the phases of such geological phenomena as a volcanic eruption, an earthquake, or a great melting of polar ice, just as we can predict now the date and the phases of an eclipse. Yet this theoretical knowledge, no matter how perfect we may assume it to be, unless it is accompanied by historical evidences, will always leave us insuperably ignorant as to a great many geological phenomena which have left no traces, or which have only left traces which are insufficient to reveal all the essential particulars about the upheavals which the earth has experienced. 304. It is not within the power of an intelligence such as ours, or of any finite intelligence, to embrace in a single system the phenomena and the laws of the whole of nature. But even though we were able to do this, we should still distinguish in this whole the parts which are detached from one another and which are the object of theories that are independent of one another, although 440. They may be connected with a common origin. Here we find another cause of the insufficiency of theoretical knowledge, and another part necessarily reserved for the historical element of knowledge. For example, the planetary system, including the comets whose periodic return has been proved, is the subject matter of such a perfected theory that we are able, as we said above, to calculate all the actions that the bodies composing it exert on one another, and to do this in such a way as to predict the future and to go back into the past without the assistance of historical documents. But suppose that in the distant past a comet traversed the system and appreciably disturbed the motions of the bodies which compose the system, and let us further suppose that it then vanished into celestial space, or that, if it did not vanish, it passed forever from our view and beyond any influence on the planetary system in describing a hyperbolic curve. Neither theory nor observation of the present state of the planetary system could tell when and how such a disturbance took place, nor could they lead us to suspect the interference of this disturbing cause. Finally, all calculations that we may make with respect to periods prior to that in which the disturbing cause occurred will, without our being aware of it, inevitably be tainted with error, in the absence of historical information about the disturbing event. Similarly, the accuracy of the applications that we may make of the theory to future phenomena will rest upon the hypothesis that no unforeseen event of the sort we have indicated will occur to disturb the condition of the system. Indeed, if we were to know perfectly the present state of the whole universe, and not only that of the bodies which make up our planetary system, we should be in a position to predict theoretically a similar occasion or to affirm that one has not occurred. But over and above the fact that it would be chimerical to pretend to a universal knowledge, grounds would still remain for considering the planetary system as forming a separate system in the universe, a system having its own theory, and events whose sequence is determined by the laws and by the particular organization of the system should not be confused with accidental and adventitious disturbances whose causes lie outside of the system. These are those irregular and fortuitous external influences which must be regarded as becoming a part of knowledge under the heading of historical data, in contrast with that which is for us the regular result of the permanent laws and of the nature of the system. It must be well understood that the contrast we are pointing out here clearly depends less upon the nature of the faculties by means of which we acquire historical and scientific knowledge, than it does on the very nature of the objects of knowledge. The external, irregular, and fortuitous influences of which we have been speaking would preserve no less of this triple character, even though we had some way to foresee them and to calculate their effects a priori, without the help of observation and of historical testimony. And while maintaining this triple character, these influences could not, at the same time, be considered as forming the subject matter of a science properly so called, that is to say, a body of systematic and exact doctrine. 305. In fact, we have a mass of knowledge, coming from different sources, to which we do not and should not give the name of science. The processes involved in metallurgy and in many other industries to which the discoveries of modern chemistry have given the secret were already well advanced long before chemistry deserved to be called a science. Meteorology is barely beginning to take on a scientific stability, but for many centuries country folk have had their meteorological predictions and proverbs that scholars can no longer despise even when they can explain them. Science is only one form of learning or of knowledge, and it appears only as the belated fruit of an advancing civilization, after poetry, after the arts, after historical, moral, and philosophical compositions. It is contemporaneous with erudition, but erudition must not be confused with science, although the world often honors scholars and scientists with the same name and treats them more or less as though they were on the same footing. When a person masters the exact topography of Athens at the time of Pericles or has untangled the genealogy of a Median dynasty, we should have more reason to esteem him than we should if his knowledge were about the plan of a modern capital or the alliances of a ruling house, for the one is more difficult than the other and presupposes a rarer conjunction of previous knowledge. Nevertheless, it is not because items of knowledge are more difficult to acquire or because they relate to distant objects or to ancient events that they must be regarded as being essentially different from analogous bits of. 442. Knowledge about contemporary events or objects which are close to us. One may have been able to collect in one's memory a great number of historical facts, to gather a mass of notions about the mores and the customs of the peoples visited in one's travels, to become familiar with the vocabularies and the idioms of a great number of languages. In this way one will acquire great learning, one will know much, without taking a place among those who cultivate the sciences, although a great many of the facts gathered may be capable of serving as materials in the construction of a scientific system. In the study of a language or of an art, such as music, we distinguish very clearly between that which serves as the object of a scientific theory and that which does not admit of scientific exposition, although it may still be an object of study, of learning, or of knowledge. 306. It was an accepted maxim among ancient philosophers that there is no science of the individual, the particular, the contingent, or the variable, that the idea of science refers to the idea of knowledge in so far as it applies to general notions, to necessary conceptions, and to permanent results. But in the present state of the sciences, we can no longer be content with these commonplace views. It is necessary to examine thoroughly and to make sure by means of examples how, under what circumstances, and by means of what conditions those bodies of doctrine which truly deserve the name of science take shape and become organized. And, to begin with, is it true that science has only immutable truths and permanent results in view? By no means. There are sciences, like geology and embryology, which, on the contrary, rest essentially upon a succession of variable states and transitory phases. And even when we consider natural objects in what we call a stable and permanent condition, everything leads us to believe that this is still only a matter of relative stability, and that we regard as permanent what changes only very slowly and in such a way as to offer appreciable variations only over periods of time which exceed those that we are able to comprehend. Thus the stars which we call fixed really have proper motions which alter their reciprocal distances and the configuration of the groups that they appear to us to form on the celestial sphere. Yet these motions, which are inquired into only on the basis of scrupulously questioned observations which are performed with instruments of extreme delicacy, have not altered the appearance of the sky noticeably since the most remote historical times. The same thing is probably true of phenomena of every sort. The specific types of wild and untamed nature, whose variability from the beginning of historical times up to the present era has not been established, may well be subject to slow modifications. These modifications should be no more prejudicial to the dignity of the natural sciences than i.e. slow perturbations of the planetary system or the still slower displacements of the stellar systems are to the scientific perfection of astronomy. The rapid changes that time brings about among the facts which fall within the scope of social order, by making more difficult the study of the economic sciences, as far as those aspects of them which are positive and determinable are concerned, do not strip from them the character of sciences. In a word, nothing requires that the objects of a scientific theory should be fixed and invariable and suited to all times and places. 307. Although we may not conceive of scientific organization without rules, principles, and classifications, and, consequently, without a certain generalization of facts and ideas, it is no longer necessary to accept to the letter the aphorism of the ancients to the effect that the individual and the particular have no place in science. Nothing is more unequal than the degree of generality of the facts upon which rest the sciences which in other respects are equally susceptible of the order and classification which constitute scientific perfection. In zoology and botany, specific types are dealt with which include myriads of individuals, all different from one another, and in which science is not interested. From the point of view of chemistry, each element or definite compound is a particular and individual object, absolutely identical in all particles of the same stuff, whether element or compound. Nature might have fashioned only a single instance of a crystal of a certain sort, and yet it would have its place among mineralogical types as genuinely as the species having the greatest number of individuals. In astronomy, the celestial bodies are considered as so many individual objects. Some, like the rings of Saturn, up to the present time appear to be the unique example of their type. It was possible to regard our moon as such an object until the discovery of the moons of Jupiter, and the profoundest inquiry into celestial. 444. Mechanics rests upon nothing but the motions of a system limited to only a small number of bodies. Finally, geology is simply the careful study of the form and structure of one of those bodies of which astronomy describes the movements and summarily outlines the principal characteristics. This is not to say that zoology or botany are superior to chemistry or physics, astronomy or geology, so far as dignity and scientific perfection are concerned. Yet it cannot be denied that, in any order of empirical knowledge whatever, the scientific form can be outlined only after a sufficiently large number of facts have been collected so that some generality and guiding principle may emerge from their comparison. Even the deviations of ordinary rules, when they are compared with one another, manifest a tendency to take place according to certain laws. This is how the appearance of organic monstrosities, which were for so long simply a cause of superstitious terror among the ignorant and then an object of curiosity for the learned, have in the end given rise to a scientific theory which, under the name of teratology, today takes its place within the bounds of the natural sciences. 308. Science is knowledge logically organized. Logical organization or systematization may be summed up under two principal heads. First, the division of the subject matter and the classification of whatever objects scientific knowledge rests upon. Second, the logical connection of propositions which reduce as much as possible the number of axioms, fundamental hypotheses, or experiential data, and from which everything has been deduced that may be deduced by reasoning, except to check the reasoning by means of confirming experiments. It follows from this that the scientific form will be more perfect in proportion as it establishes clearer divisions, more decisive classifications, and more clearly marked degrees in the sequence of relations. It also follows from this that to increase our knowledge and to perfect our science are not the same thing. Science is perfected by the conception of an apt idea which introduces a better order in acquired knowledge without increasing the amount of it, while a science which is enriched by the addition of new observations and new facts which are incompatible with previously adopted principles of systematic arrangement and classification will lose with respect to perfection of scientific form. Ordinarily this retrogression is only fleeting, it is the first symptom. Contrast between history and science 445. Of a scientific crisis or revolution, and just as the perfecting of form provokes new researches and an increase of what may be called scientific materials, increasing the materials in this way gives rise to new relationships which suggest other principles of systematic arrangement and classification. When experience reveals new facts which are in contradiction to one of the fundamental hypotheses, we are led to set up other hypotheses which are in agreement with already known facts and are sometimes more simple than those which have been given up. Nevertheless, in order to be justified in affirming that progress in discoveries will ultimately in every case introduce the perfection of scientific form or the perfection of the logical organization of knowledge, it would be necessary to be able to affirm that the conditions of the artificial development of our intelligence are in perfect harmony with those of the ordering of the universe. This is an assumption which many philosophers will not hesitate to permit themselves, but which will always appear reckless to a circumspect thinker. Even more temerity would be shown in such an assertion as this, that, when dealing with questions relating to abstract and rational sciences which, like mathematics, human intelligence seems to draw from its own depths, we notice that the arrangement which satisfies best the conditions of logical order, which makes the divisions clearer and more symmetrical, the demonstrations more rapid or more rigorous, is not always the one which furnishes the best reasons for the discovered truths, for their consanguinity and their connections. 309. There are sciences, like the abstract sciences, whose subject matter has nothing in common with the chronological order of events, and which, having no historical data to accept, have nothing to borrow from history. The theorems of geometry, the rules of the syllogism, hold for all times and for all places. It is clear that no historical element enters into them. Yet, in other respects, these sciences as well as others may have, in so far as they are products of human activity, their own history, which serves to account for their nomenclature and for their external forms. Many of the sciences which deal with natural phenomena have dispensed with the necessary support of a historical basis or idea in their theoretical construction. Chemistry and physics properly so called, which deal with laws that we regard as immutable and with 446 properties that we assume have always been inherent in matter, are in this group. As a result, in these respects there is no reason to seek the explanation of the details which the present order of things offers us by taking account of the way phenomena which precede them have succeeded and been connected with one another. Using some examples to explain what we mean, in chemistry the values of the chemical equivalents of each of the elementary substances must be obtained by observation. Once we have these values, we can deduce the values of the chemical equivalents of compound bodies from them theoretically. In so far as the theory is unable to give us, in a manner which satisfies everyone, the key to the relations which exist among the chemical equivalents of the various bodies which are regarded as elements, it will be necessary to accept the table of numbers which measure these equivalents as a fact and an empirical datum. But in doing this we do not give up the idea that the relations between these numbers must have a theoretical explanation, which might have been discovered were this nature better known to us, and for which it would not be necessary to know through what phases the parts of the matter on which we have based our experiments have previously passed, For the same explanation must hold for the other chemically identical although individually distinct bits of matter whose histories are entirely different, or which have passed through entirely different phases. In the same way, each different ray of the solar spectrum has its own index Oj refraction for each refracting material, and, in the present state of theoretical knowledge, experiment alone is able to furnish us with the numerical values of these indices. We nonetheless admit that the causes of unequal refraction rest in the permanent conditions of the constitution of luminous rays. Thus a more penetrating theory would give the reason for these indices in such a way as to make it unnecessary to connect the historical knowledge of the phases through which the world has passed with the theoretical knowledge of the nature of light and of material bodies. The same thing may be said with regard to a great many constants or numerical coefficients or, even more generally, in regard to a multitude of facts which are taken as experimental data in the sciences as they are constituted today, yet no one would think of confusing these facts with historical data, for which only the history of past events, and not the theory of permanent facts, would replace the observation of actual phenomena. 310. On the contrary, in a great many other cases, the data that science accepts and on which it necessarily depends have and can only have a historical proof. For example, celestial mechanics gives us the theory of perturbations in the planetary system and shows us the stability of this system by assigning limits, in one way and another, to the very slow and very small oscillations that the elements of the orbits undergo. But it does not tell us what causes have established certain relations of distance and mass among the members of the system, so that once the order is established it tends to endure. The physical reason and the immediate cause of this very remarkable fact, the most striking of the indications of a directing intelligence, is certainly found in the series of phases the world has passed through before reaching that final and stable order whose majestic simplicity we admire. Theory explains the causes of the tides and of their periodic and regular inequalities to us on the basis of the paths of the moon and the sun. With the help of certain empirical data, it enables us to assign in advance for each point on the coasts the hour and the approximate height of the tides for each day of the year and for many years to come. On the basis of the way in which the water is distributed in the oceans, their average depth and their total volume, theory also teaches us that the permanence of the equilibrium of the seas is guaranteed in the present order of things, so that the oscillations that the attraction of the heavenly bodies produce in them cannot go so far as to bring about the submersion of the continents. But what causes have determined, and have done so in such a way as to satisfy this condition, the average depth and the irregularities of the ocean basins, the volume of water which replenishes them, and that empirical constant, characteristic of each locality that is called in the theory of tides the maximum tide for the port. In the present state of things, this theory accepts these facts, as so many observational data. There are no branches of the natural sciences which do not offer examples of analogous contrasts. 448. In the study of languages, grammatical structure is the subject matter of a truly scientific theory. With the exception of certain irregularities which must be laid to caprices of the ear or of usage, reasoning and analogy account for syntactical laws and forms. On the other hand, the material composition of words and the lineage of languages can be explained in general only by historical precedents, with regard to some of which we actually possess historical information, while others are lost in the darkness which surrounds the origin of races and peoples. 2. When we lack this historical information, these are for us so many facts, established by observation, that theory accepts and on which grammatical science rests. The same thing can be said about the system of measurements that peoples and generations hand down sometimes after they have undergone slow and progressive alterations introduced by usage, at other times after sudden reforms due to the intervention of public authority. Among all civilized nations, the different customary systems of measurement have presented some sort of systematic coordination which is explained by the suitability of the notation and by other theoretical considerations. But the system of arrangement and of subordination among the parts always leaves the choice of certain fundamental standards an arbitrary matter. The reason for the diversity of these standards among different peoples lies entirely in historical antecedents whose trace is never completely effaced. For example, take the case of the metric system that the French legislators have constructed with the announced intention of offering to all peoples a system the elements of which all have a basis in science, and which would not bear the imprint of any particular nationality. It is not difficult to recognize the influence of a national tradition which, in the series of multiple or submultiple decimals of physical magnitudes, has led to a preference for those which approximate the standards used in an earlier system, in order to arrange, for the people upon whom authority has imposed it, the transition from one system to the other. So, too, the modern map of our departments, which was drawn up with the intention of abolishing the influence of habits bomb from historical precedents, presents a multitude of peculiarities which only the ancient provincial map can explain. Similar remarks could be made about everything connected with the economic sciences and with the organization of societies, and finally to disappear, so that a tangible influence is left only to the permanent conditions found in the intrinsic nature of the object to which science or theoretical knowledge is applied. Otherwise, since the individual and accidental particulars act in different ways, it is necessary that their effects compensate each other and cancel each other out and thus tend toward the average and general results which then become the only objects with which science is concerned. But it is far from necessary that the conditions be always satisfied. The shock accidentally communicated to some parts of the mass of a large object does not shake the entire mass, and all the effects are limited to brief, internal vibrations from parts adjacent to those which received the shock. Contrariwise, in the case of fermentation, having the process begin at one point in the mass is sufficient to have it spread throughout the whole mass, the molecular composition of which will undergo a complete change. In the case of certain historical causes, time, far from weakening their influence, extends and strengthens their effects. The European calendar, which is now in use throughout the world, is full of irregularities and anomalies that a scientific editing would have eliminated, and for whose explanation it would be necessary to go back to the obscurest beginnings of a little town in Latium. But fate decreed that the calendar of the priests of the city should become that of the peoples of southern and central Europe, which later became part of its empire. Fate also decreed that religious beliefs altogether contrary to those which directed the original redaction were afterwards adopted by other 450 European nations that Rome, in the days of its ascendancy, had not been able to vanquish. Finally, the development of European civilization was destined to carry this calendar to the ends of the earth. It is clear that the longer the institution has lasted and spread, the greater the reason why it should last still longer and spread still more, and even that, all the initial causes having disappeared, the reasons for its existence can now no longer be deduced except from its earlier existence and duration. So it is that, in some way, an individual variety, resulting originally from the fortuitous interaction of external causes, has become stronger in being transmitted from one generation to another, becoming a racial characteristic, or perhaps even acquiring the value of a specific characteristic, and perpetuating itself independently of the influence of external causes, or even because of a force of its own which resists the action of external causes. 312. After all that has been said, we can believe that the distinction between history and science is even more essential than it seemed to Bacon, and that it is not exactly due to the presence in the human mind of two faculties, one of which is called memory and the other reason. Men would never have made use of their memory and their reason in order to write history and treatises on the sciences if, in the evolution of phenomena, one part were not composed of permanent and regular laws, susceptible to systematic coordination, while another part is left to the influence of anterior facts, products of chance or of accidental combinations among different series of independent causes. The notion of chance, as we have tried to show elsewhere, has its basis in nature and is not relative solely to the weakness of the human mind. The same thing must be said of the distinction between historical data and theoretical data. A mind which could penetrate further than ours into the series of phases through which the planetary system has passed would recognize, as we do, facts which are primordial, arbitrary, and contingent, and which it would be necessary to accept as historical data, that asterisk is to say as the consequence of the accidental concourse of causes which had acted in still more distant times. To presuppose that this distinction is not essential is to admit that time is an illusion, or is to set up an contrast between history and science. 451. Order of realities in the midst of which time would disappear. But our philosophy undertakes no such bold flight. We are trying to remain within the sphere of ideas that the reason of man can attain, while at the same time conserving the capacity to distinguish that which pertains to the particular characteristics of the human mind and that which pertains to the nature of things rather than to the way our faculties are organized. 313. What makes the essential distinction between history and science is that the former includes the succession of events in time, while the latter is concerned with the systematizing of phenomena without reference to the time when they occur. The description of a phenomenon, all the phases of which follow one another and are interconnected necessarily according to laws that are made known through reasoning or experience, falls within the domain of science and not of history. Science describes the succession of the eclipses, the propagation of a sound wave, the course of a disease which passes through regular phases, and the name of history can only improperly be applied to such descriptions. On the other hand, history necessarily enters into the picture where we see not only that, in its present imperfect form, theoretical knowledge is insufficient to explain phenomena, but that even the most perfect theory would still require the collaboration of a historical datum. If there is, properly speaking, no history where all events necessarily and regularly derive from one another, because of constant laws which govern the system, and without the accidental concurrence of influences which are extraneous to the system encompassed by theoretical knowledge, then a series of events which are not connected in any way has no history in the true sense of the term. Thus the records of a public lottery would show a succession of singular drawings. This may sometimes pique the curiosity, but it would not constitute a history. The drawings would follow one another without being linked together, with the first exercising no influence on those which come later. The situation here is analogous to those annals in which the priests of antiquity sought to record monstrosities, arid prodigies, as these were brought to their attention. All these marvelous events, which had no connection with one another, cannot form a history in the true sense of the 452 term, even though they may follow one another according to a certain chronological order. On the contrary, the conditions of a historical connection begin to come out in a game such as backgammon. Here each throw of the dice, although brought about by fortuitous circumstances, nevertheless has an influence on the results of the subsequent throws. The requirements of historical connection show themselves still more in the game of chess, in which the reflective determination of the player is substituted for the chance of the dice, yet in such a way that the ideas of the player give rise to a multitude of accidental encounters when crossing those of his opponent. The account of a game of backgammon or of chess, if we should decide to pass the record of it along to posterity, would be a history just like any other, having its crises and its denouements. This is so because the moves not only follow one another, but they are also linked together in the sense that each move has more or less influence on the series of subsequent moves and is influenced by the preceding moves. Should the game become still more complicated, the history of a part of it would become philosophically comparable to that of a battle or campaign, except for the importance of the results. It might even be possible to say without whimsy that there have been many battles and many campaigns whose history no more deserves to be remembered today than does that of a game of chess. 314. Historical connection consists, therefore, in an influence exercised by each event upon other events, an influence which may be more or less extended, but which at least should make itself felt in the neighborhood of the event under consideration, and which, in general, is proportionately greater when it acts more directly on events closer at hand. The characteristic of such a connection is to introduce a certain continuity into the succession of acts comparable to that of which the path of a curve would give us the image in the graphic representation of certain phenomena, or, better still, like that which represents for us the outline of the course of a river on a map. In spite of the disorder and confusion of fortuitous and secondary causes with respect to accidents of detail, and without any theory, This sort of connection is all we need to enable us to grasp the general drift of events, to distinguish periods of growth and decline, of progress, of arrest, and of decadence, and periods of formation and dissolution, among nations and social institutions, as for beings to which nature has given a characteristic and individual form of life. The task of the historian who seeks to raise himself above the role of the simple analyst consists in placing in a suitable light, of indicating without indecision as without exaggeration, these dominant and characteristic traits. JDE must do this without being misled by the role of secondary causes, even when fortuitous circumstances give them an air of grandeur and brilliancy before which the slower and more hidden action of the basic causes seems to fade away. It necessarily follows, and this is quite difficult for other reasons, that the historian takes account of the mutual influence, of the reciprocal penetration of the different series of events, each of which has its own principles, ends, laws of development, and, so to speak, its open account in the book of destiny. The historian must unravel, in the very complex woof of historical events, all those threads which are subject to any interlacing and meandering. 315. But does not this historic connection itself indicate how history treated in this manner differs from a scientific theory? Let us assume that we are asked to mark by a line on a geographic map the direction of a great watercourse or of a chain of mountains, and that we wish to speak of that general direction which prevails over local and accidental irregularities and meanderings. We contend that there is a great similarity between this problem and those that the philosophical historian proposes to himself. In fact, everyone knows that in order to have a correct idea of the relief of a mountainous country, it must be studied from a point of view which wipes out the innumerable irregularities and the bizarre convolutions that have accumulated as a result of local accidents, in such a way that at first they present to the eyes of the astonished traveler nothing but an inextricable labyrinth. From a higher or more distant point, from which one's view takes in a still greater number of objects at one time, we see outlined those great alignments which are unimpeachable evidence of a dominant principle of regularity and of an order in the disorder. If these lines of inclination, as we now call them, meet one another, it is necessary to look, on the one hand, for an increase of intricacy and of the disorder among the details toward the points where the 454 junction occurs. On the other hand, and when considering the whole situation, an increased amount of upthrusting is to be expected. The latter is the result of the interaction of the two systems of causes, the average and the general effects of which have had a common tendency in this direction. In order to give a good description of a mountainous country, it will be necessary to indicate as clearly as possible and, more particularly, as accurately as possible the great features to which all irregularities of detail are subordinated. These irregularities need not deceive us. We need not be mistaken as to the exact location of the point at which the greatest upthrust occurred simply because local accidents may have produced in some other part of the chain, where its average height has become appreciably less, a peak which is higher than even the loftiest summits of the section where the upthrust reached its highest point. It remains to be seen whether or not all these orographic problems are among those which may be mathematically defined and which lead to a technical and exact solution. Now, this is not the case, and all the mathematical formulas which it might be pleasant to devise for this purpose would have the radical defect of being arbitrary. This is so because they would apply equally well to the case in which the fact of a constant and general direction is most striking, and to those cases in which there are many well-marked successive deviations in the general direction, and, finally, to those cases in which the irregularity and amplitude of continual convolutions exclude any idea of a general and dominant direction. Moreover, since the transition from one case to the other must be made through continuous nuances and gradations, logic is clearly unable to distinguish the extreme cases. This distinction can result only from an instinctive evaluation which becomes progressively less clear and less sure in proportion as the extreme terms of the series fall farther apart from each other. Even when the fact of a general direction is beyond question, the ideal line which indicates this direction is not a scientifically defined line. Any bearing of the chain is not an angle which can be assigned within any desired limits of approximation, or the determination of which is affected only by errors inherent in every operation of measurement. If we actually want to draw the line on a map or to mark down somewhere the numerical value of the bearing, the choice of the line or of the reading will involve something arbitrary, or something of which we cannot give an exact account. The same thing must be said of points at which mountain chains and masses, which also are called orographical systems, begin and disappear. In most cases, we cannot find among them such clear-cut breaks in continuity as would rigorously preclude connecting them with one another through some of their ramifications, and to do this in such a way as to abolish ultimately the most natural distinctions. At other times, on the contrary, notable material gaps, such as those which may be the result of the interposition of an arm of the sea, must be rejected as local accidents and should not lead us to fail to recognize the systematic unity of the disconnected parts. In the appraisal of the intrinsic value of all these systematic bonds and in the very conception of systematic unity, therefore, judgments occur throughout the process in which reason does not proceed by way of definition and logical deduction, and the probability of which does not lend itself to an accurate evaluation. Systematizing conceptions of this sort are introduced into the description of natural facts not only for the convenience of the mind, but also to give the key to a sound understanding of the facts in themselves. They must not be confused with truly scientific theories, and still less with the positive aspect of the sciences, which is amenable to the continual control of experiment. On the contrary, they have all the characteristics of philosophical speculation, characteristics on which we have insisted unceasingly throughout this work, and to which we must return in the following chapter, which is devoted to indicating the contrast between philosophy and what is properly called science. 316. Is it not clear by now that all these reflections apply, mutatis mutandis, to history when it is handled philosophically, to the picture of historical events when we intend to bring their dominant traits into relief and to forestall the confusion of their details by distinguishing the massive structures and the subdivision of the principal groups? Can this art of penetrating into the deep-seated reason of facts, of discerning their disposition, of laying hold of their guiding threads be reduced to fixed rules? Does it lead to categorical distinctions? Does it throw light equally in all directions? No, there is no doubt that it does not. All the systematic conceptions on which history is based, when dealt with 456 philosophically, may be more or less disputed, and none lead to what may properly be called demonstration or to positive and experimental verification. Yet no enlightened and impartial mind would hesitate to accept these conceptions as giving to the essential reason of things and to the progressive development of events an expression which is as faithful, as completely free from partiality and arbitrariness and as completely separated from fortuitous accidents as the imperfect means, of which our art makes use in such complex matters, permit. Actually, in portraying his thought, the historian, unlike the geographer, does not have access to graphic and perceptible symbols. He is like the traveler who does not have the advantage of a plan and who must make up for this deficiency by the strength of his memory and imagination and the picturesqueness of his style. Finally, like the philosopher, he is faced continuously with the necessity of using metaphorical language, in spite of the fact that he never ceases to recognize its inadequacy. Thus historical composition is closer to art than to science, even when the historian is clearly less concerned about pleasing and exciting by making his accounts interesting than he is about satisfying the desire of our understanding to know and to comprehend. The historian, like the philosopher, or rather indeed because he is or may be a philosopher, needs those gifts of imagination that we very rightly suspect in the case of purely scientific work, just as does the philosophical painter of nature. According to the trenchant expression of one of the masters of critical literature, one may say in this sense that he needs to be a poet, not simply in order to be eloquent, but in order to be truthful. 3. So it is that history, whose connections with science and philosophy we have been examining, has connections with poetry and art, too, and in this way the three members of Bacon's tripartite division tend to unite, yet without losing their identities. Moreover, if the historian is an artist, and up to a certain point, a poet, in so far as he has to perceive discerningly a specific character, and the work of carefully perceiving and reproducing a specific character is always the business of art, not of science, it is clear that his composition will have to share the characteristics of poetic composition to a much higher degree when the dramatic interest of the account, the importance of the actions, the strong unity of the subject matter will, in spite of all he can do, place it, so to speak, on the poet's tripod. Thus Voltaire has said, an exposition, a plot, and a denouement are as necessary in a history as in a tragedy, for a maxim that must not be generalized too much, since, among things which have no necessary end, and which, like the sciences and civilization, on the contrary, lead to a process of continuous perfecting, it is possible to have a strong historical unity without plot or denouement. But at least it is possible to say that historical composition, which is susceptible to as many varieties of kinds as there are different temperaments and proportions among the principal faculties of the human mind, is singularly suited to bring their harmonies and contrasts into relief. 317. On its poetic side, history always has the privilege of exciting interest, however slight may be the importance of the events related, and what science would neglect as too particular and too individual is often what is best adapted to art. Moreover, events which have left behind them no trace may still interest the philosopher, if they are applicable to some general maxim of morals or politics that cannot be too strongly impressed on the mind and justified through examples. But in the general system of human knowledge, and considered as a necessary adjunct to scientific knowledge, it seems that history should appear only in so far as it tells of things which are necessary or useful in the explanation of phenomena and of present facts, and those which should happen later. Everything which has disappeared without leaving any traces and without having any influence on the order of actually existing things has no basis, so to speak, on which it can be known, and becomes part of the realm of vague curiosity, that nothing limits or determines. History will make note of the violent overflowing of a river which has filled up its old channels and cut out a new bed in which it continues to flow, but it will ignore the description of the annual and periodic floods after which the river returns to its usual course. If the permanent effect of these annual floods is the progressive building up of alluvial soil, history will point out the general result without going into the detailed enumeration of phases which all resemble one another, and whose differences offer no particular feature worthy of interest, since all these differences must compensate for each other in the long run. 5. Thanks to the improvement of which scientific form is capable, the field of the sciences may spread further and further without the human mind ceasing to include and master it. Conditions of another sort must limit the indefinite accumulation of historical materials, without this all proportion would be lost. It has not seemed fit to define and circumscribe the object of historical researches and traditions more than this, when the force of circumstances makes plain the need of a rule in these matters. 318. It often happens that contemporary historians usurp the name of science for history just as philosophers usurp it for philosophy. This is one of the abuses of modern style and one of the consequences of the illumination the sciences have shed and of the popularity they have acquired. The most serious inconvenience of this confusion is that of suggesting pretended scientific formulas, by means of which the fatalistic historian admirably explains the whole past, but to which he would not care to entrust himself in the prediction of the future. In that respect he is like the authors of those epic stories in which a divine personage reveals in the person of a hero the destiny of his race, provided, of course, that his clairvoyance ceases precisely at the time of which the poet has sung. We have no difficulty in understanding that we can reduce to scientific form certain branches of knowledge which relate to the details of the organization of human societies, for, with observations which have been accumulated by the use of statistics, we succeed in establishing positively permanent laws and relations whose variability itself argues a regular progression of sustained influences. But the same thing may not be said for political history. This is so because in the migration of races, in invasions and conquests, in great revolutions of empires, and in changes of mores and beliefs, there are accidental facts and entirely individual forces, which are of such a nature as to exert a perceptible influence over all succeeding ages, or for which periods of time beyond our grasp would be required if their influence were to be blotted out. And, on the other hand, political history is a theater in which the acts of fortune, however frequent and surprising they may be, are not repeated often enough or are repeated in circumstances too dissimilar for us to be able with certainty, or with a sufficient probability, to disentangle the disturbances of chance from constant and regular laws. Thus, a history may very well have its philosophy, but not its scientific formulation. It may have its philosophy, for philosophical discernment distinguishes causes of different natures, some permanent and others accidental, and it recognizes their tendency to be subordinated to one another, without always being able to give demonstrative evidence for its insights. And while, in regard to things which fall within the field of statistics, it is possible to run back over the series of proofs and thus to confirm the truth of the results already brought to light by earlier observations in such a way as to reach scientific certainty, it would be contrary to the way in which successive historical phases follow one another if they were to lend themselves to this confirmative experience. Consequently, however well the past may be or may appear to be explained, it can never give us more than a singularly indecisive glimmer of the future, not only with respect to accidents of detail but also with respect to general results, that may always be modified and completely changed by unforeseen accidents, like those which have modified the series of antecedent events, taken as a whole. Yet, if pragmatic history can never become a science, it is perfectly plain that in certain fields of knowledge we find the scientific form connected with the foundation of historical researches. Numismatics, for example, assumes the forms of a science, has its rules, principles, and classifications, although its basis is drawn from history, and although it is of very little use except as it serves to clarify history. Thus one might experience some difficulty in putting it in its proper place in an encyclopedic system, and come to different conclusions, depending upon whether we attach more 460 importance to form or to matter. But that merely proves the insufficiency of our artificial classifications and does not in the least affect the basis of things. 319. We must dwell further on these two expressions, natural history and natural sciences, the simultaneous use of which seems to be traceable to an essential distinction which it is important to clear up. In fact, it is not without reason that up to the present time the name of history has been given to the description, or at least to certain parts of the description of nature. Take physical geography as a term of comparison. When we look at a terrestrial globe on which the contours of the continents and oceans are outlined, as though they had been arrested during the course of the latest revolution of our planet, as a result of the concourse of a multitude of causes having an extremely variable sphere of influence and degree of generality or particularity, we are impressed at first only by the capricious irregularities we see. Then after a more attentive examination certain general traits, certain remarkable conformities or resemblances in the articulations or of the terminations of the continents stand out. 6. To what extent are these resemblances fortuitous? To what extent can they be imputed to the action of a general cause? In its answer to such a question the mind hesitates more or less depending upon whether it is more circumspect or bolder. Facts of the same sort are too few in number to allow the elimination of accidental and disturbing causes to be made with certainty. Statistics are inapplicable, truly scientific theory is not possible, but philosophical induction must not be neglected on that account. One passes from pure description, which is not a science, which is applicable to a kind of understanding comparable in all respects to historical understanding and to facts which can be explained only through historical precedents. One passes from that, we say, to philosophical speculation, and the force of things leads to it, omisso medio, without passing through the intermediary of scientific formulations. Descriptive natural science need not be confused with natural history. Descriptive anatomy is a science, for it uses classifications and systematic connections which principally bring into relief the general and constant laws of organic structure, of conditions of organic unity and harmony, and not accidental facts and precedents for which history would furnish the key. If observation of the facts leads T6 a philosophy of anatomy, it leads to it or should lead to it only mediately, after the data have been subjected to the scientific coordination of which they are capable. On the other hand, in matters which relate to the geographic distribution of animals and plants, the grouping of mineral substances in rocks and veins, the distribution of the heavenly bodies and of their orbits in the tremendous expanse of space, and many other subjects that we cannot even mention, there is a multitude of facts the reason for which is purely historical, facts which are connected with one another historically and not scientifically, facts which philosophy arranges in groups, as it does all facts of history properly so called, on the basis of probable inferences, but without being able to submit them to precise laws capable of experimental verification, as is possible in the case of the facts which serve as the basis for the positive sciences. Consequently, a natural history of the heavens and the stars will find its place side by side with the history of universal gravitation, a natural history of the earth, the strata, the rocks, the veins of ore, and the distribution of minerals over the surface of the earth will find its place side by side with physics, chemistry, and crystallography. Finally, a natural history of plants and animals will find its place side by side with plant and animal physiology. These types will often be confused in monographs and in didactic writings, but at other times the distinction between them will be well marked. And even though the confusion were inevitable, reason would still have to grasp the principle of generic distinction, if it is to have a philosophical understanding of the whole. Chapter XXI. On the contrast of science and philos. OPHY, and on the philosophy of the sciences. 320. Let us put aside for a moment all the theoretical considerations which have been the object of this book up to this point. Let us run over rapidly in our thinking the historical picture of the development of the human mind. However little attention we give to the matter, we shall be struck by the contrast that this picture presents to us between those two orders of speculation that, in ordinary language, when we are not aiming at positive precision, we agree to designate under the names of science and philosophy. Science starts from certain elementary notions common to all men, and combines them to form a body of doctrine by means of the forces of reason alone, or rather, gathers together observations and experiments by means of which we are able to advance to the discovery of the laws to which certain phenomena are submitted. Philosophy has to do with the origin of our knowledge, with the principles of certainty, and seeks to make its way into the reason for the facts upon which the structure of the positive sciences rests. The development of the sciences is essentially progressive. New facts which they establish serve as a point of departure for the discovery of others. The only things in them that are likely to perish are their methods and systems, that is to say, the artificial bonds which are posited to make possible the coordination of facts whose natural connection still escapes us. Except for this, nothing limits the acquisitions they can make. The combinations of abstract notions are without number, the domain of nature will never be exhausted by man, and the work of observers tends constantly to enlarge our idea of its immensity and infinite variety. On the contrary, philosophical speculations are hedged in by a circle of problems which, under diverse forms, always remain basically the same. Even as they presented themselves vaguely to thoughtful minds during earlier periods of human history, so they still present themselves, though more clearly expressed, to the enlightened minds of the luminaries of modern science, refined by the cultivation of literature and the arts. Man has it in his blood to pursue incessantly the solution of these mysterious questions, which are all of pressing interest to him, and whether or not he is able to attain his carrot end, there is a secret pleasure connected with the efforts he makes to approach it. His thinking is improved by making a thorough examination of the conditions of an insoluble problem, as it is by actually solving a scientific problem or by discovering a new being or by determining the law of a series of phenomena. When we speak here of man in general, it is clearly understood that we have in mind only those for whom philosophical meditations constitute an intellectual need. Such men have lived in all periods of the history of culture. No doubt there are many persons for whom this need does not exist, either because of a lack of culture or as a result of natural inclinations. There are some whose philosophy consists in scorning all philosophical speculation, and who repeat, after Montaigne, that it deals with matters which are beyond our reach. Ignorance and lack of curiosity are two very soft pillows for a good head. But a person who has spent his life weighing the opinions of the philosophers in the balance of doubt is a long way from furnishing an example of this repose of ignorance and lack of curiosity. As Madame de Staël put it, to those who ask you of what use philosophy is, reply confidently, of what use is anything that is not philosophy. 321. Originally the human mind had only an obscure consciousness of its different faculties. It has succeeded only gradually in separating them, classifying them, and at one time recognizing their independence, at another time their subordination. We see that religion, morality, civil legislation, philosophy, and science have been confused during the infancy of all civilizations, and no one would venture to say that the struggle for the emancipation of the domination of one or of the other is definitely ended. Should we then be surprised if certain persons still tend to confuse philosophy with science even in our own day? And, it must be. 464. Said, today this tendency should be attributed not to scientists but to philosophers. The positive sciences have acquired such a great brilliance, they have rendered such indubitable services to humanity, that it is natural enough to want to gain public goodwill toward the speculations of philosophers by claiming the name of science for them. Some treat philosophy as the science par excellence, other more modest persons wish at least to think of philosophy as a science or as a system of independent and autonomous sciences, as certain, as positive, and as progressive in their nature as others may be, and which will be seen to be such just as soon as those who cultivate them use the correct method. These pretensions are not new. It has long been the case that in their prolegomena, nearly all philosophers have presented philosophy as a science poorly fashioned prior to their time and now waiting to be constructed. To them has fallen the task of pulling down the poor constructions, of clearing the ground, of setting up the plan, and of laying the foundations. That of their successors would consist in carrying through the execution of the plan and of going on with the building. But unfortunately, those who follow them have not resigned themselves to this modest role of continuators. These latter could not resist, any more than their predecessors could, the temptation to alter the plans and to rebuild the structure from the ground up. So Voltaire was able to say that metaphysics consists of things that everyone knows and of things that no one will ever know. Yet this did not keep him from busying himself with metaphysics throughout his whole life. Without being Voltaire's, many discerning minds who have not gone deeply enough into the reason for these continual alterations must have conceived little esteem for a body of learning which is always being remade, and the principles of which are perpetually being brought into question. They have ceased to consider it as a true science, and in this they have been well advised. But they have gone further, they have regarded the field of philosophic speculation with disdain as a sterile field. Seeing clearly that philosophy is not a science, as most philosophers pretend, they have concluded that philosophy is not. If the errors of man were able to prevail against the laws of his nature, the human mind would tend to be maimed by having one of its nobler faculties condemned to inaction or to impotency. As a matter of fact, it is by no means necessary to conclude that philosophy is beyond the possibility of general improvement just because it does not have the same sort of progressive development as the sciences. There is no question that the germ of all the most important problems is found in the obscure texts of the Brahmans, beneath the bizarre symbols of the Egyptian priests, in the subtle dialectics of the Greeks, and beneath the dry argumentation of the scholastics. Nevertheless, philosophy has made some progress, at least in this sense, that its problems are more clearly stated, its difficulties better classified, and their subordination better established, that systems are recognized as belonging to generic types, that their mutual connection and affinities can be traced, that their probabilities can be weighed, and that the scope of the conclusions they involve can be estimated exactly. Philosophy still proceeds by the method of exclusion. If it cannot reach the solution of problems directly, it may be able, by an analysis which is often rigorous, to indicate the reason why these problems are insoluble or are amenable to a number of solutions which are either limited or indefinite. It shows the impossibility of certain solutions by establishing their incompatibility either with the data of science, or with the native wisdom and understanding of humanity. In this way it circumscribes the intermination of a problem that the nature of things has not made amenable to a determinate and truly scientific solution. 322. Another error into which men have fallen by failing to discern the essential characteristics which distinguish philosophical speculation from the positive sciences consists in comparing them from the point of view of the difficulties they present. Thus philosophy, under the name of metaphysics, has been regarded by the unlearned as the realm of those abstractions which are most